But this is going to be negative.
Yeah, that's true. Yeah.
So the vector wasn't actually pointing up, but it was pointing. Sorry, the vector wasn't pointing to the right; it was pointing to the left because that's negative.
Yeah.
So it's something like this, right?
Interesting.
Not coincidentally, this arrow fits right here.
Oh wow!
I didn't meet the right value, but
yeah, it's not one to one, but yeah, I mean it would be though if it was the actual size, yeah, the actual vector. But yeah, I get what you're getting at.
So the difference between the vectors is actually what points from one to the other one. So if you make the sun minus the earth, you get this vector. If a vector already points at the direction of the sun, and the length of this vector is the distance between those, right?
That's true. Yeah.
Okay.
Hey, in my defense, my friend, when you first presented this, my interpretation was the 3 points, which is the sun, the moon, and the third vector and the point. That's why I was like, oh, he's talking about 3 different vectors, But it's the same thing, only in reverse. You are the point, and the vectors are these. I mean, a great little graph. Is that paint?
Fair enough.
Oh, you know what? Hold on. Yeah, that's interesting. Wow. Okay. Yeah, because. Yeah, that would be the vector. Yeah, because the whole what do you call it? Pythagorean theorem. That would be the fucking hypotenuse of the triangle. So that yeah, that's interesting.
Exactly. The length of this vector is
beautiful presentation there, brother.
Wow. Okay.
Well, thank you. Anyway, so this arrow here is where gravity points at, isn't it? Like it's where Earth is going to be accelerated. But the length of that arrow doesn't mean how strong the Earth is being attracted to the sun. If you can just use that as an acceleration, right? It's a distance. But you can resize this arrow. You can make this arrow the exact length of the acceleration of gravity. Do you know how to resize vectors?
What are we like multipliers by like a scale, like a number thingy?
I don't know. If I want to. Yeah. So let's say I get the length of the vector. That tells me the distance. So that's my the length of the vector is my distance. Now I can use that for the equation of gravity. So the g constant times the mass of the Earth times the mass of the Sun divided by d squared is going to give me the acceleration force, right, between the Earth and the Sun.
Okay.
Correct.
I guess so. I'm not too knowledgeable on that, but
yeah. Literally showing you guys why you see the eye of the pyramid everywhere, because it's perspective and based on your position and the vectors of the positions that you're observing.
Perspective.
This is the formula for the general gravitation in Newtonian mechanics, right? M1 times M2 times G over d squared gives you the force of gravity, right?
Yeah.
So you know the strength of the force. This is the magnitude. This is not the vector, right? This is a scalar. It's not a vector. Okay.
Oh, I think I see what's going on here now. I think.
Yeah,
the distance force already gives you that, and then you multiply that by that. I think.
Yeah. Well, we'll get there. The force isn't like the force alone doesn't mean anything. We still needs to the force doesn't tell me how much that thing is going to move if I don't know the mass of it. Right? The same force applied to a lighter mass is going to move more. It's going to accelerate more than a bigger mass. So how do you turn force into acceleration using the mass of the object?
Well, my brain just okay. We said how you turn force into acceleration.
Yes, you have a force that you're applying to an object, and you also have the mass of the object. What is the resulting acceleration on this?
Resulting acceleration. Maybe reword that. I'm not exactly sure what you mean. Would you?
Well, you know F equals AM.
F equals A. I do not. I do. I'm telling you, I really. This is like, yeah. I haven't really.
Okay, so.
Bam.
Force is energy.
Yeah, if you apply 1 Newton of force and 1 kilogram of object, it's going to accelerate 1 meter per second, right?
Oh, okay.
If you apply 2 newtons of force to that same mass, it's going to accelerate 2 meters per second squared. Ooh. But if you apply the same 2 newtons of force to an object that has a half a kilogram, it's going to accelerate 4 meters per second. So you get that the acceleration is proportional to the force, but it's inversely proportional to the mass. So the bigger the mass, the less it accelerates. But the bigger the force, the more it accelerates. So if you divide the force by the mass, you get the acceleration.
Okay.
Or you can just rearrange this.
Wait. Can I correct you on that?
Okay.
You said that maybe it's my portrait. Maybe it's just my interpretation, but I keep hearing the word the acceleration is always going to be constant, regardless of the mass.
That's what I was going to add in. How you
are you talking about free fall, or what scenario are you talking about?
Well,
yes.
That's where
we're talking about orbits.
Then if it's orbits, oh, okay, sorry.
Yeah.
We can't even talk about free fall other variables, dude. Just let him present. He's presenting.
The misconception usually says if you have more mass, then it should have more force because that's the weight, so it should accelerate more. The fact that it has more mass, the equation says that you have more mass, you have more force proportionally, so the acceleration stays the same, and that's where it goes into the new.
Well, then you have resistance and air, vapor, water vapor, density, refraction, all that kind of stuff. Just let him finish.
Just the equation itself allows you to say if I have 9.8 newtons, that's the weight of something. Weight. It's going to accelerate at 9.8 meters per second squared.
Mm-hmm.
In a vacuum chamber.
In a vacuum, but it has 1 kilogram. Let's say it's let's say it's 9. It says 1 kilogram. No, it's going to be 1 kilogram.
That all changes based on density. Like it depends on where you're doing it. If this is in a vacuum chamber and you can verify that, it's all solid.
We get the vacuum chamber. I'll get to that in a second. So we have 2 kilograms. Well, you have more mass, but you have force, so the acceleration still stays at 9.8 meters per second.
I was just trying to focus on the simplicity of this demonstration. He didn't bring in resistance and air, vapor, and all density and all that kind of stuff. Let's just look at the basics of what he's showing here.
So then that tells you that you know that if there's any other forces acting on it, well, that'll slow the acceleration. That'll lower the acceleration rate. So
but we have to start with what he's showing. He's just showing a baseline of this is how it's all measured. If you want to throw in density and resistance and all that stuff later, cool. But this is the basis.
The basics. If you have 9.8 kilograms, that'll have 9.8 meters per second acceleration because you have 9.8 newtons of force acting on it.
Depends on the environment, where you do the experiment.
No, that's what it has. That's what you measure. That is true. Once you add
if you don't mind, Zenik.
Add a medium like water, for example. Water you'll have a viscosity.
Here we go.
Have a drag. Hold on. Let me finish the sentence and you'll get it. So let's say it's air. Air is easier to understand. We have a frontal area and we have a drag coefficient. We can measure that drag coefficient of an object very easily. And it's scalable too. So we have something model, big airplane, they're close. So we can measure that drag coefficient and multiply it times its area and get
When you're talking about drag and density, let's just focus on what he's showing, the simple vectors and
that's what you asked about. So we take that frontal area, we multiply times the coefficient of drag, and then we get actually a force, a value in newtons of how much that object will act on that medium, and the medium acting on that object in terms of force. And that force will take away from the force that's trying to accelerate it. Even if we were to do it in Newtonian realm, if we have 1 newton of force and we have 9.8 newtons of a weight, then we know that it only have a 8.8 newtons of force acting down, so the acceleration will be less.
What you're saying is based on the environment. What he's showing in this presentation in simple paint is the basis. So that's what I want to focus on because it's a very interesting presentation. You're trying to throw in all these other variables that.
No, you did. You said, what about the medium? I said.
No, I'm just assuming that we're in a vacuum chamber because he's showing us the simple mechanics of how that would work. Now, if you want to talk about density later and all that stuff, cool, whatever.
Hey, Zenik, leave the guy alone. I mean,
why is he being like this?
Oh.
Well, if you don't mind, I would like to continue.
Right, yeah.
No,
just I went over that with somebody else earlier. I thought it might be fresh in my mind. It was an easy confusion. In the physics.
Zanuck, I think somebody's in the middle of their presentation. Just so you know.
Presentation. I didn't realize. Oh, I didn't see your live thing. Go ahead.
It's okay. It's okay.
All right, back to it. Okay, what are we doing here?
Yeah. Back to the thingy thing.
Yes, please.
All right. So, okay, you got the acceleration of the Earth towards the Sun, right?
Okay.
And if you flip this vector, no, ignore what I just said. If you want to know the acceleration from the Sun to the Earth, it's the same thing. It's the same force, but it's now divided by the mass of the Sun instead of the mass of the Earth.
All right.
So they're both going to accelerate towards each other, but at a different rate with the same force, because the force in Newtonian mechanics, the force is not one-sided. It's always mutual, right? You don't have a force on one object. You have a force between objects, right? So, yeah, but the Sun's going to, of course, move a lot less than the Earth because it's a lot more massive. So
yeah. That is true.
You gotta divide their force by the mass of each to get the acceleration of each. But both accelerations are going to be towards each other, right? So let's focus on the Earth first. We got the acceleration of the Earth. We firstly subtracted their positions, and we end up with this vector. And then we got the length of the vector that tells us the distance. We apply to the Newton's equation to get the force, and we divide the force by the mass of the Earth to get the acceleration. So far, so good, right? Okay. So now we need a vector for the acceleration. We already have a vector that points in the direction of the acceleration, which is this gray arrow here, right? This arrow points in the direction in which the Earth is going to accelerate.
Yes.
But the problem is the magnitude of this arrow is not the magnitude of the acceleration.
Yeah.
So one trick you can do is first turn this arrow, this vector, into a unit vector. You know what a unit vector is?
Oh no, I don't. Like I said, I'm not familiar with this vocabulary.
It's pretty simple. A unit vector is simply a vector with length 1. That's it, right?
Length 1. What's that?
Whatever you want to make.
The length of so, for example, let's take the vector xy 0, 1. What's the length of this vector?
Oh, that would be it would just be 1 because there's no
Exactly. That's a unit vector. What about 1 over the square root of 2 and 1 over the square root of 2?
That would be. Hold on. I'm pretty sure it's very simple.
That'd be a half.
Is it just half?
No, do yourself. Do yourself, Arma.
Okay, hold on. Give me a second.
Oh wait, no, I'm an idiot. Sorry.
That's great. I'm sure this is really simple. I'm pretty sure it's like you do like a thing about I'm like, oh, hold on. It's gonna take me at least 2 minutes. You got time for that?
It'd be 1/2 plus a 1/2, which would be a 1. That'd be a 1.
Well, hold on. Wait, hold on. Oh, wait, hold on. Wait, actually, yeah, because it's a Pythagorean theorem, so I'll just do.
Yeah, you squared both of them.
Yeah,
you
so
get
it'd be
1/2 each. You add them. You get 1. You take the square root. That's still 1.
Yeah, there you go.
Don't feel bad. I fucked up when I said a half. So
No problem. It was fixed. Okay, so this is also a unit vector, right? Because the length of this vector is 1. And the beauty of a unit vector is that if you multiply by, let's say, 7, that vector is going to grow in the same direction that it's already pointing, but now the length is going to be 7. So you can first divide this arrow by its own length, and that's going to turn that vector into a unit vector. Does that make sense?
I think so. That sounds right. Yeah.
Right. So, for example,
by right, I mean it sounds like it. Yeah. That's yeah.
Yeah. Yeah. If the length of the vector is 2, and you divide all the components by 2, you end up with a vector with length 1. Right.
Yeah.
Okay. So this is what you do with this vector here. you pick that vector, the gray vector that we were calling v, and what we're going to do is we're going to divide the vector v by d, which is the length of the vector. That's going to result on a unit vector that points in the same direction of this vector.
D. Wait, what was D again? That was what?
D is the distance between the Earth and the Sun. The length of the gray vector.
Right.
Okay, I'll pick the purple color here. Actually, I think a unit vector looks like a black vector. It's too simple to be any other colors.
Hey, Bacon, just a quick question. What is the goal here?
I'm explaining how he can simulate an n-body system without using trig functions.
Just use that universal law of gravity and you're done.
Yeah, that's pretty much what I'm trying to get to. He also used it, but he used trig functions to get the motion of the bodies.
The motion? Oh, that's gonna be hard ass math if you're gonna talk about orbits and stuff.
Yeah, if you're using trig,
n-body orbits.
Yeah, say that again. What was that? Said what? Was it Kosho?
No, I was just letting him know that you had said you're showing him how to do n-body orbits. So obviously that's going to involve orbits, right?
Yeah. Well, if you want me to shut up, please let me know, and I'll happily shut up out of respect.
Well, you're welcome to contribute.
And by the way, afterwards, Bacon, can I quickly show you? After this is done, can I show you how I did it? And maybe you already understand it, but just real fast afterwards, can I show you what I did? My logic.
I didn't understand, so yeah.
Okay. Because for all I know, I'm pretty sure it's correct. But just in case, I'm gonna show you, and you judge it. Be like, okay, that's right or wrong.
Okay. So we have this a here is the magnitude of the acceleration, right?
Yes. But
and this u here, go ahead.
No, yeah, go on.
And u here is now the direction of the acceleration.
Yes.
So if you multiply u by a, the vector u is still going to point to the sun, but the length of the vector now is going to be exactly how much the Earth has to accelerate. So the x of this multiplication is how much the Earth has to accelerate in the y-axis. Oh, sorry, in the x-axis.
Okay.
And y of the resulting vector here is how much the Earth has to accelerate in the y-axis. So now you can accelerate the Earth in the x and y axis without using any trig. That's already how much you have to accelerate the Earth.
Oh wow!
In each of the axes.
Wow, look at that.
So, for example, we have a vx, which is the velocity of the Earth. You have a vy. So what you're going to do is vx. You're going to add the acceleration, which is this x here,
plus equals
times your what you call time, right? Which is your delta t.
Mm-hmm.
This is how you update the velocity of the Earth in the x-axis, and this is how you update the velocity of the Earth in the y-axis.
Oh wow! All right, look at that.
Simple multiplying, dividing, and that's it.
I didn't even think it was possible, but it obviously is. And okay, yeah, because I did it a totally different way, but that actually does make sense though. When you subtracted the sun and the the Earth's x and y positions, whatever, and then you get that that vector, which is pretty cool.
Yeah, and for the position, you just add the velocity again times time.
Bacon, how many times are you updating it in a second?
Me?
Yeah, I guess. Yeah, I forgot. You just not the one you made, but the one you made at least, the one you made a while back. How you said you were updating it how many times a second?
Arma?
What's up?
How many times a second?
Someone's snoring in the background. I think they're bored.
Oh, it's here. Sorry.
Yeah, you gotta determine the resolution because obviously if you have like a, let's say like near infinite resolution, you're updating it. I don't know, near infinitely times a second, which is not possible. Then you would end up with like a perfect description of an body orbit. But so it's going to be limited by how often you're updating it.
Yep. The smaller you make the time variable, and the more you update, like it's not actually how many times a second you update, but the size of your time variable there.
Oh.
The smaller the time variable gets, the smaller are your increments, and the more precise it gets.
That actually makes sense, because whenever I speed up my thing, sometimes it'll like the orbit will be off or whatever. So like, that's interesting. That kind of makes sense.
You speed up, you mean like making time bigger?
Well, what I'll do is like I'll actually like hold on. Let me actually what does my code say exactly? So what I do is I speed it up. So what I'm doing is I'm actually making the movement like faster. So it's the h speed and then time speed. So what's happening is it's just like it's jumping. Yeah, it's jumping instead of doing from like instead of the vector being like, for example, I don't know, like what was the one thing you called? What was the one thing called the one vector? Where it's just one number, like univector. Yeah. So instead of it just being like, I don't know, like 3, for example, it'll be like times 10, so it'll be 30. So it's there's less precision because you're just it's jumping to
Yep.
Yeah. So I noticed that whenever I speed up my thing, it is a little less precise. Well, okay, that's interesting though. Look at that. I did it like, I mean, the same thing is there technically, like the same like like the whole vector direction or whatever, but it's just like I did it in a different way. I guess I could try to draw it out maybe to explain it, because I'm not good with words. I'll be honest. Just never have been. Yeah, let me real fast show you what I did real fast, or at least attempt to, because I don't know if I,
You use trigonometry to determine the distance.
Yeah, basically, the distance, and like I did like, let me see.
And that fisheye lenses might warp your trigonometry based on your perspective.
No, we're not talking about the lens anymore. We're talking about something else.
No, but he just laid it out. That's what you guys started with when I joined.
Yeah,
and
but
he just literally laid it out with a very simple vector graph of how a fisheye lens and density, like the other guy, what was his name, Zanuck or something. He came in and said that he was talking about water density and da 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 da. But what the dude laid out was exactly what you guys were talking about when I came in, like, I don't know, 90 minutes ago, whatever. You're talking lenses and cameras, perspective. But he just showed you, and then somebody, I don't know if it was you, but somebody else was talking about how trigonometry can't be applied to certain images because of the lenses and yada yada yada. So what Bacon did is he showed you basically the metrics and the math and the trig that all of that stuff is based on.
no.
You would have to admit that applying those vectors from those perspectives and that single point of perspective, that some kind of medium like water vapor or maybe a fisheye lens or a non-binocular scope that we use to do these measurements with cameras, there would be some warping. So you have to adjust based on that point. Like if you pull up Bacon's graph, where those 3 vectors converge, that's your point of perspective.
Wait, what Bacon graph? What graph are you talking about?
Yeah.
What he was sharing a minute ago.
Well, that's not.
He means
the whole time.
Yeah.
I just thought that was beautiful, guys.
But that was about orbits. So how's? I mean, I know there's lines and shit with perspective, but I don't think that's the same thing though.
Yeah, this can be nipped in the butt fairly quickly in less than a sentence. And I was trying to say this, but you guys were going on for a long time. Based on the claim that was being made about the perspective thing, all you got to do is have somebody provide a single observation taken where the person has 2 different types of optics, maybe 3, maybe more, and is taking the same image at the same time of the same thing, and showing that in some of those images the sun is hidden by the horizon, and in other ones it's not.
If you guys want, we can go to different rooms, and then because they're talking about 2 different things.
Hold on. Wait, I'm trying to figure out what the fuck I'm doing right now. Hold on, give me some. What the fuck?
Well, yeah, let's pretend that your trig functions already work with degrees, so we
Wait,
don't have to keep...
hold on. Let me try and help out. Draw your where. Okay.
Well, actually, I can
draw the triangle that you're basing that. That's X, right? And
yeah, hold
y
on.
is the vertical distance.
Yeah. So it's like, so it's
Just
like
so you don't get confused.
Oh, what information do you have? What information do you have for each body?
hold on.
Okay, you're fucked. Wait, you fucked up there. Other way.
Oh yeah, my bad. What the fuck am I doing? I'm sorry. Yeah, I'm sorry. My brain is like it's mush right now.
I know. I get it.
Yeah, there you go. Yeah,
Yeah,
that's
see, that's
the
what I
why.
thought. That's what I thought you were doing. But you're
would
using
be-
circular orbits. You're not using elliptical ones, right?
What you mean?
I'm just curious. Like when you're doing this, were you using elliptical orbits, or were you using just like a simple
He
circular
was
orbit?
just doing it in body system. I think it's going to be your.
Yeah, here's my code
It's
real
going to be
fast.
elliptical if,
Yeah,
if
I'll
it's
throw
not
in my code here. Let me just grab this.
Can you zoom in a little bit?
Oh yeah, let me real fast. Yeah, move all this first. So I gotta move all this.
So you're putting the sun in the origin, right? Is that where you're putting the sun?
Something like that. Yeah. Okay. Hold on. So hold on. Me real fast. Also scale this up. Let me resize to 200. So it's.
Oh, then you're done. All you need to do is say that. Actually, I think the if you're
Actually,
gonna,
hold on. Not that code. Let me get another one. Hold on. Yeah, go on.
If you're
You should
talking about
post that one
Jesus
again,
Christ,
then I'm gonna look at it.
can't even talk. If you're trying to make a circular orbit, keep in mind that the gravity or the acceleration is going to be a constant value all throughout. So that never changes. That's just going to be the magnitude. That's just going to be the radius.
I see.
So just say GM1, M2, two masses over the R square, the D, and get that value, and that's your constant. And multiply that by cosine of theta changes, and y multiply it by cosine of theta. Those are your parametric functions, and then you're done. That's all.
Well, I mean, okay. Okay. Well, hold on. I don't know why I had it like
that's it. That's it. That's it.
Yeah,
that's
but no, but to be fair though, like I wasn't like when I made this, I was literally just trying to see if I can like put what Bacon was saying into like code because there was one argument we had with what's his name, Gregory, and Bacon was just describing like how you can accelerate towards something without actually moving towards it. And I was just trying to replicate that, and I accidentally
it accelerates, it changes the direction, but that's it.
Yeah, hold on.
But that's the magnitude right there. Those are your vectors, x and y.
Yeah, hold on. 150. Let's do 150. Okay. So yeah, here's my code. So we have.
I'm not familiar with that.
Yeah, don't worry about it. I'll explain. So this is poopy code. Not poopy code. Well, it's poopy code, but it's also poopy language. Don't worry about it. All right, I'll explain it. It's pretty self-explanatory, but whatever. So basically, I have this little thing in the beginning because I don't want the fucking thing to crash if I don't have the sun. And anyway, point is, checks if the sun is existing. All right, and then it's all like, okay, hey. In fact, I can get rid of all that. Let's just fucking. Here you go. You don't even need to worry about that because that's not important. So here's the actual.
I mean, if the sun is not existing, why bother, right?
Yeah. Okay. So anyway, yeah, don't worry about it, right? So yeah, so grab sun, right? It's just don't worry about that. It's just gravity, all right? So the gravity, I have it as just the object sun dot mass. Once again, it doesn't have to be that correct. Right? Don't even worry about this right now. This is just my simple version of it. All you need to know right now is that this is the gravity speed, right? So I'm just going to change this to the strength of gravity. So gravity strength thing. All right, that's all you need to know right now.
I see what you did now.
You don't have to delete. Was that the distance between the Earth and the Sun, or is that for all objects? Is this code just for the Earth or for all objects?
Oh yeah, this is just for the Sun. I don't know why I named the distance. I guess because let me see. Hold on, I got distance, and then yeah, it's just for the Sun because unfortunately I didn't do any like complicated code for the Earth or the planet, whatever. But for the Moon though, the Moon does have it pretty much attracts to multiple moons and shit. But for the Earth, I literally just have it the Earth and Sun attracting each other or some shit like that. So there's only one distance. It doesn't attract to the moon right now because I got lazy, so I just wanted to do like 1-on-1, just two bodies. So I have it, just the distance from the sun or whatever, right? And that math is somewhere else, but don't worry about that. So that's the distance between the distance from the sun, and then I take where is it? Where the fuck is it actually? Where does the distance? Oh, right. So the gravity. Right. So then I take, where is it? Deg to red. Okay. So that's the degree. All right. Because there's the angle to the sun. Right. And then.
No, I don't see that, right?
Wait, what?
I only see paint.
Wait, you don't see
the bottom corner? The bottom corner, bottom right.
Yeah, right here. Wait, what the fuck's happening? Hold on.
Maybe you got to open up You gotta open up like the.
I think you're only sharing paint.
Wait,
no, he's got the code at the bottom of his paint.
Wait,
it's on the bottom right.
Wait, he was putting the mouse where there was nothing.
Oh, you know what? It might be a scaling issue. Hold on. It might be because I have I'm doing this on my drawing tablet, which is 1920 by 1080, so it's a different. Yeah, my bad. Hold on.
Just move the code upwards because I mean, like I can see it.
Here we go.
No, I could also see it, but I thought he was doing that on a different window.
Yeah, it's weird. I'm sorry. You know what? I got a better idea. How about this? I'll just.
It was fine. I mean, if you were not in another window, then it's my bad. I'm just.
I'll just underline it. See, so you know where mouse is. So here we go. This right here. So there we go. Bam. All right. So we have the degree right here.
It makes sense now because your mouse is up in the top of the screen.
Yeah, it's weird.
But when you draw, it's on the bottom. That's weird.
Yeah, it's a resolution thing because my tablet has a greater resolution than my other monitors. But anyway, so here's the degree. Here's the thingy, right? So what I'm doing here basically is I'm getting, I'm taking basically, with this, right? I'm going to be moving X amount, right? So let's say, for example, this is like 5, and let's say this is, we do it, whatever. Let's say this is 5, and let's say this is like 7, right? I forgot what exactly, but the long story short though is by getting that angle, the 135, actually that would be the same. Actually, it would just be 5 and 5, but whatever. The point is you don't have to worry about that, right? So let's just say 5 and 5, right? So 5 and 5, because that's a 45-degree angle, so it should be the same. But anyway, the point I'm trying to get at is what happens here is I take the cosine, all right, and because it's 135, whatever, you should get. You should get the right amount of h speed for that, and then you multiply that by the graph sun, right? Graph sun would be just the gravity here, right? So that gives you the strength of the thingy, right? So it'd be like, remember that whole thing, but like whatever. Anyway, and then was it times object? So that one, that's the object that controls the time speed or whatever.
You get the angle first, so you can then apply like sine and cosine to get the. I get it.
Yeah.
That's just you're just scaling the vector in a very inefficient way.
Yeah, in a really weird way. Yeah, I know. It's just.
So, can I see how you calculate the distance?
Oh yeah, sure.
Where's the angle? Where's the angle being updated at though?
The angle?
Is there a different part of the code?
Yeah, it's a different part of the code.
I think he's calculating all the time.
Yeah. I was just wondering. You maybe not showing that part of the screen.
I'm guessing you're using cosine or arc sine or arc cosine.
Hold on, how do I? Oh shit! Hold on, I didn't mean to run the program. I'm trying to increase the scale of the fucking text. No, that's not what I want. Hold on, give me 2 seconds.
I can see all the text. I can see all the text.
Here we go.
In
fact, let me do even better. I can raise the. There you go. Well, actually, that's not going to matter because whatever. Okay, whatever. Point is, So where's my math? Okay, so we have angle 2. That's my function. Hold on, let me see. So what did I do here? So instance exists true.
It's a global variable instead of returning it. Is that what it is?
Hold on, give me a second. I need to figure this out. Because I didn't really whatever. So angle 2. I think I used angle 2. This program's weird. I did it in a really weird way, but basically, it's like a function, but I put stuff in and it doesn't return. It just kind of.
It's the global variable degree, right?
Yeah, basically, yeah. It updates.
Where is that though?
So hold on. So angle. So hold on. Angle 2. It would be.
I ask him hard questions. He's lost.
Hold on, I'm sorry. Yeah, so angle 2 is right here. This is my little function I made.
You have multiple scripts, I see.
Yeah. I did it really stupidly, but whatever. It is what it is, right? And don't worry. The what now?
That's actually good. It's neater to do it that way, yeah.
Yeah, so I did. Don't worry about the bottom part. This was experimental, so don't even worry about that. But it does work, though. But don't even worry about that.
If you're converting things to degree and then you're deconverting them to radians all the time, you could just work with radians.
Yeah,
but
Bacon's obsessed with radians, dude.
I
don't know. It's just a logical thing to do.
You're probably right, but I haven't like learned like radians exactly, so I just kind of
You
stick
don't
to.
have to. Just pretend they're degrees and it's going to work the same.
But I like my degrees though.
Okay. Oh yeah. For example, instead of converting the result of arctan into degrees, you could be converting the 90 to radians, and you can add them and it will work the same. And 9 is just half pi. 90 is just half pi.
Yeah, but once again, though, don't even look at this. This is experimental, all right? I'm a little. Yeah, don't even. It works though, but just experimental though. Because I was trying to like drop the code down even smaller because I have another like project I'm working on and I'm really trying to optimize it. So I was like, maybe I could do like less lines of code, whatever, and it kind of works, but it's a little weird. But I think it kind of pays off. I think it is slightly more optimized, but it's anyway. That's another topic. But anyway, so we got the var distance x, which is that's pretty much like the sun in the Earth, whatever. But that's the x and y is defined in the function earlier where you put the thing in. Anyway, you do that. Bam, bam, right, and then it goes.
Are those the coordinates of the Earth or the Sun?
It could be whichever one you want to put in. That's why I made it a function. So it's just So the Earth in this case.
He used it for the Earth.
What about X and Y?
Open source CAD, man? Are you like doing open source CAD? That's kind of what it looks like.
What now?
I think he said you're using.
I was like, what? Is this your own code you're writing for this?
Yeah, this is my code. Yeah, this is all my code. Yeah.
Right on, dude.
Yeah. But yeah,
basically Game Maker code.
Yeah, it's a Game Maker. So it's a weird hybrid like language between like what is it like C# and like JavaScript or some shit. It's a really weird, stupid hybrid. But I don't know. It gets the job done. Anyway,
I thought it was like basic, but yeah.
Yeah. Well, maybe it is. I don't know. But from what I've seen and from what I've messed with, it's kind of like a little bit like JavaScript. I think. I don't know. It's been a while.
No.
Or Java. Maybe it's one of those. It's one of those. Java something. I always get those confused. Don't worry about it. All right. It's one of those. But yeah, I know I offended you that one time, Bacon. I said like JavaScript or Java, and you were like, no, they're not the same.
Yeah. I hate Java and I love JavaScript. So if you confuse them, I'm gonna be angry. Go ahead.
But anyway,
I didn't throw that in there. I just thought it was cool. I was like, oh, this guy must be a Linux guy.
No. But anyway, you get the distance. Just all you have to know is that this is the distance math, right? You get the distance and angle math. So this one here,
I get why you're using sine and cosine. I mean, everything makes sense now to me.
Yeah, it's just really weird and probably unnecessary, but I'm proud of it though because I got it to work. And you just you said what you said that one debate, and I'm like, oh shit, let's fucking throw this together, and I did it.
Mm-hmm.
So
I'm proud of you.
Right.
Thank you. Yeah, I'm proud of me too. Like this shit's fucking cool. Like have you seen it, Kosho? Where I had like the fucking like moon?
I've seen it.
Yeah, shit was orbiting each other, like a bunch of shit just orbiting, and I was like, oh my god, it's fucking crazy.
Yeah.
Bacon's because n-body problems are they're interesting to it's interesting to see like what sort of system what sort of like phenomena come from that system. So it's like you can use an n-body problem to map out like eclipses and shit like that, like eclipses or tidal phases and stuff like that. So it's pretty interesting.
Yes. I probably won't be going in too much detail with this because once again, it was just a means of like putting it together. But maybe I'll expand this more and do more stuff with it.
If you're only updating in X and Y, how's that tree? Are the orbits all 2-dimensional?
Yeah, because this is 2D. This is all
Game Maker's 2-dimensional.
What about the moon? Oh, so that's when we were looking the moon to make those spirals. It wasn't like
No, it wasn't. It looked 3D, right? But no, because the trail kind of gives that effect.
I could say it was 3D. It makes sense now.
Yeah, let me see if I can.
Because if you're using 3D and X, Y, and Z, it would be much harder to do what you did to like use sine and cosine to resize the vectors. Well, not that much harder, but it'd be much harder to visualize.
Yeah, hold on, let me see if I can. Because it is a pretty looking thing. Wait, why?
Yeah,
is
at some
this not
point, Big, I
working?
want to show you this. I want to show you this dude that Jeremy put me onto. What's his name? Carl Monk or something like that. Anyways, he's like this fucking dude who's obsessed with like ancient structures, and he shows like how the math, the math has like hiding all these secrets in the construction. But dude, this guy, it's so crazy, dude. He is explaining these things and how they're connected, but he doesn't understand like basic math, and so he thinks like radians and radius mean the same thing for some reason, and so he's doing like he's
I
doing these
kind of do.
calculations. Yeah, I know, but no, they kind of do, but they don't in the way he's doing it. Like basically what he was doing was he was doing he was saying that the area of a circle is a constant, regardless of the size. Because he was
What?
multiplying. Yeah, he was multiplying radians
Oh, it
squared.
is in radians, right?
Yeah, but he's using the value for radians, like 57 point whatever degrees.
Mhm.
He's using that as radian, and then squaring that, and multiplying that by pi.
Yeah, that's the area of a circle in degrees.
Yeah, I know, but he's using that as the area, not in degrees. Even though he calls it degrees squared, he's actually talking about the actual area of it.
Right.
You'd have to see it to see what I'm saying, because he does this like weird funky math.
I'm going to be very frustrated watching it. Thank you. I pass.
It's like 5 hours long.
Are degrees ever curved?
Always.
You know, are degrees ever curved? They're always squared.
No, degrees are always curved.
Yeah, it's usually always curved.
Unless you're talking about degrees
I've never
Celsius.
seen one that was curved.
Well, if you're talking about like we were talking about spherical triangles the past few weeks, not talking about those anymore. But the spherical triangle has the angles that represent the angles along the surface, but even the distances, which are arcs, can be represented as angles as well, because they're arcs, right? So the angles on a circle or a sphere, they're going to represent arcs or curves.
Now we're talking about fisheye lenses again. I'm kidding. Let's see.
Oh, you almost caught me.
I need to figure out why this. Why is it running? What the hell? There's something wrong with I might have to restart. Whatever. I really wanted to show off the whole orbit thing, but I think Game Maker is broken right now. I don't know what the fuck's going on.
I made a lot of stuff with Game Maker, but it crashes a lot.
I mean, this is, so you don't think I'm like a, baby, like, coder guy, whatever. Because, I mean, I am, but, like, just so you think less of that. I did have not recently, but, like, kind of recently, maybe, like, a few months ago, I was messing with Unity. I showed Bacon. I was, like a little, like, Spyro fan game, like that, Spyro the Dragon. And I actually got, like, stuff to work in that. So, I mean, it's not hard, obviously. Like, I mean, like, I'm learning that, what is it, Sharp, I think, for Unity. So... yeah, I've actually done quite a few things. I've done like a whole, like a really like shitty, but it still works, like a shitty like collision system, and a bunch of other stuff. But I don't know, it's kind of cool. So I got to get back to doing that. It's fun, and maybe I could do a 3D simulation of the planets, because that'd be kind of cool to do too. I mean, it'll be the same thing for the most part, because it's, I imagine they only, the planets orbit in a plane. I mean. Now granted, the planes can be tilted, like some planes are tilted relative to other planes.
They usually always are.
But you could do whatever you want with what you got going on here, man. You make the planets whatever, and do this and that and this and the other,
Yeah, but I mean, I can only do the one plane though, because it's 2D. But I mean, I don't know, like that's all I really need, for me personally. But yeah, it would be cool to do like 3D, where you got some planes sort of tilted relative to other planes, and that would look kind of interesting.
You can do all that in Blender, and I know that you're familiar with Blender, but you can code all that in Blender too.
What languages does Blender use? Is it?
You use Python.
Python. Ooh, I don't even know. I haven't touched Python. I might have to.
Python is a lot neater than Game Maker.
Probably, yeah.
There's a lot less just junk.
Junk.
It's probably slower.
How long do you think it would take to speed run a n-body simulation in JavaScript?
What do you mean speed run it? Like just writing it straight out? I mean, you could probably write one in a couple minutes.
Yeah, I think so too.
Yeah, exactly. That's what you wanted. You wanted me to say. I don't know, 2 hours, maybe a day or 5 days. Oh, I could do it in a couple of minutes.
The setup. You just wanted to.
I was just gonna check if maybe Arm would want to see how to do the whole thing the way I explained, because that wouldn't.
Have you not done it? Like you I guess you've only done it in increments.
Explaining in a code that is already written, it's very boring.
Oh yeah.
Writing code live is much more fun to watch.
You know what you should do? We should add. You know, GPT-4 came out the other day. It's fucking crazy, dude.
Oh shit.
Okay, but enough about that for a second. You should, if you have access actually to the Chat GPT with the version, you can actually utilize GPT-4 already. Otherwise, you got to wait on the waiting list. But regardless, you should ask Chat GPT to fucking write that and see how quick it can write it. I'm gonna see if we can write it in Blender real quick.
Real fast. I'm gonna real fast troubleshoot this. Why the fuck is GameMaker not working right now?
But y'all haven't seen that GPT-4, and also Google's because they're fucking massively competing right now. So Google's gonna just unleash like their AI on all their products, like on Gmail, on Google Drive, and their spreadsheets, and their what do you call those? PowerPoint shit, like basically everything. It's gonna have their AI basically attached to it. So you just ask it to like write you a spreadsheet or write you a fucking PowerPoint, based on whatever you want to write it on. It'll make the whole PowerPoint for you.
Fucking interesting.
I'm sorry.
No, it's fine.
But you know how before. Go ahead, man.
I thought Arm was trying to communicate with my dog.
But you know how before, like, flyers were using ChatGPT to ask you questions and acting like, even though it says like we don't give you correct information, like don't trust information that comes from here. But GPT-4, it's going to actually probably do a lot better job at that, because whereas like ChatGPT failed like math tests and science tests and doesn't really know anything, GPT-3 or GPT-4 fucking it's like it adds like an intuition to it. It's crazy. So yeah, you should be able to like ask it like fucking anything, and it'll do a lot better job.
Interesting. We should ask it. Oh, is the Earth is it round or flat? Just to rub it in the the flat earthers' faces, because they'd be asking those stupid questions. So we could do the same. We'd be like, hey, this perspective cost. There you go. This perspective cost things that disappear bottom up. We should ask that. What? Someone do that actually. All right, start posting it in the fucking chat like they do.
It definitely does, dude. Over distance, yeah.
Well, maybe I can ask the AI, and see what it says. Right?
Ask the overlords.
Yes,
dude. This AI stuff is really. I don't think there's. Honestly, I think it's been blown out of proportion. It's just like a rejumbled information machine. It's just a code that pumps out information based on other information it has. It's not really anything like different.
No, but that's only if you use it to ask it questions, which is like that's the worst way to. I mean, it's not doesn't really highlight its capabilities, and it's going to give you wrong answer.
Yeah.
But if you tell it to like explain, like give me the plot to Pulp Fiction, and do it in one sentence, and make each word like an alphabetical order starting from A to Z, like it'll write you a sentence that makes sense in that exact format. It's crazy. GPT-4 at least. So it's just crazy how.
Yeah, but that's just like a code function. It's just a code function.
I mean,
uses words and a thesaurus and statistics, and within the thesaurus that it just pulls those, exactly what you're asking for. Like it has all that in its system. Like it has the alphabet, the numerical order of numbers, and so it's just categorizing it and then just pumping it out in a categorized way.
Yeah, I suppose you could do it just the way you described it.
Like it's not an intelligence outside of just whatever it's been programmed to do. It's just programmed to calculate and crunch, just like with blockchain. The way blockchains work and the algorithms that it has to solve. You know about that?
Oh yeah, hash functions.
Yeah. So yeah, those are very complex, and they're running through a massive amount of data in order to accomplish those. So these AIs are just like creatively programmed ways of jumbling information in a way that is able to be calculated and crunched.
Well, I mean, no, but they've been trained. They've been trained on this. So they're basically like predictive models that have been trained on a giant collection of the data. But there's a lot of there's a lot more that goes into how they're trained, though, and that's actually why they're letting so many people use all these models. Is because they're doing further training by doing that. But regardless, what was this? You said about the chat. Oh yeah, right. Yeah, right. So it's true what you said, that it's not intelligent. It's because it can't interpret anything, and it can't. It doesn't understand the semantics, and so it's not actually communicating anything to you. However, it is capable of, doing things that you can't just program it to do that. You can't automate it. Like you can't create something like this that was just automated. When you wrote the code for it, like that actually would require a lot more. I don't know. I don't even know what it would require. Because if you wanted to get it to write you a story, like it can write like full text now, GPT-4, and so trying to get try to automated bot to do that seems like it would be pretty difficult. But training the AI to do that based on like a prompt.
That's all it is a
bot.
No,
it's not. It's not just an automated. It's like it acts based on its training. So it's like it's true that the training was coded into it, and then it went through the training, but what came out of that was a product of that training, more so than just the coding. If that makes sense. Like for instance, the bot that beat that Japanese dude at Go actually never learned the rules of the game Go at all. It never learned any strategy or any rules or anything. It literally just played the game over and over and over again. So it was just trained over and over and over again. And through that training, it developed the best strategies.
Just like the chess one.
Right.
Actually, there's a single AI that plays the three games. It plays Shogi, chess, and Go. Yeah, there's isn't it Alpha Zero?
Alpha Go.
Three of them. There's Alpha Go, Alpha Zero, and Alpha Go Zero. I never remember which one is which. But their games are awesome. The games between Alpha Zero and Stockfish are awesome.
Well, I just think it was funny. Like I remember back in the day when Ken Jennings, the guy who won Jeopardy 74 times in a row, they had him and a couple other champions go up against Watson, IBM's AI. This was like 10 years ago or something like that, maybe 15. And Watson, it wasn't beating them at first. It was like neck and neck, but then it started beating them like handedly. But beating people at Jeopardy is a lot harder than beating people at chess or Go, because like there's logic and rules to those games, whereas Jeopardy it requires interpreting the questions or interpreting the clues and then giving the questions. He did a TED talk. I remember I saw that, and it was about how AI was going to take over everything. I was like, dude, the guy's he's so butthurt from losing to the robot. Like he's like afraid of AI now.
Yeah, but the horizon definitely can visually obscure things upon it that are on the surface.
Well, I mean, I wasn't trying to get into that. I was just being, like, what's the word?
Facetious. Well,
yeah, sure. I was just, yeah, because there's flat earthers, they'll be like, oh, what was it, lines curve or some shit? I don't know, in the fucking chat, whatever. So I was like, okay, let's make, let me just get back at that by typing that, typing the whole bottom up thing. Oh, sorry, my mic. But the bottom up thing, in perspective, with the AI, and see what they, what the AI tells us. But yeah, I wouldn't. Yeah, I'm not gonna get into.
What'd you think about my test though, Gio? The test I suggested, like if you had this person, let's say a person went up to like a mountain on the beach or something, and lined up like 3 cameras, like a P900, maybe 2 P900s, one with different zooms, and then also like a iPhone, and also like a Polaroid, I don't know, disposable camera. Who knows? Like whatever. There's like a whole bunch of different optics, and took pictures of the sunset. Would that be a test that would be able to conclude if optics and perspective can determine where the horizon is, or if the sun is going behind the horizon or not?
Could you say that again? Maybe in
okay. The claim is that perspective can do that. Can cause the sun to be behind the horizon. Like basically, perspective creates the horizon and can allow for the horizon to obstruct things like the sun, even though the sun's never going below the ground. Right? This is the claim.
Yeah. I mean, that is what's happening. Although I don't know that I would call that only perspective, but perspective is part of that. But I wouldn't just categorize it. It's not, because you said just perspective. So it's more than that actually causes that to occur. Because if you were looking out, like let's say there was no land at all, and you were just looking out into open space, quote unquote, not like NASA's outer space, but let's just say the Earth with no land or water. So you're just in this huge open thing. You wouldn't really get the same type of convergence of the ground and all that, because there isn't a ground. So you would just be seeing like, open space. But the fact that you're actually like on the ground on a planar surface, and then the fact that the sky is above that surface, and then there's an object in the sky above that surface, is what then starts to create that dynamic of the angles and the viewing points of those components. And then if you have something on the planar surface, like a boat or something like that is above it, well, then now you have something that is popping up higher than the planar surface. So depending on how the horizon is being constellated at that moment, you're going to get the visual effect of the visual obscuration from the bottom up.
All right, but so the way that I take that, like, let's throw the atmosphere out of it, just so we're not focused on what refraction could be doing. But the way I would imagine it is, if let's say you're not on Earth, you're in some void, and let's put whatever objects you want to put in this void, but there's just no ground. Then I would expect that the way it would enter your sight, like the image that would be formed, could be represented by lines to each of those objects, like lines that start from your eye and are angled at each object, such that you if you were looking at this orthogonally, you'd see like a cone with lines that are pointed at each object, right? And so based on where those lines are, if one of the lines is angled less than another object, then the other object's going to appear higher. Does that make sense? Like if the angle was 0, then it's going to be at eye level, and if it's 1 degree, then it's going to be 1 degree above eye level, and if it's if it's higher up, it's going to be a greater degree. Basically, this is how I would imagine it. And so, if I was looking at something that was higher than some other object, the angle was always greater than that other object. I would
yeah.
think.
But when the water, the point at which here's how my understanding of it though, the point at which the ground and the sky meet, that point changes. Just like if there's a bunch of fog out on the water, you know how like if the fog is close, you can only see like 30 feet of water, whereas if it's further out, you might see 50 feet of water. If it's even further, 100 feet, et cetera.
Mm-hmm.
So just like in that same way, the horizon works in a sort of similar way to that, to where that meeting place of the ground and the sky is at a particular distance because it's the last bit of water you can see in that current environment you're looking at. The thing that we call the horizon of the water, if you're looking out of water, that water level, that's literally the last little bit of water that you're able to see. Now, it's not because you're seeing it beyond a curve of a globe Earth, in my viewpoint, it's just beyond the visual limit. And so there's a place on that ground, which is why a boat's hull will not be cut off at that point, because it's in front of that. But if you have an object on the surface that keeps going backward past that point, because again, that point, like the horizon is not physical, but there is a physical point at which it's the full extension of how far you can see. And at that point, right, that's it. It's the furthest point. So if that point is only a mile out, then and the ground and the sky are meeting there, then if you have a boat that's at 2 miles, of course you're not going to see the bottom of it because it's past the horizon point, which is in front of it. It's past the point at which the ground and the sky meet. But because the boat is popping up out of the water, you can still see the top of it. It's just being visually obscured, the bottom part.
Okay, so I have to.
It's being visually obscured because it's past the point of the maximum extension of where the horizon is on that day, which is why in something like what people refer to as the black swan, that image, the day where you can see the horizon way behind it, that's because the place at which the ground and the sky meet is very far. It's way back there. So you're like, oh, look at that, the extended plane, you can see it extend out. Whereas on the other day where you see the bottom of the oil rig being cut off, that's because the point at which the ground and the sky meet is much closer. You can't see nearly as much of the water. It's a closer distance. And I think it has to do with atmospheric magnification and the ether and the electrostatic fields and the way that whole thing comes together. But there is that distance. And so if that distance is closer, well, now the last bit of water you can see is in front of the oil rigs. If it's that much, to where now the legs of the oil rigs are going to be cut off. That's why
I get what you're saying, but I'm curious. But maybe I missed it. But what is it? What principle what is the principle that dictates where the furthest point on the ground or on the water or whatever is going to be that day? And on whatever that principle is, like even if you don't define it specifically, how does this principle not affect the boat in the same way? So how does it affect the water but not affect the boat? If that makes sense. Like the parts of the boat that are still able to be seen. Like what is it that causes that limit to be at that given point? Like is it just like the atmosphere, or you not being able to see clearly through the atmosphere that day, or whatever it is?
Yeah, I mean, I think it's a confluence of several factors. I mean, ultimately, I think it's electrostatic in nature because it has to do with like the electrostatic nature of air and water and how they form and a lot of those factors. So yeah, I think it has to do with I think it also has a lens component to it, sort of like a camera lens where you can alter the focus. How you can, with like camera lenses, you can do like zoom and focus. Well, basically that's because it's a lens. So the atmosphere is a lens and it's zooming and focusing. essentially. So the horizon line is being constellated due partly to, I'm not saying they're exactly like a zoom or a focus. I'm not saying it's the exact same thing, but I think there is a similar component at which the actual, because we're in a system of, water and light and air and all of these gases, everything that's here. So it's like a very live medium that can be able to kind of like, I almost see it as like an expansion and a contraction. Like when it's expanded, you can see past the oil rigs and the horizon's way behind it. When it's more contracted and kind of magnified and so on, then it's much closer.
Okay, but that's why I was asking, like, regardless of what the mechanism is, because I get now what we're saying is like it's basically not necessarily refraction, but it is due to the atmosphere and the variance in that. It's gonna have effects that change the limit to how far you can see along the surface.
But ultimately, I think it not only changes the limit, but it also changes where the horizon, like that limit is denoted by where the horizon constellates. Right. Like I said, that's the furthest point of the ground you can see, and then the sky is going to be the default because obviously that's what's above it.
Right. But yeah, I know, I understand that. I was using that phrase, like the furthest the point along the surface, but I was using that phrase because I agree that that's one way to describe where the horizon is. But my question ultimately is, how does it have this effect on the surface, such that like on this boat, for example, or any object that is further than where that point is in the horizon, it's not affecting your view to see that thing because it's being obstructed halfway or whatever, but the part that you can see is still visible. So that's what I'm asking is why does that limit the bottom part and the surface, but not limit that part?
Yeah, I would say because it's the ground layer that's actually the part that's being changed. It's not the sky. Like the sky is just the default. It's always there. But the ground layer, because we're so close to the ground, and since we're on the ground, you know what I mean? Like the angle from a 6-foot guy standing on the beach looking out, that angle is very tiny, 6 feet above the ground. So you're very close to the ground in that sense. And like in the ones I just posted in the chat there, how it shows that the two differences. So the one where the oil rig's legs are being cut off, see how the water looks really detailed? Like it's almost like it looks like it's behind a lens, like it's much more clear. And so that's the part that's being, in a sense magnified, and that's the part that's being changed is the distance, because it's the distance of the ground. The sky is just always there, is the way I see it. Like the sky is kind of the default, and it's the ground position. So in that one, it's so much closer, which visually is going to not allow you to see it in it behind it. Whereas the other one where the horizon's way, way behind it, that's just because the point at which you can see in that scenario is so much further. But I think what you're also saying is why doesn't the boat change or whatever? Well, I mean, in this one it does. There's a different refraction little thing going on. But you're saying why doesn't that get zoomed in? Well, it's because it's not like well, sometimes it can work like a magnifier like that. Is that what you're asking? Like, why doesn't the boat look magnified?
No, not why doesn't it look magnified. Okay, so let's say that this effect changes the distance along the surface that you can see, and let's say that has something to do with because it's 90 degrees opposed to the direction. So it's like the ground is along the surface, so the angle to it is going to it's going to obviously limit the amount that you can see based on how high you're looking off the ground. But
yeah, it's going to be most affected there. It's going to be like severely affected at that level because the density, the water that's all spraying up from the ocean. So yeah, it's going to create quite a tapestry there.
All right, so I understand that. Hold on, because I just want to finish the question because I understand that part. What I'm saying is the vertical component of what's in the image. So anything that's not along the surface but is actually vertically constructed, like a tower, mountain, oil rig. It's also there's parts of it that are being able to be hidden by the horizon, probably because of the same effect that you're talking about. It's being applied to the bottom part of some of these objects, but it's not being applied to the top part of the object. So it's like that's what I'm saying. Is what denotes that what part of the thing is able to be obstructed or not? Because it would seem like it's all that same distance away. It seems like the whole thing would be due to that principle you're saying. It would be subjected to the same same thing, or none of it would be. I would think.
No, because it's on the ground.
Why do you got to go so complicated?
The object, the key to that is it's on the ground. Yeah, the boat is
moving
on
though, Gio.
over a planer. Hold up, Zanuck. If you want to get in, that's cool. But I was going to respond to Coach real quick, just on that at least.
You're saying it's on the ground.
Yeah, I have to recover from Zanuck's interruptions. What was I even saying?
You're saying it's on the ground is the last thing you said.
Yeah, so I guess my answer to that would be like, okay, so if you're on the ground, if you're on the, like, you're a 6 foot observer off the sea level, and then you have like a boat in the distance. Part of the boat is like the hull of the boat is in the water, of course, and then the part coming right up off the water sea level is the hull of the boat that we can see, and then, a foot up, 2 feet up, 3 feet up, etc. And at some point now, if you're going to go like 15, 20 feet up, if you're talking about a sailboat or maybe even higher, the mast. So now you have this big mast above the surface. Well, if the furthest distance that you can see upon the water on that day is X distance, then let's say that the boat is 5 miles away. And I'm just going to kind of make up these numbers for a second, but let's say the boat's 5 miles away, but you can only see 4 miles of the water on that day due to the atmospheric conditions and the conditions. You can only see 4 miles. So as you're out looking over a planar, flat water, you're looking, and the furthest you can see is 4 miles. That's the last little wave of water you see is 4 miles. Well, if that boat is at 5 miles, then visually the bottom part of the boat is going to be obscured because it is past the extension point and the angles that you're looking at it from of the furthest distance of water you can see. However, the top part of it can still be seen because it is visually at an angle higher than that 4 mile limit.
But Gio, why does the top of that boat go down? Even though that I'm accepting the fact that you think it's going to pass the point of some angular resolution idea at the surface because the angles are so acute. Fine. But that wouldn't explain why the entire structure is constantly moving downward.
I don't know what you mean by downward. It's not sinking down.
Angular position
no, more of it is being obscured.
No, it's moving.
And it's shrinking due to perspective. Hold on, dude. Everything shrinks due to perspective. Like you can have a 30-foot pole out there, and as you move it away, it's going to be shrinking, just like railroad tracks, the whole thing. So perspective. So that yes, it will be sinking in that way. That doesn't mean it's sinking around a sphere. It just can be sinking due to perspective.
No, because you showed a picture here that shows two identical objects. Nothing has changed as far as distance. Exact same distance away. One sunk down lower. The top of the roof is much lower than the left picture, which is higher. So that doesn't corroborate. That doesn't make any sense what you're saying.
If you talk about that one in particular, there's definitely some distortion going on. Yeah.
No. It's down. Obviously, you have distortion in where it's higher is more. Those buildings, those rooms and things on the right side of the structures are not that tall. They're elongated.
Have you seen the Thanks Chemo one? Check it out. He made this one day. We were joking around. It was one of those days I was on Gems. We were all joking. We posted this, and then he added Thanks Chemo to it. I think, I have the original one, which is this one. And then he added.
Those are great. Those are fantastic. Why is it?
Yeah, it just shows how magnification. Yeah, I was explaining how there's magnification involved, and it shows exactly how magnification does this.
If it's magnified, why is it lower? Why is it move? It shouldn't move. Magnified.
Because that's what magnification does.
No, it doesn't. It doesn't magnify it. It doesn't move it. It makes it larger. And in this, it's distorted laterally. And the other, you said that's more of a true. My question, really, the obvious question, the elephant in the room is, which one is correct? Which one is refraction? Which one is not refraction? The one that's hidden is refracted? And why does it move down? If it's not refraction, if it's just perspective, as you said earlier, then why did it move down? It's much lower angularly in that field of view with respect to the water, with respect to the first object. The closest object is still in a pretty solid position as far as same as the other one, but the further one is much lower. that's not a perspective effect.
Well, it definitely is. It has to do with the way the atmosphere works. I mean, on a globe, that's the same distance, same elevation, same location. So obviously, it's not going around a curve. It's not sinking around a sphere.
Of course it is, but
that's obviously not what it's doing, because
it's not
that's
obviously
the same on
it's
the
obvious
same
I would
day. You're interrupting again, man. I don't know if you can even do it.
I'm not. I'm trying to wait for you to. I thought you had to stop for a second. It's not being hidden by something. It's not obvious at all, because if it was obvious, I would just say that's obvious. It's not obvious to me, so it's not obvious. It shows that it's being hidden by Earth curve. If you say it's not, then what makes it lower versus the one on the right? And the answer can't be perspective, because perspective should work for both. So something else is happening.
Yeah, I think there's different mediums. There's different layers of medium as you go out in distance. So you have different, like ducts and different sections of Earth that are going to have some variation as well. So that all has to be taken into account. But ducks. Yeah, I think there's a, and just like with the Skunk Bay footage, when there can be sort of warping happening as well. Like, for example, you can have like let's say like the bonfire idea. Like if you're outside in a bonfire, you got a big fire, and you're looking through it, and someone on the other side, they can be moved in their position, like refracted, but maybe to the right of them, there's less distortion because it's a little bit further from the fire, and the person next to them looks normal. So the one person is being refracted in some way. It could be bent down, up. There's various different wavering. It could have different components. So that's an example as well on how. And then if you add distance to that, if you were to add a scenario, which is what this has involved in it, when you now have distance, I'm just saying those are additional factors that can be involved.
Yeah, but we don't see that. I mean, show me an example of a fire. I know refraction happens when you have heated air. I know things get blunt, but the center points of those people don't move, never. So this is showing something dramatically lower. So yeah, you can say I can't see because of it's unseeable, but that doesn't explain why it is dropping. If it was due to atmosphere near the water, near this water that can only be seen usually 3 feet or 3 miles away, and it's really 7 or 10 miles away, that wouldn't explain why it sinks down. And you said it's perspective. It's not perspective. If you want to give me refraction, I'll
I mean, if somebody wants to talk to Zanuck, go ahead. But I wanted to actually go back to talking.
Well, you just didn't give me an answer. You didn't give me an answer. You made it sound like it was so obvious, Gio.
I'm not interested. Hold on, dude. I'm just telling you, I'm not interested in engaging with your just like teaching, condescending attitude. Kosho and I were having
teaching
an actual interesting discussion. So I'm just saying, if anyone else would like to talk with you, go ahead. I'll step back, and if not, then I'd like to continue with Kosho.
All right, that's fine. Well, that's what I close by saying that I wanted to hear your answer on it. I didn't get the answer. It doesn't explain why this would drop with respect to.
Well, it didn't sound like you had a question. We were having an actual conversation, and it's gone into you monologuing about whatever.
No, I want to know what you. I was hoping you were going to say, light bending. Light bending made that thing go down. It's a sinking effect, which is make light bending upward, and then we could have gone down the path of what makes light bend upward. But you just kept on saying, "Okay, fine, I'll end it there." You said it's perspective. I don't agree. I don't think that's a good answer, and it's not.
Well, if you want to try to engage in an actual conversation, we could try. I mean, I'm just saying, if you're only going to do like the preaching, teaching thing, I just find it boring because I'm not really looking to debate anything. I'm looking to actually explore the ideas and talk about it. And Kosho and I were going into it. So if you want to try to ask an actual question or go back and forth, we could do something. But if you're just going to do teaching and preaching, I just don't find it interesting to engage.
I thought I was. I really mistaken if I was really wanted to know the answer, what the explanation was for it dropping. I said I didn't understand that perspective could make things move, because I don't see things move with the perspective of that, especially with respect to two objects that are the same exact position they were the day before or whenever they were taken before. If you want to explore refraction and bending of light, that'd be interesting, because I don't know how light can bend up over the skin conditions. So it's not a teaching; it was just asking your position on, because you talked about perspective and this narrowing of your view and the angular being your position being smaller and smaller due to perspective, and also a couple other things you mentioned. I that logic.
Hey Zanuck, you want me to give an analogy of the question that you just asked Gio regarding those pictures?
No, I don't.
Okay, well I'll give it to you. I'll give it to you anyways. So Zanuck, what ingredient makes a cake?
I just said I didn't want to engage it. part of no, don't you understand?
Hey, Gio, what ingredient makes a cake?
Wait, now Xanax said he doesn't want to engage with Napalm.
Because I don't like.
And now you're just doing
silly games.
Oh, jeez.
I'm winning. I'm winning, Gio. I'm winning.
Yeah, because he didn't even do it. He didn't even do anything. He just asked.
All right. Water.
Wait, what was the question?
So, what ingredient makes a cake?
Water.
So you're telling me if you just handed me water, it makes a cake? I can make a cake with just water?
You need water to make a cake. That wasn't the question.
Yeah, the question was what ingredient makes a cake? Singular.
What ingredient? It's not just one ingredient.
Okay, cool. So when you ask Gio, hey, what is going on here that this one is appearing to sink down and this one's appearing to rise up, and you're asking all these questions, and if he gives one specific answer, it would be like answering the question, what ingredient makes a cake, and answering water.
False analogy, because I never asked what ingredient or what is the problem, what is the solution, answer. And it's not one answer. It could be a whole story. I'm willing to hear the story. So that's a false analogy and a false.
No, so yeah, sorry I interrupted, but I mean, what well, the thing is though, dude, you were asking for. You were saying, why is this happening? Especially on the ones I just posted. Why is it at a different height compared to the other oil rig?
Angular position.
Yeah, and you were asking for one, just like, why is it doing this? Why is it doing this?
No,
based on perspective. And I was starting to give a tapestry of multiple components that are involved. And then you basically just kept saying, no, it can't be that or whatever. So it is, what Napalm was saying is true. Like you were trying to ask me, I guess, to summarize it in one way, but then every way I was saying, you were just writing off anyway.
That's not true. You gave me a 4 or 5. One thing I said, no, it's not perspective. You said some atmospheric conditions. I didn't say anything against that. You said things get distorted, and you gave me an analogy of the campfire and people moving around. I said that they don't move around for that reason. So again, I want to know, whatever the reason is, how many reasons you want to give me. It's up to you. Why you think that one object in the distance, it looks pretty clear in both pictures, with respect to the closer object, has moved downward. Can't be perspective because the one on the right can do it. So if it's perspective, both would. There had to be something optical that's happening. I would think, but I don't want give you.
Yeah, it's a vertical optical gradient. Absolutely. Like if you go back and look at the one that is like it snaps back and forth between them. Let me see if I can post it again.
I got it. I've seen it a million times. I posted it myself, actually. It's a great picture. Question is, why does it drop down? Up, down, up, down, up, down.
Okay, I was just trying to post it again since I was about to mention it. Yeah, so I mean, if what I'm saying is the case, that there's a vertical and horizontal gradient going on, but if the furthest limit of the water that you were able to see due to the way that the horizon constellates over a planar surface between the ground and the sky, if that point is much, much closer on the day when it looks, like it's cutting off the bottom of the legs, there's a vertical change happening between in the medium, essentially from the water up, that is going to denote how far you can see of the water. And then what you can see, and the one where you can see the horizon behind it or beyond it is because the distance of water you can see in terms of where the horizon is on that day is way behind the oil rig. So it's much further in distance.
Well, it's actually behind it.
And then, yeah, there does seem to be like a vertical squashing magnification kind of thing as well. Like when you see those flashing back and forth, there definitely is it's like it gets brought. It's like it's just like a lens, you can do this with a lens. You can the way magnifying glasses work, the way lenses work in cameras, where you can do like a zoom and a focus, and you can get these effects. It's going to it's going to distort it.
Okay, the bottom picture that's stepping back and forth. Of the bottom picture that's stepping back and forth, what is more representative of the actual oil rig? Which one would you say? The lower one sunk in the water in the bluer picture, or the second picture where you got the squiggly train? What would you say? I mean, be honest. Which one is more representative of the shape and size and proportions of the oil platform? Which one?
They're both distorted. But obviously, this one where in this particular scenario, the one where the horizon is far beyond is very bent, and yeah, that metal thing is obviously not bent in reality. But just because that correlates, that it happens to be that when you can see the further horizon, that it's a little more bent, is not, I think, a very strong argument for anything. With some idea, as off people have tried to say, oh well, that's why you're seeing around the curve because it's more bent. I don't see that as being very logically.
It's not a matter of bent. I was really I wanted like a 1 or 2 word answer. But you wanted to give me a little bit more. Fine. We all know that the one that's stretched out and has, we're talking about 2x the distortion vertically of the brownish picture, and forget about the bent cranes, because there are also pictures of loomed up objects that are not bending the cranes. But that's not the point. It is stretched up, and that is a characteristic of swimming. That on a small scale, and it's a characteristic that shows that when things are loomed up, light bending downward, things will stretch up and make some towering effects happen. So they do kind of follow logic and follow that the observations that we see in those kind of objects. It wouldn't be the opposite. It wouldn't say like, oh, the one that's bent and stretched out, that's the one that's how really the Earth is, and the one where it's hidden, that's the one we have other problems.
They both are the Earth. They're both a planar surface extending outwards with level water. It's just that the one where the bottom of the rig's being cut off, where the horizon constellates of the ground and sky due to the distance of the ground you can see on that day, the peak of that distant water, is whatever. Let's say it's that wave, whatever it is. It's that wave. It's right there. That's the last bit of water before the ground and the sky are constellating where they meet visually. And that definitely changes over a planar surface. It's optical. It changes profoundly. Even throughout the day, it can change. And then on the other one, so on the second one where you can see the horizon way behind, that is more representative of more of the Earth's surface. Like it is representative of more of the surface.
Well, that
they're both the Earth. It's just level water and how the things are.
You're not. Let's get something straight first, also, because I was just there last week. That second oil rig in the back that's shown, you see that's the horizon behind it. That is it's a band of fog right along the water, and it kind of makes it think that it's a horizon. But no, the horizon actually is just at or before that second oil rig. It's still seeing much farther than you should based on our calculations of descriptions of it.
Yeah, I think you're absolutely false with that. 100%.
That is absolutely. In fact, I got pictures that you can actually see why would it be higher laterally on the right and lower on the left. And that's exact. That fog bank you see all the time in Southern California. All the time. It's not even a question. You think that's false, and you're making a statement based on a guess. I'll give you a pass because knee-jerk reaction. Like it is in the chat.
Yeah, you really ruined this conversation. Kosha, are you still there?
All right.
But now you're just throwing condescending.
Well, no, I'm going to show you a picture, and I know that you said absolutely. You said that's false. Absolutely, you said. So here's a picture.
Yeah, I was just saying I do think that's false. Right. Yes.
Then take a look at this picture real quick. Same day, same week that was all this was taken, and take a look at that picture. Why the fog bank on the right is higher, almost mid crane on the closer platform, and then it also kind of drops down significantly on that line that is supposed to be the.
Yeah, I've described this exact effect. Over a planar surface, you can have like areas where you might be able to see further on one side of your vision because there's less clouds or less fog, whatever it may be, and then the other one could be closer. So it can look almost curved in a sense because you're seeing, like, let's say the limit of the fog is 3 miles on the left, but on the right it's 8 miles. Well, then there's gonna be a lot more water visible, and that sort of visual horizon line is going to, just like it does here, it looks a little curved. It's not actually curved. It essentially changes in elevation in your view. It goes from being a little bit lower on the left to a little bit higher because you're seeing further.
Okay, so when I was there also last week, I saw this other interesting picture, which you can take a look at it.
Yeah, that's a good one. I wish that was a better, not like a screenshot from the YouTube video, because that one is.
There's my picture, and I showed this. I was live last week showing everybody on the first platform. That was the Habit. The interesting thing about that, Geo, is that the top crane is almost in the top of the. Now I show a picture of my telescope sitting on the beach. Got it. Pads were getting wet. Probably, even though I was 3 feet off the water, I wouldn't claim it was 4 feet because the it's coming up to the. Even though it's a very shallow declination. Anyway, let's call it 5 feet. You can't figure out the math that makes this work. The top of the crane, which we 7. The top of that.
You keep cutting out, Zanuck. I'm not sure what's going on.
Anyway, the top of the crane matching up with the top of the in that point.
Yeah, you're breaking out.
Beach.
You're cutting out.
You kind of.
Hey, Geo, I would actually be curious. I don't know if I'm breaking up or not, or if it's him.
Oh, you're good. Zanuck, you got to fix your mic.
I would be. Yeah, I'd be curious to hear his response to your previous question or your previous analysis of the photograph, where one side appears to be closer and the other appears to be further away in regards to the horizon. You have this kind of like hilted, almost curvy kind of horizon. I would be curious as to what Zanuck thinks is going on there. Why is one horizon appear to be higher than the other horizon? What is causing that? And
it's a fog bank that's closer to the shore on the right. There's actually an isthmus out there, a peak of land.
Yeah, so you have atmospheric conditions. And when you said previously, so when you had, which is an atmospheric condition. So when you had,
you're seeing fog. You're not seeing farther. You're seeing a fog bank,
which is atmospheric condition that causes the horizon to appear closer.
No.
So okay. So in the left side of that image, where's the horizon?
Where the line
appear
is.
To be.
Where the line is. Red line.
Yeah. Where's it at on the right?
Same spot. The fog is above it. That's a fog bank that's below and emerging into the. If you watch the video, you can see it very clearly. That is fog. If you live down there, you see this every day. This is how fog works.
I'm not disputing what it is,
same kind
or
of
whether
color,
you would or would not
horizon,
see it.
It's not. Okay, Napon, come on.
You are like, do you intentionally try to not have a conversation with people?
No, you keep on contradicting what I'm telling you.
You said fog is not a weather condition?
It's a weather condition, yes, but it is fog. It has nothing to do with the weather condition. It is fog.
It changes optics?
It doesn't change optics in this picture.
It does.
It changes the condition.
Okay,
it changes what you see. It doesn't change the optics.
Changes what you see. It doesn't change the optics. We get it.
No,
double
you can
speak
see these objects in any day, no matter what the conditions. You see those objects. They move according to they move according to optical conditions. I agree, but the fog bank is not related to that. That is a separate physical
optics.
Obstruction.
I said optics, not objects.
The objects are
it changes. Never mind, dude.
Objects are optics. You didn't know
that? No, optics. Optically, you have refraction. It could be the reason that.
This just seems so remedial. This seems like you could just be like, you could be like a tribe on an island in the middle of nowhere and be looking out over the water and be like, yes, fog over here, less fog over there. I can see further over there. Like, it's literally that simple.
Well, you have three things going on. You have a fog bank on the right, you have fog bank on the left, and you have an optical condition which has caused looming. That
and where does fall come into this?
So let me ask you a question, Zanuck. When you were asking Geo about things apparently moving up and down, right? Moving up and down due to atmospheric conditions. What is causing that?
It's very clear. It's refraction.
Yeah, when Zanuck was asking this before about the height of the oil rig, I would say compression as well. There's magnification and compression involved.
Yeah, magnification, compression, refraction. All of these are components. But what we can agree on is that the object is appearing in different places at different times due to different types of conditions. Would we agree upon that? Zanuck?
No, because we're seeing the two objects on one day and the two objects on another day, yet one in the back is dropped down. And I'm asking what you thought, what Geo thought that the reason was for that to occur. And I got two pictures that I took live. This is like not part of a video, just me pointing a camera at the habitat, and then also the those two platforms. And one is almost completely gone. It was a pretty clear day. The picture. You just gonna talk over me? You don't want to hear.
Was this at a hotel or not?
This is in front of the hotel, the Miramar. Yeah, the Miramar Hotel. Right in front of the hotel. And you can see the crane that lines up. The easy equation will be to look at the top of the crane, figure out how high it is, and see if you can, if you have a 6-foot observer, look at the top of the crane, it's straight up, and see if it matches a 2,000-foot mountain in the distance. And it won't. That won't pencil out. That also shows that there's curvature because the mountain is lower than it should be angularly.
I think you're back in preach mode. It was my sense of it. Sorry, that's just my feedback. I don't know. I don't know where the convo can go right now.
No problem. I thought I'd put some pictures to make you guys think, maybe do some angle measurements, and then maybe give an answer for how these two objects can actually move with respect to one another. That's my question, and I don't think I got an answer. If you want to say it's refraction, that's kind of preferential refraction, but okay.
All right. What's your question? What was your question then?
What you think the reason is? 2 different days, 2 identical objects, same viewing point, where one could move higher or lower with respect to the other one. And if it's refraction, how does light bend upward to make that happen?
Wait, these 2 pictures you're saying they look totally different. One of them looks more zoomed in and all that. Which ones are you talking about?
No, the same exact telescope. Mine or yours? Mine are the exact same telescope. No change. Mine's from a telescope. Fixed lens.
You're talking about this oil rig thing, or which one?
They're both oil rigs. One's an oil rig that has a crane that's pointed straight up, and then the other one is a Grace platform. I think it's Grace or Habitat. What's the other one? Habitat's a closer one. Can't remember the name of the other one. Anyway,
well, I mean, these just look totally different, dude. The first one is very clear. You can see the water. It looks like it's zoomed out. The other one looks very zoomed in, and it looks totally different. So I don't know.
Same exact telescope.
Well, then why is one all fuzzy and looks all blurry?
The camera is, my phone camera is looking through the viewfinder. Same.
Oh, yeah, this is a mess. Then I mean, it's not a direct representation. I mean, that thing looks totally warped, and I'm not even sure what that is. Looks all.
Are you seriously taking it through a phone? Are you crazy?
Yeah, that looks totally different, dude. That's not even. Are you trying to say that's the same one? Because one of them, there's a huge, big, tall crane. It looks, hundreds of feet high. The other one, I don't know what that is. It looks further away. It looks squashed on the horizon. I don't know what that is. Looks all zoomed in. Are you sure you didn't post the wrong ones or something? Danik, you dropped out. Are you sure you didn't post the wrong ones, dude? Because one of them looks like a clear, very tall, huge tower and everything. The other one looks zoomed in. It looks like it's further away. It looks totally different.
That was the same. This is one camera or one telescope looking at the oil rigs from the shore. It's lighter, so it's late in the day. Yeah, that one, and this one. These are all 3 I took in a row, all from the same spot.
Okay, these are all different. They have different zooms. These are all different.
No, it's not zoom. It's the same. It's only one telescope. They're all the same. Oh, the other one's Grace. This is the one that's always hidden, and then the first one is the Habitat, which is the closest one.
Cool.
Same lens, same beach. I have them numbered here. I know when they were taken. 1218, 1223, 1248, and 1258. Those are all in succession. There's a bunch of ones I erased that were all jacked up that I couldn't get a clear picture. So last ones I took. One of the earlier in the day, I was off the highway, and I took a few of those as well. They're similar in look, but they're not the same. They were off of the highway more north.
All right, man. Well, I'm not really sure what you're looking at. I don't have any response to that. What I'm seeing are three dramatically different looking things. You're telling me it's a camera through a telescope lens. It could be tilted. I'm not sure. I mean, the first one, like I said, it looks like a huge, tall, extended. You can see a lot of detail. The second one looks completely blurry. It looks like it's either a different zoom on it because the waves look like they're a different size and it's all blurry. And then the third one is sort of in between those, I guess. But this is looks like a different oil rig setup. I'm not even sure what this is. So what are you?
Same spot, all three different oil rigs, all different directions from my location in front of the Miramar Hotel. Also,
okay, three shots, different directions, different oil rigs. And what are you trying to show with this?
Well, one is like 3/4 missing. That one, I mean, it's blurry. I wish I could have got a clearer picture of that. We should have focused on trying to get that one, but it's cold and windy, and wind is picking up. But it was all from the same exact spot. Here's a picture of what it looked like. Here's the beach. It looks like right here.
Yeah, I mean, things can get compressed and magnified in the distance in various different formations.
They all look the same.
Get refracted.
The moment I got there, I just wanted to focus on one, then focus on the other, and then get out of there because it was cold.
I mean, we live in a lens.
Okay.
But was there a particular question on it, or was it just?
No, just to show you that I'm looking at a day where there's not much refraction, that there's no miraging, there's no infrared miraging, and you can see the main thing is you can see the mountain on top of the crane, and all you have to do is do some simple math. Look at my telescope, where it is on the beach, guesstimate how high I am, look at the crane, figure out how high that crane is. It has specs on the website, and then look at that mountain, the Santa Barbara Mountains, Santa Barbara Island.
Yeah, compression can change the height of thing. This is where Ranty got all excited about that Blackpool Tower thing, but I'm not trying to call him out in what I'm about to say, but I mean, that whole argument is a dramatic misunderstanding of how the environment functions, and that in terms of how things shrink in the distance and how they compress and how the environment can at different distances. Because I know this is a thing you bring up a lot, the different mountains at different distances. Right. But
my video, Geo, a long time ago, Ranty proving what he said he couldn't find. But anyway, it's him showing before he even turned to right before too. I'm surprised his memory was so short, but he showed through the refraction gradient. He did a demonstration and said, for Miles Davis, anybody trying to use mountains in the background, being at the wrong elevation, here's your answer. And he shows it plain as day that with just the refraction, the way they describe it, shows the shit in the background lower. And then he uses that very thing to switch over. That was weird to me.
Yeah, it reminds me of like an effect when you zoom out of something, how it kind of changes its height, Like it's not an exact zoom effect, but yeah, like a compression. There can be compression involved in terms of where the height is going to be aligned due to the gradient. Just like in the Skunk Bay where that wavers up and down, it's not quite the same thing, but in a way it's similar. There can be, sort of like visual misplacement. Even like, if you ever have like water in your eye or something, or you're looking through goggles, how like we've all probably had things like that, where you kind of get like effects like that. Like compression effects and different lens effects like that. At the way that can happen at distance. But you're saying that it showed that, Brian, like that video?
Yeah, plain as day. Like he demonstrated it. Like he set one of them things up and induced a gradient, and then he filmed it. Did a couple different times, and he showed paint can one time, and then like a little other, like I forgot what the other thing is, but I'll post this video in Lab Chat for anybody interested, where he says plain as day for anybody who tries to use these distant mountains. Well, there's your answer through their own demonstration of an induced gradient. with the light bending down toward the denser medium. It showed distant objects drop.
Yeah.
In fact, I put it in my recent video about dishonest globers. I put a little clip of it, so I'll just post my new one. Before I do that, Gio, I asked Blue. It was just me and D-Mock shooting the shit, and I think New Perspective was in here for a minute. But the other night, Blue Marble popped in, and no, it wasn't me and D-Mock. That was a different time. But anyway,
I'm in here now.
He popped in, but and I think he said that he was muted, but there was no mods. Is he able to talk, pipe up if he has any concerns or?
Yeah, he's got roles. Yeah, that might have been. I think he had rejoined the server recently, so. But yeah, he's got roles. Yeah, he's in the VC now, but maybe he's just listening. But yeah, he can unmute.
Okay, I was just checking.
Hey, is Napalm still here? I don't know if they can talk. Yeah, I was just curious because I brought it up to Gio, but actually I really wanted to talk to you about it because it was you who was talking to them about it earlier. But it was based on your idea of what the of what how the eye sees and how perspective could cause the sun to be obstructed by the horizon. And my question to him that I really wanted to ask you was, do you think that it would be a fair test or a proper test if somebody were to get like a wide range of cameras, like if iPhone, whatever, a wide range of cameras and lenses and pictures, and took an image of the same sunset at the same time, and then like look to see, like I guess you would expect that the different optics would give you different observations of where the horizon was in reference to the sun. I'm assuming according to the way you described it. I'm just wondering if you think that would be a test that would show that one way or the other.
No, not necessarily. I don't think so, because you would, in order to get like extremely noticeable differences, you'd need to have like really extreme focal length and aperture differences and lens sizes to be able to pull in light and to be able to open up the perspective at a much longer distance to see a significant change. The problem with doing something like that with the sun is that it is so far away when it is appearing to disappear that your focal length and distance, like, if you changed where your apparent horizon is from 3 miles to 6 miles or 10 miles or 12 miles or 13 miles, you're not really making a huge change as to what effect you would be seeing based on an object that could be 3,000, 4,000, 10,000, 100,000 miles away, if that makes sense.
I mean, it sort of does, but I mean, it answers the question at least, because I want to see like what caveats would be the issue. How would you adjust this test that I suggested? Like what variables would you change in it, or conditions would you use to do that same sort of test in order to get to conclude whether or not that's causing it or not? You know what I mean? Like, if that was the question that you were asking, was if that thing's causing it, how would you adjust my test to find it out?
Well, I think that the sunset is a multitude of things that's taking place there. Like I said previously, there can be a cloud bank that's 1,000 miles away on the horizon that could be obscuring the sun as it goes past it. You know what I'm saying? How can you adjust for a cloud 1,000 miles away, a bank of clouds that could be obscuring the light? It's nearly impossible.
Let's change. That's what I'm saying. Like, let's adjust it. So instead of making an observation of the sun, we're making an observation, let's say, of a giant building, a tall building of whatever height, a single building with defined windows where you can easily tell the height that's being obstructed. Would that adjustment change
Not really.
the net test?
Not really, because here's the thing: like what sets your optical horizon?
I think something differently than what you guys think. That's why. So,
well, let me ask you this: is it the ground or is it the sky?
It's the ground. It's your distance. Based on our geometric shape, it's based on that fact. So the distance you are above that geometric shape will determine that distance.
And if the surface of that shape is planar, do you at least agree that there will still be a horizon based on how we visually see? Because there's some globers that are like, you wouldn't have a horizon if you're on a flat surface.
No, I mean, if you called it the horizon, I would only call it that if I was allowed to describe what it was I was calling that, because I would. The only reason I wouldn't call it the horizon is because that's a specific thing, whereas the horizon in this case would be something that wouldn't be fine. I wouldn't think it wouldn't be like a fine line. It also wouldn't be a consistent line. So like different directions, you might even see it at different distances. And
just like the actual horizon, then, right?
Yeah,
You're describing it
not quite.
perfect.
No, not
Horizon's
quite,
not an actual thing; it's apparent, right? I didn't claim that.
Yeah, right. But if you're looking over the water, though, your horizon is going to be the same in all directions.
Yeah. Have you ever been out offshore on a boat?
Yeah, I was a sailor.
Yeah, it appears that way, and then you can have atmospheric conditions where your horizon might be closer. But here's the thing: when you're out in the boat in the middle of the ocean, and let's say you look north and your horizon is 3 miles away, and you look south and your horizon is 10 miles away, would you be able to tell the difference?
Yeah, if let's assume there's buoys in the water.
Nothing. You're just in the middle of the ocean.
Yeah, but in order for us, we'd have to be able to actually. I mean, there's no point asking that question if there's no way to tell.
Right. You
can't tell. You can't tell just by. Well, you can't tell if there's no references. Of course, yeah. It wouldn't be very easy to tell.
Correct. Yeah. But you wouldn't see. I think this is the common misconception: is that you would see, in some way, shape, or form, the horizon either visually higher or lower in that scenario, and that's not really the case. You just, within the same frame, kind of see an opening up of more expansion of that vanishing point.
Yeah, sure. I mean, I like I said, whatever you want to say the causes or whatever. But I mean, that's why I said it the way. Like, I think it would be the same in all directions. On a well, let's just call it the water. But that's what I'm asking is like the test that you were describing, or not the test, the mechanism you were describing earlier. It sounded like if you had different optics, you would that would make that distance vary, basically, or that would make the amount of something that was beyond the horizon vary about how much is going to be obstructed. It's like a building would be obstructed at different heights depending on the optics you're using. That's what.
Not necessarily. Like I said, you would have to get a drastic change because you're dealing with like aperture size and focal length, and if it's not that different between all of them, some of the effects that you're seeing are not necessarily going to be changed, and some of them aren't just artifacts of perspective. They're atmospheric. So in atmospheric condition, you can't necessarily change specifically with optics.
So you're saying that there would we'll use the most extreme case and we'll use varying instruments that are as varied as you can get. So it's like, an aperture and zoom of two totally different devices, and they're two totally different conditions. but of the same exact moment at the same exact location. You're saying even in that case, you still wouldn't expect a difference, or you would?
I don't know. These hypotheticals are just not. I mean, I don't know what you're expecting me to answer.
He just described a totally impossible hype. He said you're at the same spot, but you said you're at the same spot, but it's two different conditions.
Yeah. Put the cameras right next to each other.
Yeah, so how's it going to be different conditions? It's going to be the same conditions.
Yeah, so that's what I'm saying. Put the cameras right next to each other. I'm saying when I say different conditions, I'm talking about different conditions of the camera. So different properties. The cameras have different zooms and different apertures.
Yeah, you can do this very simply with a P900. You can have it zoomed all the way out, take a picture, and then you can have it zoomed all the way in on the horizon on a boat that's on the horizon and take a picture. Will you see a difference in those two pictures?
It depends on what was missing from the one that was zoomed out. Because if it was just too small to see some of the features, then
let's say you can't really see it at all.
Well, if you can't see it at all, then yeah, I mean, there's no way to say. I was thinking like particularly a test where you could.
So let me ask you a question.
They're too small to see.
If in your first picture you can't visually see something on the horizon, and in your second picture that it's zoomed all the way in and you can, why is that the case?
Well, typically, if something's too small to resolve, then you're just not going to resolve it.
But when you zoom in and you resolve it, why is that the case?
Because you get more, you have more of the image, or more of that image taking up more of the picture that you're taking, and so it's gonna, you're gonna, be able to resolve whatever it was that you couldn't see.
Not necessarily, because what you're describing there would be the equivalent of like a digital zoom, or just taking that picture and trying to like blow it up, which isn't always taking place, right? When you're using like a zoom, an optical zoom, you're changing parameters, the geometry in which light is entering, right?
Yeah, absolutely, yeah.
So you're changing aperture size, you're changing focal length, all this kind of stuff. So let me ask you a question, Kosha.
Hold up.
Okay, go ahead.
Because this is going to. I was trying to say that in the example that I'm trying to give is not one where anything is too small to be resolved, and in whatever test, this would be, it'd be like the buildings, the windows in the buildings were always, at least the ones at the top of the building, they're always crisp enough to be able to discern the difference between the windows and the rest of the building. So, for example, regardless of you changing the effects, you would never want one that was too small that you couldn't resolve that. So I just want to make that clear for this test.
What does that have to do with anything? Like atmospheric conditions, when it's such your visual apparent horizon at varying distances, you get different things in the distance. It's not going to affect the windows on a building in the way that you guys think it would.
That's my point. Yeah, as long as you could see those windows, then you would be able to carefully, you'd be able to do this test and actually be able to count exactly how much of the building is being obstructed or not. Right. So that's the point of the test, is to see if the amount of the building that's being obstructed is changing. Well, it's supposed to, but like I said, based on what I was hearing earlier, it sounded like the different optics, like your eyes being what they are, is what dictates the 3 miles at like 6 foot observer height, whereas different optics, you'd have different values for that. Is what I heard. Yeah. I thought I heard you say that earlier, and so that's what I'm imagining. That varies.
That varies based on atmospheric conditions, right? So if you have atmospheric conditions that are setting a horizon at a specified location, meaning you're setting a horizon that's a mile away for a 6 foot observer, and you have a day where the optical conditions are setting the horizon 10 miles away for a 6 foot observer. No matter what you're doing, zooming in and out, you're not going to change those atmospheric conditions.
Okay, but I mean, I agree with that, but that's what the question is based on what we see then, and what can be obstructed by the horizon or not. It sounds like it has very little to do with the optical equipment. It would be the same for any optical device you're using. And so like the aperture and the physical components of your eye or whatever you're using aren't going to change the amount that's going to be obstructed by the horizon. I heard something different earlier, but if
No,
you're saying yeah,
things can get changed, yeah, for sure, based on the way that you can see. Like if you take what I told you before, where you have a zoomed out picture from the P900, that's very similar to like your vision, right?
Hold on, real quick, Carlos, you're hot, Mike. Carlos.
Oh, sorry.
Yeah, so if you take like a zoomed out picture from a P900, that's fairly similar to like your human eye, maybe a little bit more zoomed out than your human eye. Would you agree?
not quite, but I mean, I can go into for a second. But
I was just going to say, what if the sun is not what you think it is? Like, what I believe is that there's ambient light first, and then the sun is the secondary light as a radiant source of heat and light. And what we're seeing there is something that's a reflection. It's like a rainbow. It's not really. It's just apparent. Has anyone seen that? Has anyone seen the photo, that high altitude photo where the sun's putting a hot spot on the clouds?
Yeah,
it can't be
let me
that
back
far
that
away.
up. Let me back that up, guy, because it's a function of distance. So zooming in, you're not getting closer to the horizon where you're going to see further. It's going to be to your vision. You're just zooming in. You're just enlarging what's there, bro. You're enlarging what our eyes already see. You're not. People mistake zoom, and yeah, they're going to say that hot spot's like water, but you can clearly see it's not water. You can see other water in that actual clip, and it's not even lit up. But you can see that spot's definitely not water. But that's a function of vision, like hot spots, reflections, horizons. It's all a function of vision. We're not getting closer to the horizon by zooming in. We're just enlarging what we see as the horizon.
Yeah, some of what you were saying, Coach, I wanted to comment on. I may have forgotten fully what I was going to say, but yeah, just because in terms of like the way I see it is that like your vision, like the human eye has a particular capacity. Like let's just say someone that has 20/20 vision. It's a mammalian eye, it comes from, we're mammals, etc. Like the way that, we're obviously a biological beings. So we have these eyeball things, and that seems to be where we see out of. So just going on the most basic ever. And that eyeball has like certain specs to it, like how far it can see and how it functions. But then I also think that the atmosphere can function as its own version of a lens that can make horizons be further or closer, et cetera. Like you might be able to see, your eye might have the ability to see further than a particular observation point. Obviously if there's only like a mile out, there's fog. We all know we can see past a mile. So in that case, it's going to be limited when it comes to the horizon, the distance of it, but it's like your eye can see more of it, but the atmosphere or the environment is actually going to constellate it at a particular position that might be closer or further. Like in that black swan thing or in that image that people refer to as the black swan, where, at one point the oil rig's legs are cut off visually, whereas on the other one, they're much further. So obviously you could see the further beyond the oil rig the whole time. Your eye has the spec to do that. But in those conditions, the atmosphere, as it were, the environment actually constellated that horizon closer. And I think that's due to the actual, the water and vapor and density, all of the thing, the conditions beyond just what our eye can take in.
Okay. I'm formulating a question, but I want everybody to, because I know Napalm might wanted to, he was, I think, trying to respond to somebody else too, but I have a question now let me formulate it before I ask you. Unless nobody else has anything else, because I see what you're saying, and my question is actually going to be in response to both that and what Napalm had said. But the more
I think there's an ultimate optical extinction of beyond what the human eye can see, but then there's also the furthest point at which the environment will allow us to see at any one time. Now, perhaps where those intersect would be the sky, where you can kind of see, seemingly indefinite, unless that's unless there's a dome or some kind of material up there. But that's, seems like the furthest we could see up, most likely. I mean, on the ground, like we definitely could see further up. I mean, we see thousands of miles of the sun and all of that, whereas on the ground, usually you're not going to see 1,000 miles on the ground,
Right. And let me just write this down real quick just so I don't forget. Because I had these when you said that again, it reminded me exactly what I wanted to ask. So
like, what's the furthest we see? I mean, like on the ground, the Mount Canigou world record, Guinness Book of World Records, like, what is that, 273 miles, I think. And then I know there's some of the Jay Tolan that claims with infrared is getting further, but I mean, you could be standing on the ground and have a couple mile horizon, but then you can still see the sun. Now, I know from a 93 million mile globe idea, there's a different thing there, but from the idea that the sun is close and local and actually fits the inverse square law and actually fits the dimensions of the planar surface we're on, then in terms of that, the sun is going to be thousands of miles from you that you'll be able to see, even though you can only see a couple miles on the actual ground level, just because of all the density, the water, clouds, everything that's, going to be obstruct your ability to see further. But in the sky, like the 24-hour sun, you're seeing a far distance. You're seeing the sun on the other side of Polaris, in the Arctic.
Yeah, I mean, Walter Bislin's little thing perfectly explains the celestial objects and how that can all take place. It's very easily explained. Just put yourself inside that little... Oh yeah, he even says it.
I wouldn't. Well, no, it doesn't say it. But I wouldn't use that. It will weaken your argument.
If you put yourself inside that little dome, that's like putting yourself inside stellarium. There is no difference. But here's the thing. So when you're talking about optically, I described this earlier. You may or may not have been in the room, and I try to explain it. I don't know if I do it very well, but when you're looking straight forward, you have a field of view. And the lower portion of your field of view, close to, not exactly, 50%, is roughly filled up with what we would call the surface of the Earth, right? This is the appearance of the ground ramping up that we see. Hopefully we can agree upon that.
I'm listening. I'm just writing something down. I heard you guys talk about this earlier, and yeah, yeah, exactly. It's 50-50 minus the elevation angle. Yeah.
So, yeah. So if my horizon line appears at, let's say, 3 miles away, due to the fact that I'm 6 feet above the surface, and I want to work that out mathematically based on angles, and we're talking about normal conditions or whatever we want to call standard. I don't think there is a standard or a normal to the atmosphere, but let's just say on average it's about 3 miles roughly where things start to become unresolvable into the horizon line at a 6 foot observer height. So what I'm looking at is almost 50% of my field of view is being taken up by an angle that starts at my feet, right? So you have your feet up to your eye, and then you have your eyes almost straight out, and then the ground coming back to your feet, right? Does that paint a picture of a triangle for you?
Yeah. You said your eyes, and then the object. So what are the 3 points? I guess. What are the 3 points? One would be your eye, the object, and then your feet.
Yep. Well, it's not an object. We're just looking off in the distance.
Yeah, right. Okay.
And our horizon visually seems to be the last thing that we can resolve is roughly 3 miles away. So we're putting a point there where anything past that point is becoming unresolvable due to the angle that we have there, right? Do you agree or disagree with that?
Yeah, well, that's going to be what takes up your image. Because there's a couple ways you could draw that triangle, but yeah, that triangle. Well, I guess so wait, hold on. So it wouldn't really be a triangle. It'd be kind of like a triangle, and then your eyes be the, what do you call it, bisector of that triangle, basically. Like it'd be a triangle with a line in the middle. Right?
No, because your eyes would set the top angle of the triangle.
See, that doesn't make sense to me
then. It's a right triangle where the 90 is your feet in the ground. And then you have a slight dip down from your eyes, slightly downward, ever so slightly. And that's meeting at a specified point.
Okay.
Off in the distance, roughly 3 miles.
And so the bottom of
that can change. That can vary.
Okay, and that point is along the surface then, because the bottom line is just the base of that triangle, right?
Yeah.
Okay, but then what does that triangle represent though?
That represents your bottom portion of your field of view.
Oh, okay, so that's why I said like the line bisecting it, because this is just the bottom part of the triangle. So if you were doing like the full vision, it'd be a triangle.
Yeah, you want to do full vision, right? So
no, I didn't see that. You were just only
no, we're getting there. We're getting there. We'll do it, and it'll wind up being a triangle where your eye would be something that would bisect it, but not exactly. So we'll take the sun. Let's say the sun is 10,000 miles high. So then you would have to draw up from that original eye line. You'd have to draw up 10,000 miles. And then you'd have the object, let's say it's 4,000 miles around. As that thing travels away from you, right? Remember we were talking about this earlier, from 0 to 3 set your bottom. So from 0 to 3 miles set your bottom. And then we have an object above us. If that object moves 3 miles, where does it appear in your field of view?
Where was it before that?
Directly on your apex. Actually, you wouldn't technically see it directly at your apex, and you technically don't see your feet either, but you understand the concept.
Okay, I see what you're saying. Yeah, and where would it be once you move 3 miles?
Moves 3 miles. It's not going to be that far.
You said how? Yeah, it wouldn't be that far. How high did you say it was though?
Let's say 10,000 miles.
Okay. Yeah, it wouldn't be that far.
And it's like 4,000 miles away. 4,000 miles in circumference. Or diameter. At what point, at what distance does that object, as it's moving away, start to interact with your bottom horizon line?
I mean, I would just have to say 100 times 22. I mean, I would. You said it was 10,000 miles.
10,000 miles high, and it's 4,000 miles in diameter visually. Like diameter.
Eternity, bro. If you're going by like the Rayleigh criteria, just divide it by 0.02 or whatever.
No, it's gonna start to interact with your bottom visual horizon at some point. Meaning that bottom visual horizon is going to give you the appearance of physical obstruction to that object.
I don't think you're going to want to hear the answer he's about to give you. Just saying.
Because it's not.
I don't know why you would hate it.
It's not perfect trig though. That's the problem. He's going to just try to give me a perfect trig.
No, I'm not going to give you a perfect trig. I mean, there's
the funny thing about it is I'll change the scenario, and you won't be able to.
Well, I'm not worried about the horizon in this case. But we do have.
going to give like real world examples, right? So what we see in reality is something like the black swan, where that horizon line is still going to be visually the same height in your field of view, meaning it's taking up the same percentage of your field of view, the ground is, but we're appearing to see farther, even though it's at the same height within your field of view in regards to a percentage of your field of view. So let's say it's 49, or let's say 47% of the lower portion of your field of view is consumed with ground in both scenarios, but we see further in one scenario as opposed to the other, but they're taking up the same percentage of your field of view. How would you do that mathematically?
Well, I mean, the ground would be limited by exactly what you described before, like whatever your height was. You could determine your horizon from that distance, and whatever the other object is, whatever height it's at, you could just reverse that equation, and you could determine how far away you'd be able to see that object. And in the case of this 10,000 mile high object, I came up with 8,800 miles distance would be about when it starts interacting with the horizon.
Cool. So the floor portion, when we go into reality, right, it's not just a percentage or an angle specifically due to distance that is filling up the percentage of our field of view. And an example for this would be like pictures that Zanuck provided, pictures from the black swan, where you're in the same scenario, kind of like you were talking about previously, and you have a camera at a specified height, and you have differing days with different atmospheric conditions, where your horizon appears to be taking up the same percentage of your field of view, but you are seeing a farther distance. How can that be explained trigonometrically when that's what we see in reality?
Well, I mean, that's explained by the thing that was obstructing the oil rig is not obstructing it anymore. Because technically, if you use the same cameras and the same zoom and everything, the oil rig should be taking up, like the oil rigs in their completion should be taking up the same amount of the angular size in the image, depending on how much of it you can see. So obviously, if you see less of it, it's going to take up less of the image. But assuming that it's the same, assuming that you can see the whole thing, that the oil rig is going to take up the same amount of image. So obviously, what's changing is the thing that's obstructing it in those cases.
So, what is the mathematical formula that accounts for the horizon taking up the same percentage of your field of view, but you're seeing farther, meaning that your horizon is now, let's say, 10 miles away, where on the other day it was three miles away, but it's still residing in the same portion of your field of view?
I don't think that it would.
But that's what we experience in reality. So how can you explain that?
Well, as I'm saying is, like, if you accounted for the oil rigs taking up the same angular size, then in the image, the only thing that would be changing would be where the water line is, and the water line, because oil rigs would be the same size and take up the same angular size, and since the water line is changing where it's appearing in reference to them, it's going to change where it appears in reference to the image. So if you take the exact same image, you're not going you're not going to end up with the water line taking up the same amount of the image. You can construct the pictures like that to make sure that the pictures are always taken where the horizon's halfway, but then the oil rigs are going to be in different parts of the picture as well. So it wouldn't really be a fair comparison. Yeah. You have to set up the camera the exact same way in the exact same position both times, to be sure that, like, I guess using like a theodolite or something.
Yeah.
I mean, this is just the way. I don't think that you would end up with. I don't think that you would end up with the same. Like if the horizon's changing, I don't think you're gonna end up with the same amount of the image being taken up, or your field of view being taken up by the bottom part of by the ground.
But why would it ever change?
Well, it would change because the light that's coming from beyond the horizon, or what was the horizon, is now visible, and so you have a different you have a different image coming to your eye now.
So
you can see
when
further.
that light from over the horizon, if it's a physical thing, starts to present itself, wouldn't it have to do that above the previous horizon? And can you give me an estimate as to how high above the previous horizon all of that imagery would have to be?
Well, I don't. Let me think about that, because when you say above the horizon, so it's like you have one vision, and then let's say refraction happens while you're viewing this, and so the light that was beyond the horizon is now visible to you. You're asking, where does it end up in your field of view? How do you realize that? That's what you're asking? I'm assuming. We can look at the Skunk Bay footage, for example, and assuming the camera is always in the same position, you can see further where what that does to the picture. I mean, that's what I would have to do to answer that question, because otherwise I'd just be guessing.
Yeah, you see distortions based on the Skunk Bay stuff, right? That's a pretty fairly close observation. I guess the mountains in the background do rise and fall within the Skunk Bay scenario. So in your paradigm, is that the mountains rising and falling due to the atmospheric conditions? Are they changing their position?
Well, that's what they call magnification, right? Like when the light that was reaching you from those mountains is also being adjusted, or it's coming to you at different angles. Different light is coming to you at that point. But let me look at the footage. Actually, I'm looking at it right now, because actually the mountains in the back aren't really changing. But let me take a look. Try to carefully look at this to see like what's going up and down and everything. And actually, it's also important to just make distinctions between like the the magnification or the looping or steeping or whatever, like the stuff that's going higher and lower, and the actual
yeah, a lot of that takes place,
distortion.
especially on the horizon, right? So you can have things that appear to be above or below a horizontal when they're not actually above or below an established horizontal.
Yeah. And yeah, I just say like that. Yes, because in this Skunk Bay one, there's obviously a lot of distortion, and you want to make sure, or I want to make sure I'm not, conflating these two things and putting them together as the effect, because the distortion is also going to cause where it ends up in the picture. But we're not really talking about that. That's not the purpose of what we're talking about. We're talking about the light, basically the light that's allowing you to see further what it does to the picture. Yeah, I don't know. To be honest with you, it's hard to say, because this was the thing I was going to go to kind of observe it and see what happens. But because of the distortions, it's kind of hard to say what's happening.
I agree.
It looks like if you take out the distortion, I would say it looks like things are staying in their same position, but that might not be true. So I don't know.
Yeah, so when things like appear to rise up or come down as they go further away in the distance, right? Based on your field of view, there's an interaction that takes place between all of those things, especially the ones that are above you and the ones that are below you, based on the distances they are and the sizes that they are. And when your lower portion of your field of view is filled up with the ground, and that sets your horizon, the apparent location where the sky appears to meet the ground, things that are large and above you, as they continue to get further and further away, appear as though they are dropping down towards that horizon and eventually interact with it at some point.
That's what I want to talk.
Yeah, the larger and the higher they are from you, the closer that interaction is going to be without the like angular size change taking place or anything like that. It's just a matter of perspective that draws that object eventually down to a point where it's an apparent location where things appear to be disappearing from the bottom up.
Yeah, but that's what because I could see that making sense if it weren't for like the fact that like you have images of like buildings or ships where the top part is clear and you'd imagine you'd be able to see it at an even greater distance because of how clear it is, but the bottom part's obstructed completely with no
why do you think
like,
why do you think clarity of the image makes a difference?
Because it's it doesn't look like there's any chance that if it were slightly further, you wouldn't be able to resolve it. It seems like it's pretty crisp and it would be resolvable even at a greater distance.
So let me ask you a question. If you had a large lens, like a magnifying glass or something like that, but a lens that wouldn't give you as much distortion as a magnifying glass, a large one, like the size of like a dinner plate or something like that, and you held it away from you, like 10 feet away from you, and you're looking at something, like you're just looking, the things that are in that plate size lens, they're going to be actually clearer probably because they're being lensed, right? The same way like glasses work. It's probably going to be clearer, but it's also going to be larger and it's going to be distorted from the things around it, right?
I guess if you're talking about if you could like anything you could see through that lens, you're saying, or things that are at a distance.
Yeah, just what you visually see in that lens. So it's like 10 feet away, you're looking, just off towards it. Things in that lens are going to appear larger and closer and probably clearer than other things that may be in the distance but not in the lens.
The way that I am imagining that is I would imagine that based on how far away you were from the magnifying glass, that would create a range in the distance that would be where you'd be able to see something clear, but anything closer than that or anything further than that would be blurry or whatever. Just the same way like when you look at a telescope or binoculars, like you don't that gives you a range where things are clear, but things outside that range, either closer or further, are going to be too blurry to see. That's how I would imagine it. I don't know.
Yeah, so like the atmosphere acts in interesting ways, and it can have various zones, various lensings that are taking place. There's a guy that comes in here often named Beerman that talked about this. Travis used to talk about this a little bit as well. So you have varying things that are taking place in the atmosphere, one of which we call lensing.
Okay.
Right, where you can,
yeah, go ahead.
Yeah, where things can actually appear very clear, but it doesn't necessarily mean that what's taking place between you and that object is not distorted in a way. Kind of when I was talking about holding up that lens that's the size of a dinner plate 10 feet away from you, and as you're looking, everything in that lens is probably going to look a little bit clearer and a little bit crisper and probably closer to you based on the fact that it's magnifying it a little bit. But that doesn't mean that between you and that object, there's nothing between you and that object. There's less obstruction or distortion or anything like that. There's actually a very large piece of glass between you and that object, but it's appearing clearer than everything else around it in the distance. That portion of your field of view, that is appearing clear.
Yeah, I suppose it doesn't seem like there would be, because like even in that example there would be a gap between where the horizon appeared to be and where that clear object was, and that gap would represent like the actual the distance wouldn't be skewed. It's like, but whereas in the observations we're talking about, like you see the top half of the ship or building, and then the bottom half is just all merged into the horizon somehow. But I go back to the test real quick, because there's something that the question I was going to ask when Gio was talking, based on something he said, but what you guys were saying, because it's like, so we were saying that the atmosphere causes the horizon to vary in distance, but from what it sounds like is that happens, because that's the same one. Our idea is same on your idea, is that the atmosphere will change where the horizon is, but what could cause the horizon is this perspective, this thing with the way that we see things, in a way that's like a spherical view of perspective. That's actually what causes the horizon, but what varies it is the atmosphere. Would that be correct?
Yeah, atmosphere varies it for sure.
But the true cause is something more to do with perspective.
Yeah, I mean, things visually appear to ramp up or ramp down due to what we typically call perspective. I don't know, what else should we call it?
Well, no, because this goes back to what
do you think
it's
refraction or the atmosphere that causes it to do that?
No, I don't. I said in both our ideas, the atmosphere just varies where the horizon will appear to be, but it's not the true cause. And that's what I was asking is so then basically, like in our model, we have the geometric horizon, which is caused by the
Where's
Earth.
the geometric horizon? Can you show me a picture of the geometric horizon?
Well, I wouldn't be able to show you a picture of it, no, but I could tell you how it's defined, because it's not describing something visual. It's describing, an observer on a surface of a object at some height, a sphere, and where the tangent line from his observation point to the surface, where that tangent point is of that tangent line. So that would represent like the furthest distance along the surface that he should be able to see, if that were the only thing that caused it. But obviously, refraction causes that.
For a moment there, Kosho, for a moment there, I thought you were actually understanding what he's been talking about for the last 10 hours, but you've just gone a full circle back to your paradigm where there's geometric measurement involved. It's not a measurement that's geometrically measurable. You just can't drop
he just asked me what it was, so I just answered the question what it was. I mean, I don't know what I was supposed to do there, but
right. Well, I just wanted to see, like, can you show me a visual representation of this geometric horizon that you speak of?
Well, I can show you like it represented in like a a drawing or something, but not an actual image that somebody took, because it's like I said, it's not going to represent where the horizon appears in the actual image, because of the fact that it's influenced by other things other than just that fact. It's caused by that fact, but it's influenced by the atmosphere.
We can agree upon that is what's taking place, is that there's things that affect that horizon, making it strictly an apparent location. So if I was you, I would refrain from trying to utilize images as proof of a geometric horizon like many globers tend to do.
I mean, I don't know. I don't know why somebody would try to do it. Like I said, the geometric horizon is strictly not even describing something that you see. But regardless, the reason I bring it up though is because I'm comparing it with what we were talking about with the perspective and how different optical properties of whatever you're using. It's what creates this effect. And so having different properties, like different zooms and different apertures and stuff like this, you should be able to adjust that. However, the atmosphere is going to be the hard limit. And so, the atmosphere is going to, make that vary for the same reason, like I said, in my idea. The only difference is the geometric horizon is the hard limit before, the atmosphere. And so it's going to cause, no matter what optics you use in our model, the horizon is going to appear to be the same distance away, because the only things that depend on are the atmosphere and the geometric horizon. Whereas it sounds like on what you're describing is the horizon can vary it, but the thing that causes it can also vary it. So you could have different optical devices giving you different obstructions even before the atmosphere is applied.
All right, let me ask you a question. What causes the ground to appear to ramp up toward your eye level in your paradigm?
Perspective.
All right, cool.
Yeah, it's just how we say. Like I was telling Gio earlier, like if you put a person in free space and you had objects in his view and like the ground wasn't even there, and you just drew vectors to each object that he was looking at, and you looked at it orthogonally, you would just basically, it appeared like it was a cone almost, whereas things that were closer to your eye level would have a smaller angle, and the bigger angles would be things that are higher or lower than your eye level. And this is how objects would appear in your image based on where those angles are. So yeah, I mean, so that's why the ground appears to ramp up.
Cool. So it appears to ramp up to a specific point.
Yeah, I would say your eye, everything below your eye level, especially the ground, since that's the main thing below your eye level, will be risen up and converge with on top of your eye level at your eye level.
Cool. So the stuff that's rising up from the bottom, is that dependent upon your height above it? How much of it you can see? Like the distance?
Well, how much of it is not, I wouldn't say how much of it you can see, but how much of it is going to be resolved. Because the angular resolution, the angular resolution is going to be what determines that. And it's going to be, obviously if you're lower to the ground, it's going to be a steeper angle, and so the resolution will be even smaller.
Becomes unresolvable, kind of like when you're looking at a chessboard or something like that, and the more acute you make that angle, the less you can make out any of the squares on the chessboard, to where the chessboard just kind of becomes a line, even though we know that contained within that band or whatever there is actual squares, even though it might just appear to be a black band. Right? Did I lose you?
Yeah, I agree completely. Yeah.
All right, cool. I think we agree upon that, man. And to me, that unresolvability into the vanishing line is what we call the horizon. And as things traverse in the distance, especially on the surface, they start to become unresolvable from that most acute angle, which would be the closest to the surface. Even though the stuff above it is still visually rendered because it is a larger angle than you have to the stuff below it.
Yeah, I've always had a problem with that though, because
I thought we just agreed.
We agreed on the principle of how perspective works, but if you use perspective to describe an image, and like let's say it's a Burj Khalifa, I would draw a picture of this, but I'll just describe it because I don't want to find it. But if you had the Burj Khalifa and you were on sea level or whatever on the ground, then the top or the 6 feet above your eyes and the 6 feet below your eyes would be the closest to your eye level, and then the ground and everything closer to you would be all below your eye level, and then the building and then the sky would be above your eye level. But it seems like your eye level would be, like I said, the 6 feet above the ground of the building, and the 6 feet above that would all be the center of your image, I would think.
Yeah.
And so given that
as it gets further away in the distance, what is the portion of the building that's closest to the ground? Wouldn't that be your most acute angle? If the ground is what's setting the horizon, right? Visually.
All right.
I mean, even if you were on a flat surface or like on a boat, right, going away from the Burj Khalifa, and you had a clear view to it all the way down to the bottom, right, as you're moving away. Let's say this scenario is possible. Do you think you would be able to tell when the bottom starts to blend with the visual horizon? Do you think you'd be able to tell the difference between the top 6 feet and the bottom 6 feet? At what point would those become unresolvable?
About 3 miles.
So you wouldn't be able to resolve the difference between the bottom of the building and 6 feet above your eye line. So really, the bottom 12 feet of the building would just kind of be unresolvable to your eye, right?
Yeah. Like basically it should be about like every 12-foot section, and then at that point would be all, or every 6-foot section of the building, or every 12-foot section would be blurred together, basically.
And with your eyes at those 3 miles, do you think you can resolve a 6-foot person 3 miles away?
No, I think that's about when they become unresolvable.
All right. So what about a 600-foot person? He'd be resolvable, right? At 3 miles?
Oh, sure, yeah.
But the bottom 6 feet of him wouldn't be, right? Because if there was a 6-foot man standing next to him, that 6-foot man would be unresolvable, thus rendering the bottom 6 feet of the 600-foot man unresolvable based on the same principle.
Yeah, right. That's what I'm saying, though, is that
so as it continues to get further away, that bottom portion starts to meld in with the horizon line. Yeah. So we get it.
Yeah, but that's
same page. All right, cool.
No, but there's a part that was missing there, and it's like I said, the building and the person, this 600-foot person, they would be every 6-foot portion of their body would blend together. So it's like you would see the person, but any section 6 feet apart would be unresolvable, and then you move further away, and those sections, it would be less and less sections that you you'd see until you finally saw just one blur of a object, and then later that would become unresolvable. But what you wouldn't see is like the top of this person to be crisp and clear, and the bottom part not be crisp and clear. Does that make sense? Like it doesn't make sense that the bottom of the building is blurred together because of this, and so you can't see it. That part makes sense, but it also makes sense that the top part would also be blurred together, still being able to be seen, but not able to see clearly. Like you'd see a blurry, building basically.
I mean, when we see boats going over the horizon, all the images that people post of boats going over the horizon are not the same scenario as the human eye, right? They're zoomed in versions of what's taking place. So that would give you a different angle to the top, or a different resolvability of the objects that are not being blended in with the horizon.
But why would there be a difference there? Because if it changed the resolvability, wouldn't it change the resolvability of that part of the building or ship or whatever too? So that was no longer blending together.
Right. So the top of the ship's not blending in with anything. What's it blending in with?
No, yeah, it's not. It's not blending in with anything. That's what I'm saying. But the bottom part would be
becomes a bump on the horizon, right?
Yeah, but if you said that you can zoom in,
the taller portions of it would continue. It's just a bump that starts to blend in to the horizon line, just like
exactly. It's like it melts into it, like the way that the train tracks. They look like they're rising up, and then you know how the train tracks, even like if you're looking at them in the distance, like they look like they're rising up, and they're kind of like pushing into the vanishing point. They're kind of running up into it, and so yeah, that's how it works. My understanding over a planar surface, when you have an object above that planar surface that's moving away, it's going to do precisely that. It's like the angle is like. I've often said like almost like Pac-Man, like Pac-Man's right at the horizon, just munching it away. And so visually the angle, you're not going to be able to see certain things at that angle. It's just going to be visually eaten up by the other available, space and the way that that's all lined up.
There's tons of information right there on that line. Tons of information. Because if you think about it, in that same horizon, let's say we take that Burj Khalifa again, and we go as far away as we can to where the Burj Khalifa is unresolvable. Now, if you have a boat that's with you as you're taking this journey, and that boat starts to go back into the shore, you realize all the information that's comprising the height of the Burj Khalifa is right there on that same level, that same horizon that boat, as it goes away from you, starts to blend into. Do you realize how much information is contained right there? It's a ton. Just kind of eats everything up, like Gio was saying.
Okay, but based on what you said a second ago, is that in the footage of these, ships being whatever, you can see the top part, you can't see the bottom part. These are using different optics. Those optics have different zooms, and that zoom allows the parts of the ship or building that was unresolvable to be resolved, which is why it appears to be crisp in these footages or videos or whatever. And that's why my question was, if that's resolvable now, then why isn't the bottom part that was unresolvable and got merged with the horizon, why is that not, why is that not treated the same way as the top of the building or ship, which is now clearly visible again?
Yeah, because in a lot of those images, you have the false horizon being presented to you due to atmospheric conditions at a short location.
Oh, sure. You admit that the horizon drops down, so you do admit there's a horizon on a flat Earth too, almost at the same spot, but off just a little bit. But I would say that so the horizon on a globe drops down. Why is it appearing like halfway in our vision, no matter where we go? But pretty much it's right there at the cutoff point.
Doesn't.
If it's dropping down,
Doesn't appear.
You do admit that the horizon is a function of vision and not Earth curve, right?
No, the horizon. It's a function of. We went over this a little bit ago.
So it's dropping down.
In our idea,
why does it appear higher?
It appears if the Earth were infinite, or if you were on the surface of the Earth, and at zero height at all, and in either of those cases, the ground would appear about almost perfectly halfway, for the fact that it's basically being
vision, right?
It's meeting up with your eye level. Your eye level line is parallel with the horizontal of the ground.
So if it's dropping down and creating a horizon, then it's certainly going to create a horizon. If it ain't dropped, I mean, it's more justified because on a flat Earth there's no drop at all.
Yeah, no, but
it appears to ramp up in our vision, but on a globe with the physical horizon dropping down, why the fuck is it appearing? You know what I'm saying? It's obviously a function of vision and not Earth curve.
No, things that are below, like I said earlier, I'll say again, things are below your eye level, they converge up to your eye level, and things above it appear down or converge down towards it.
Right.
So
not
if you're
Earth
on
curve,
the surface, if you're on the surface, yeah, but you're asking me why does it appear to rise to eye level? This is what you asked me. So this is what I'm answering. So hold on, Brian. I don't think that the horizon rises to eye level because you're on a globe. As I said, whenever Napalm asked me, that happens because of perspective. But that's not what we're trying to figure out here. We're trying to figure out why there's a horizon in the first place. Why is it that things that are on the surface of the Earth but have some sort of vertical, why are they obstructed by this thing that is the ground level of the Earth, which should always be below. It should always be below those other things in reference to your eye level.
Why would it be when you're witnessing convergence and you're talking about it and then asking why? Who knows why? That's how we see. But here's the thing: is you agree
why?
that when we zoom in, the crosshairs of a instrument, whatever, they look like they're just sitting on the horizon, but you zoom in and you see a gap, a bigger and bigger gap. So them crosshairs, no matter how far you zoom, there's always going to be a gap, right? It's just going to look bigger. It's going to optically look bigger the more you zoom in.
It depends on your elevation above the ground. Like I said, if you're on the ground, if you're perfectly on the ground, there's no reason for there to be a gap. But yeah, if you're any height, if you're perfectly on the ground, then the line that represents your eye level, the horizontal, and the horizontal of the surface are going to be two lines that are the same line, and so the bottom part of your vision is going to be taken up entirely by the ground.
Right, it's a function of distance, bro. Like I always describe this by the fog, like my half-mile horizon. It's nowhere near. I mean, it ramps up real quick, bro. It's a function of distance. So if you can only see half a mile, then there's going to be your horizon. And if you could see farther on a clearer day, but here's the thing: with your regular vision, a normal horizon is, like I said, my instrument crosshairs are going to be just on or just below or just above the water, depending on the conditions. But when I zoom in, then I get the gap, because if I'm looking out horizontally and I'm 6 foot above the surface, then that 6 foot is going to enlarge as I zoom in. In other words, that tiny gap that looks like a no gap at all, when I zoom in, I'm going to see the 6 foot a lot more with more clarity, but I'm not actually seeing further. So it's not going to change where the horizon is, because all I'm doing is magnifying what's already there, bro. You see what I'm saying?
Yeah, but no, I know, but you're bringing up something that nobody's using as a cause of anything. Like the dip of the horizon is not said to be by me or anyone I've heard today on either side to be the cause for the distance or where the horizon appears.
I wish you'd get a camera or something. I'm tempted to loan you mine, bro.
The dip, yeah, but the dip of the horizon is not in question here.
You'll see it's not Earth curve, though, man. I'm telling you, the horizon ain't Earth curve.
Yeah, but we're not saying that the dip of the horizon is caused by Earth curve. I'm saying that the horizon on my model is caused by Earth curve, and it can be adjusted by the atmosphere. And we were trying to find out what causes it. we were trying to find what causes it.
You said my model, and I'm denying it, bro. I was being sarcastic. I was just teasing with you, man.
You don't have to explain the thing. It doesn't matter, dude.
Did you see my video, bro? Did I just made the part 4 RIP spherical excess? Like I literally, like I can't believe I had to do this for grown men, but I did anyway, and explained it.
I thought you guys stopped talking about it because like you just kind of quietly realized that you were wrong and just stopped talking about it.
Bro, I literally had to put toothpicks on a globe to show y'all motherfuckers that no matter what, I showed that I lifted one string, lowered the other, I bent them backwards, I bent them forwards, that no matter what, that triangle with straight line of sight I'm trying to show that y'all are inducing an orientation change. And I even made a prediction. I said, when they see this video and I pin them down where they got to admit that the line of sight is always 180, then they're going to drop it as proof. They're going to say that, well, yeah, it's a globe. You know, we induced the orientation change in the calculation. And like y'all was saying that shit the whole time, like y'all be trying to use that as a proof of a measurement. And there is no measurement of spherical excess, and even on a globe with line of sight, unless you induce an orientation change in the mathematics. And then so y'all act like you never said that you weren't assuming a globe. That's what you're going to, like McToon and shit, he's going to be like, yeah, well, we know we're on a globe, so we calculated in the orientation change, you know, act like it was just part of it the whole time.
That's not necessary. There's no orientation change. I've said this to you every time you brought this up. I forgot that you were utterly confused about the whole thing, but we and Bacon went over this, or I don't remember who it was, but we went over this several times. They're taking a line of sight observations, but they're not taking the angular separation between these two positions. They're taking only the horizontal component of that angular separation between these two positions.
Right.
So using that fact, so the toothpick thing that you're talking about, like we said, getting the angular separation between the other 2 points of the toothpick would be an incorrect way of taking the measurement. When they're doing is they're taking the azimuth. They're taking the azimuth from one toothpick to the other toothpick.
Right. I'm only showing azimuthal freaking measurements, okay? And they're all freaking adding up to 180 no matter how you orientate it. You're talking about horizontal only, azimuthal only. So that's my point. Don't try and steal my damn point, bro. My point is it's spread anyway. And the fact of the matter is that even on a globe, the line of sight is going to give you 180 no matter how. Anyway, just watch the video, bro. It's a short video. It's 3 minutes. And no matter how I turned the toothpicks, no matter how I angled them, no matter how I did one side high, the other low, that triangle added up to 180 no matter what. And even on a globe, if you're dealing with line of sight, the string line represents that line of sight. And so, you know, I don't know. Like I said, they're going to say that. I mean, just look in the calculations, man. It's using the radius for or the curvature for the 39th latitude and shit, man. It's
Brian.
What?
Yeah, Brian. You keep saying that you did strings and you made triangles from them. If you're doing
represent line of sight, pal.
Yeah, but you can take a line of sight to something and you can record only the azimuth, and the strings would not be able to describe that for you. You wouldn't be able to use strings to describe that unless you wrap those strings along the surface.
Stations, bro. They measure they measure the angle from one station to the next, from each station. They go to one station and measure the angle between the two. The azimuths are pretty much recorded in with the mass and all that stuff, and with the orientation change. I mean, I don't know what you don't understand about
azimuth. The azimuth is just the horizontal component of that measurement. That's all it is.
Nobody's arguing that it's not the horizontal component, bro. So you can quit saying.
Well, you're right. So, but whatever you did with strings wouldn't be able to represent that. You can't represent that using those strings that you had. That's not going to do that unless you.
I can do them. I can do a 360-degree azimuth with the strings, bro. With just a few triangles. What are you talking about?
Yeah, if you wrap those strings on the surface, you can do that. But those the azimuth is only going to be it's going to follow the direction of where those other toothpicks are only if you wrap that string around the surface, not if you make a straight line to it.
So only if line of sight. So only if them strings represent our straight line of sight, right?
Oh, so I said you can't do the actual measurement with strings. In order, if you want to represent it in actuality, you'd have to make it with like something that had two axes of rotation, and you would point it at one thing and then the other thing, and you would record only one of those axes of rotation. If you did it like that, then you represent.
I did it individually, bro. I did 3 of them individually. I did one angle to 1 to 2, one to the other 2, and one to the other 2. I did it. I knew you was gonna say that shit, bro.
Yeah, but how can you represent that with strings? And you can't represent that with triangles and strings.
Bro, listen to me. If the string line or laser eyes, whatever you want to call it, okay, represent, okay, and I even showed the spherical triangle on the ground underneath on the globe. But as far as the line of sight goes, the ground doesn't matter in these readings, bro. That's what I'm trying to tell you. The ground doesn't matter in these angle readings. They're line of sight, okay? And with line of sight is always going to be 180, even on a globe. And I'll show you in the video. So I'm just going to post it in live chat, and you can watch it and then criticize it.
You keep saying that you agree, and then the thing you describe is not at all in line with what I've said. So whenever I said that they take the horizontal component of the line of sight positions of the so it's like if you were to take the angular separation of the other two sides, you would point the theodolite at both locations and then measure the angular separation between them. But if you were looking only at the horizontal,
that's exactly what they said.
But if you were only looking at the horizontal component of that angular separation, you would set it so that your vertical, or you would set it so that these were two different recordings. There'd be one axis that were rotating it. There'd be one axis that were rotating it horizontally, and one axis that's rotating vertically. And
I'm not talking about vertical, bro.
And you would look only at the horizontal component of that. So in doing this, Brian, hold on, dude. In doing this, you could representing it with strings and line of sight is not going to represent the that measurement. That doesn't make sense.
So we got stations A, B, and C. Are you telling me that from A, what's recorded in the data ain't the angle between B and C?
Yeah, it's not the angular separation between them. It's only the horizontal component of the angular separation between them.
I still recommend you watch this video. But anyway, what McToon said over and over is that these measured triangles from mountaintops, line of sight, measured triangles, okay, are more than 180, okay? That is not the case. Even on a globe, these triangles, I don't care if you want to do something different than a fucking line of sight triangle, bro, that's on you. What I'm talking about is the triangles, and they add up to 360. They can't add up to no more than that. But anyway, I would still recommend you watch the video. It's just a few minutes long, and then criticize it after. But I'll post it.
I'm not criticizing the video. I mean, I won't watch it. I'm not criticizing. I'm just criticizing your idea of what's happening. But yeah, let me pull it up. You haven't posted it, so I gotta find it.
I'll post it right now.
Yeah, I was surprised. Like I said, I thought that because every day, like, new claims were being made about. Okay, there you go. Not by you. You were making the same claim the whole time, which is, like I said, fundamentally incorrect. But other people were making new claims. But like, doing intensive research on everything that everyone said on it, all that was found out was everything that's been said about them being averages, and of the actual measurements, and those are in the paper. That's 100% true. There's no other assumptions or corrections made on them before they post them. They just take the average, and they
they're reconciling it at the 39th latitude. It'd be different if they were at another latitude, right, Coach?
They would get different answers, if that's what you mean.
Yeah, they would. They would have to invoke different orientations.
No. Okay, dude. The orientation. None of that stuff is. Hold on.
Well,
I'm looking at your video.
Well, I wanted to ask
Go ahead,
Geo real
Arnold.
fast. Geo, are we not allowed to post videos in the live stream chat? The bot is telling me, oh, we can't. We're not, doing your video thingy because
it does that. It does that sometimes, man. Just wait a second and repost it.
How big is your video?
It's well, no, it's a good size, but in fact, I think it's only like
How big is it? It's like what?
It's hold on. Yeah, 1.2 megabytes.
It's 1.2 megabytes. Okay, that's not big at all.
Yeah, that's what I'm saying. Like, but like for whatever reason, it's the bot is just being weird. It's like, hey, we don't want to post your video. Let me see, maybe I can change it.
Hey Brian, what are those patties you put on that globe?
No, it's putty.
That clay? Oh, that putty? Like silly putty?
Yeah. Like big red bubblegum putty.
Yeah, I have a whole bunch of that. I guess it does. Yeah, it does look like if you must have had that for a while because it looks like it looks a little darker.
Yeah, I save it, man. It comes in handy, bro. It's kind of nasty to talk about, I guess, but it's just like putty, bro.
Well, no, I mean, I have a whole bunch of it too, dude. I have the Ferris kind too. Like you can like wrap it around wrap around a magnet or whatever. But yeah, I see. I mean, that's exactly. I'm watching what you're showing, and it's exactly what I was responding to. So it's not showing me anything different than what we're saying. It's like what you're showing.
Even if it is what you're saying, like even if it's something different than what I'm talking about, I'm still responding to to McToon and them, how they said that line of sight triangles on a globe. You know what I'm saying? So even if it does turn out to be something, whatever, we could talk about that. But which I'm going to look into. But it's still responding to the claim they've been making the whole time, right?
Yeah, I mean, like I said, I can't really speak on something somebody else was saying that I didn't hear, but definitely, if like the way I'm describing it is the way I understand it, and I happen to understand it as being correct. So if somebody's saying something different, then they're either leaving something out or maybe getting it wrong or whatever. But yeah, because it's true that the triangles, created are going to be line of sight to the other stations. But the angle you're taking, like I said, it's not like if it were an angular separation, you should be able to get like a sextant to get the spherical axis. But just give me a second.
No,
Brian.
I'm saying, what's the point in measuring a straight line 180-degree triangle?
Give me just 1 second, Brian, because they don't do that. Is my point.
They don't measure it. Okay.
So, it's like if you got a sextant and you measured the angle between one site and the other site, and you did this all three sites, you'd end up with 180 degrees, because that's the angular separation between these positions, right? But they're not looking at the angular separation between them. They're looking at the horizontal component of that, the azimuthal separation, angular separation.
And that like I'm showing anything other than that. I'm showing the azimuthal.
No, but you're not, because the azimuthal separation would be the one that runs along the surface.
The sextant would not be. The sextant would not be an azimuthal triangle measurement.
Right. Exactly. It would just be
so a flat triangle, a plane, 3 coplanar points.
Yeah, but what you're showing with strings, like what you're showing with the strings, this would be like what you would obtain if you used a sextant to measure the distance between them, the angular separation between them, not the azimuthal separation.
I'm talking about the sextant measurements. Like if you're if you're measuring like the vertical height and shit like that, then you're deviate from horizontal, right?
So there's a difference between azimuthal readings and like elevation readings. So you have like the sextant would give you an elevation angle, and an azimuthal angle would be horizontal.
Well, Brian.
Well, no, yeah. Well, yeah. Go ahead and say it.
Brian, with your picture of the globe and your clay and those sticks, that shows that you can have a 180 triangle on a sphere.
Yeah, that's my point.
Axis. Is that, we all agree, I think we all agree to that, Brian. Is that your point?
Yeah, the thing I'm arguing against is them saying that they over and over. I heard from MC Toon, okay, from from Fight the Flat Earth, from them, that they're measuring the two other stations, measuring the angles from 3 stations, adding them together, getting more than 360. And I'm showing that even on a globe, that over and over they made that claim that the triangle add up to more than 180 degrees. The angles between them. He even elaborates on it on that.
Well, they elaborate in the wrong way, because the way I've explained it to try to get people to understand how the spherical axis is determined, you have 3 triangles on those 3 sticks. And then you take one angle from each of those triangles and add them together. That will be greater than 180.
That's what I'm saying. There's 3 stations. You take
3 triangles.
That's not what's reported. They're reporting station.
I know, because that's how I have to explain it to you. But then what they do then is have multiple. Now you have add 2 more triangles to that one you have on the globe. Add 2 more, and then take one angle from each of those triangles and add them together.
The triangle represents a semicircle, right? The triangle represents a semicircle.
Hold on, Zanik. I think it might be important for you to further describe those triangles, because they're not just any triangles. Those triangles are horizontal at each of those. Like, it's a triangle created such that it's parallel to your horizontal, and the other points are along the verticals of the same of the other 2 points. Like each of the 3 triangles that Zanik is talking about are horizontal from each position.
Right. They're all horizontal. They're all attached and have a common two vertices. Each one has a common 2 vertices, and then they add one angle from each triangle together, and they get the spherical axis.
Can you show me where they're doing that?
Specific angles, because they have to be the complementary angles. They just can't be random. That wouldn't be fair.
I'm good with the fact they're making assumptions like that, bro, and shit, bro.
Not an assumption. It's what they measure.
Here's my thing. The triangles that we measure add up to 180.
There's no such thing as a spherical excess triangle based on observations from 3 points of line of sight.
Correct. And
physically
I've been saying
impossible.
that for weeks now. I've been saying that for weeks. You do not get spherical excess by one triangle. Now, those 3 poles, Brian, if you took those 3 poles, those pencils that are sticking out of the clay, and you made 3 more triangles, or 2 more triangles, that one a little higher than a yellow stick and one on the very tip of the yellow stick, 3 triangles all on top of each other, and then grab one angle from each of the triangles different and add them together, they will be greater than 180. If the surface was flat, they'd all equal 180. That's what spherical excess talks about. That's been glazed over by everybody I've heard talk about it since this thing started. But I will agree with you. Any triangle made on a sphere.
So are they measuring elevation as well?
All triangles made on a sphere, line of sight, will always add up to exactly 180.
In this survey, were they doing azimuth and elevation and or altitude angles?
Multiple triangles, all sharing common vertices.
Listen, we could do it a full circle, guys. We don't have to just share sides. We can do a full circle sweep of the azimuth, and on a flat Earth or a globe, we're going to get 360 degrees.
Correct.
If we share a line on every triangle and do a full circle on a flat Earth or a globe, if we're dealing with line of sight, we're going to get a 360 sweep.
No, you absolutely will not, and that's where spherical excess comes into. So you should probably look into that a little closer, Brian. Do your exam. Hold on. Do your model there. Maybe make smaller triangles and string like 5 triangles together. Grab the complementary angles, to be fair, and see if those add up to how many triangles you actually add up to. You get 3 angles, you'd be 180. If it'll be more like 6 angles, you should get 360, and then so on. And you'll see
you'll always get 360 if they're line of sight.
They'll be line of sight. Always. They won't, because that's where you get into these complementary angles that aren't going to be adding up to exactly 90. And for example, in a 245 degree.
Bro, if they're line of sight, they're going to be 180. I don't know what I got to do to explain this.
You cannot make 2 45-degree triangles on that sphere. It won't work.
What are you even talking about, Zanik? You're not even addressing what he's saying.
If you had 2 30-degree triangles, equal.
Who measured that? Can you give an example? You're just throwing bullshit out there.
I'm just giving you the concept. You're fighting the concept of multiple triangles tied together at the vertices. Multiple triangles will give you spherical excess. And that's why I give you the example of the three
out of line of
triangles
sight.
on top of each other, all line of sight on top of each other. So three line. Let's
On
start
top.
there.
What do you mean by? Hold on.
You can't pass square one.
Hold on.
Square one is
Hold on.
Why?
I'm just going to keep
Why?
saying it until you slow your roll. So when you say on top of each other, are you measuring elevation or altitude angles as well?
No.
So what are you putting on top of one another?
The triangle. One triangle at the bottom of. Look at Brian's picture. I'll talk you through it. Brian's picture: clay, sticks, string, all line of sight. Bottom of that yellow pencil, triangle 1. That's a position we'll call A, B, and C, like the drawing I post all the time has. A, B, and C are those. It's called the yellow pencil A. A, B, and C are those pencils, and those are the angles that we're going to be looking at. Now we're going to have another triangle, a little higher on that triangle, mid stick, connecting all three, all line of sight. Then one on the very top of the stick, which is A, connecting all three pencils. 3 triangles on top of one another. Now you're going to take one angle from each of those triangles and add them together. And if those 6 were parallel, those angles would add up to 180. Because they're not parallel, those angles will not add up to 180, and that is what spherical excess is.
How are you measuring?
He's declaring they're not parallel. He's just declaring that.
No, you don't have
That's
to.
what's in contention, bro.
Don't read into it. Just measure the angles. You can do it yourself. Measure the angles. They will not add up to 180.
How are you measuring an angle, top, bottom, whatever you're talking about? So when they're doing these observations, it's to mountain peaks, right?
Oh, you won't listen. You can't take the steps.
I'm asking you a question. It's not that I'm listening. I understand what you are saying.
What am I saying?
You how they physically
Show me you understand.
did what you are saying conceptually.
No, it's the concept. How they do it is the 3 connecting triangles on the surface.
How did they do that?
Line of sight measurements to these angles.
To what? The base of the mountain?
No,
and
it doesn't
then
matter.
the peak
No,
of
it
the
doesn't matter
mountain?
where they measure. Each triangle is unique. The elevation does not matter.
Then how can you have
because you're
3
not
different
listening.
Dude, let me
Napalm,
fucking
you're not stopping and listening until you can understand the 3 top and top triangles, the 3 triangles on top of another. Until you understand why that works, you'll never understand the connected triangles.
Let him ask his
not
question,
that I
though.
don't understand it.
Then tell me how you understand it. Then explain
This is
to
all
me
you're here
what
to
it means.
do is to agitate me. So I'm just going to chill out. So it's not that I don't understand it. It's the
I think you
fact
don't.
that you're not listening to me when I
am
ask
listening.
you how you apparently have the inability to listen. I don't know if
I
it's
am
like
listening. I know
lack of
exactly what you're saying.
comprehension on your side. Like I don't know if you just don't understand how to listen to people. Maybe
I'm
it's a lack
listening
of
to you.
education in how to actively listen.
Okay, instead of trying to
One thing my
browbeat me,
grandfather
I
told me
understand,
is he
Napalm.
said you can't learn anything when your mouth is moving, right? So when your mouth is moving, you can't really learn anything. So if you want to learn something, Zanuck, maybe you should stop moving your mouth. And then maybe we can have a productive conversation. Because I want you to understand this. I know it's not an easy concept, but I want you to understand it, okay? And what I'm trying to say is if you're measuring 3 different triangles on Brian's little thing there, right? And we're taking the pencils. If there were actual little people that were making measurements to these pencils, they would have to be at varying elevations, or they would have to be measuring multiple points on those pencils. So
you don't
can you
understand. You're
explain to
completely
me
wrong.
within this
That is not
survey
what I said.
how you can
These
measure
people
3 different elevations of triangles from the exact same 3 points? How can we get 3 different triangles if we're at the peak of each mountain and we're just making measurements to the peak of each mountain? How are we getting 3 different triangles?
You have poles, you have different heights above the surface.
So they're making a line of sight measurement to a what? Like a story pole?
Story pole, yes. Bottom of the story pole, middle story pole, top of the story pole. Every one of those has a triangle, regardless of the elevation contrast between any of those locations.
How high were the story poles they used?
They didn't use story poles. He's just making shit up.
You're not getting it. They don't use story. This is how you understand.
You just said story poles.
No, I'm saying how you would do it. Story pole.
How did they do it?
You haven't showed me. So if you said you're listening and you understand, explain to me why we need 3 triangles on top of one another and how we do it. Go ahead. And why we do it.
I'm asking you how you measure those three triangles.
Line of sight.
Line of sight to what?
To the opposing two poles.
Poles? So there's poles involved. I thought you said there wasn't.
No, there are the pencils are the poles. Yes, those are the poles. We're making three triangles. We're trying to explain to you how this works.
I was talking about the
survey.
survey.
The survey's three triangles, not on the same poles. Three different triangles, other places. I'm trying to help you understand how this is done and why it works. You said you understand, but yet you have not been able to explain to me what I mean.
Do understand. I do understand.
In order
to have
how it works.
Three different triangles.
Tell me why I have three triangles tied to each other. Go ahead.
You have three triangles tied to each other.
Three triangles on top of each other. Why do I have three triangles on top of each other?
Line of sight, the triangles will never intrude on each other as long as it's. You can draw it out on the ground and change orientation and get them to intrude on each other.
It's mind-boggling. Everyone says they understand.
You're not good at talk, bro. You can't help it. It's like when you hear me speak, bro, you just have to start puking on me.
That's all he does, because he has no actual argument. He just tries to run over people when they're talking and then act like they don't know.
Frustrated because
and he has no actual argument. Because when you press him for the details, he can't actually explain how the three different triangles were measured that are on top of one another in his claim. And then I understand you connect three different points based on three different triangles, right? So you have three layers of triangles, and then you're connecting 3 points within those three layers of triangles. But how are those three layers of triangles measured via line of sight, Zanuck?
Yeah, that right. Three triangles on top of one another. Points? No, not points. Three angles. Every triangle has three angles. That means you have a total of 9
Oh, is
angles.
that what triangle means? Three angles? So
you said point.
Angles?
Point. What point?
Gee, thanks for teaching me
point.
that.
Why'd you say point? There's no points we're measuring. We're measuring angles, only angles. So tell me if you understand this. Three triangles.
The station is the point, Zanuck. The station represents.
Okay, then what do we do at that station?
Yeah.
Tell me what triangles we actually add together to get greater than 180. Go ahead.
They will not overlap.
Napalm,
with line of sight.
I have one question for you, and I'm out. Yellow pencil is point A, is a point or pole A. Point A. We'll call it point A. Vertex A. And then the other one on top of the left is going to be B, and the bottom one is going to be C. We have three triangles, all line of sight measured. Three triangles. Tell me how we would get measure spherical excess, Napalm, if you understand what I'm saying.
Okay. I can cover that whole ball.
No, I didn't ask you, Brian.
No, don't interrupt me, dude. For fuck's sake, shut the fuck up.
Is your name Napalm?
No, let me answer, man. I can cover that
whole... I
asked
Napalm because he said he understood.
I can cover that whole globe with triangles, bro. And they're all going to be 180. As long as they're line of sight, they're all going to be 180. They're not going to intrude on each other. Now, when you draw them on the globe itself, or if I induce an orientation change, I can overlap them and intrude on each other. I can cover that whole globe with triangles. As long as they're line of sight, they'll all be 180 triangles. What the fuck don't you understand about that?
I just temporarily muted you, Zanuck. I'm going to try to moderate this since I'm not involved in the conversation, and then Napalm could actually engage with you as well.
Thank you.
And not feel like he needs to moderate himself or moderate you.
Brian,
but yeah, it doesn't have to be that you're directing it and teaching everybody everything. Even though I don't know if you can handle it any other way, but try to just like have a conversation, Zanuck. You're not teaching anything to these guys. I'm very aware, as well as you should be, that Napalm and Brian understand this stuff way more than most flat earthers. So don't act like they're stupid as a tactic, and it'll be much more enjoyable to listen.
Well, Brian just showed that he doesn't
understand. I'm going to unmute you now. Okay. Well, Napalm, Brian, anything you want to say before I unmute him?
I'm actually disengaging from Zanuck because there's no such thing as a productive conversation with him.
There is, but you let.
Well, you were doing a great job, and in fact, it'd be interesting to hear if he's actually.
He's not actually going to answer it. That's the problem. He's going to come back with some condescending thing.
No,
as
I'm not.
If I don't understand his three stack triangles. You're literally over talking me as I'm speaking to the mod.
Because I've been trying to get in for 10 minutes
This is why I'm going to dude. I'm giving you a warning to where if you continue this, you're going to get an actual warning.
All right. Here I go, real quick. Brian was not correct. He completely got it wrong by saying that.
Now you think that's your time to come in?
Well, yeah, I
Well,
thought I was.
I can't hear him now. Was it me that muted him just for myself?
Yeah, you muted him for himself. I actually did just step back from the conversation and server mute him when he was over talking Brian.
Right.
So when you stepped in to say you muted him, I was like,
I have to go, so I want to tell you my piece before I leave. Before I go, is it okay? Can I say my piece real quick? Because I got to go. Seriously, Napalm, Brian didn't have it right at all. I'm told you what the situation was. You have 3 triangles, all on top of each other, all line of sight, all measured to be triangles individually. They don't share the same lines. They share the same vertices, but they don't share the same connections at all.
Were those triangles, were those measurements taken from different elevations from each specific point in that triangle? The 3 points, I'm meaning the three points that make up the triangle. If you're claiming that there's 3 different triangles on top of one another, that would allude to various elevations.
Correct. They're all different heights on the poles at those 3 locations.
No, I'm not talking about Brian's globe with the
Well, that's the only way I can explain to you where you can see it visually. We have 3 poles.
I'm very good at drawing a visual in my mind.
Three poles, all pointing straight up, plumb lines, all 100 feet. We make a connection at the base for all 3 mountaintops. We make a connection for the midpoint, all 3 mountaintops, regardless of where they are in respect to one another, altitude-wise or elevation-wise. And we connect all the tops of those poles, all 3 points. Those are 3 separate triangles. All of them will add up to 180. Every single one of them.
When you say base, middle, and top of what?
The pole, if my God, Napion, 3 poles on 3 mountaintops, all plumb lines, 100 feet high. One point measured from the base to the base of another mountain to the base of a third mountain. That's one triangle, 180. Midpoints, starting point A to B to C, midpoint triangle, all 180. Tops of those poles, 50 feet higher, A, B, C, another 180. No spherical excess there. All of them add up to 180. They're all different triangles. Well, we think, we can suppose, we don't know. We won't know until we add the triangles that would give us spherical excess. The spherical excess is measured by taking a triangle from each one of those contributing triangles and adding them together. Now, if those poles are parallel, they will add up to 180. If they're not parallel, there'll be spherical excess. That's not how they did it. That's how you understand what's happening. And now you extrapolate that technique and that logic to multiple triangles that are connected at their common vertices.
Gotcha. So how did they make these multiple elevation measurements? You said 100 feet. Did they actually have 100-foot plumb bob, and at the base of it they were making a measurement? 50 feet up they were making a measurement, and then 100 feet up making a measurement? Did they have this apparatus that was constructed at the mountain peaks, each 3 mountain peaks?
No, you missed it. I told you this is an example to understand the concept, how they measure.
How did they do it? My question is how they did it within this fucking survey.
I can't be any more clear. They didn't do it.
Explain.
No one's measured 3. Well, maybe they have, but no one. I'm not talking about anyone who's measured 3 sandwiched triangles.
You're avoiding the question. Can you answer?
The point is to understand why they do it.
I understand the concept. I understand what you're talking about, and I understand why they would or would not do it. How did they do it?
They didn't do it. It is a thought experiment.
Thank you. That's all I need to know. I'm done.
Yeah. Then they take that concept and measure multiple triangles that are connected at those common vertices and baselines. 3 or more, or even as many as you want, you can add those complementary angles and contribute one triangle to each of them, and you'll find out that those angles do not add up to 180. You're just not understanding it. I mean, I don't know what the problem is.
Yeah, I don't get why you don't understand that I understand the concept. I just want to know how it was physically done in reality, not just conceptually.
Well,
I
when I told you
understand
clearly that it was an example to show how they do this to understand the concept logically, and then you
Oh.
said, how do they
An
measure
example
those
of how they
poles?
do this.
Wait,
Can
I'm
you give me
talking, you're
that?
talking over me.
Can you give me that? An example of how they do this?
Yes. So that concept is used when they connect, I feel like I broke a record, multiple triangles from mountaintop to mountaintop to mountaintop, and another triangle mountaintop, 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 and another triangle mountaintop, mountaintop, and add those angles together and see if it can actually give you spherical excess. They're not on top of each other. That was an example to understand the logic. Brian came and said he understood it. He goes, I measured all these line of sights and they all do 180. And he's right. Any line of sight triangle will be 180. That's not how spherical excess works. It's your line of sight. I don't think you're getting it, but you might. I don't know. It doesn't sound like you are.
This is hilarious.
Well, if you ask me how they do it with those poles and stack the
I
triangles
find it
together,
funny that this is what you guys have used for years as your measurement of Earth curvature. Oh, the House of Cards has been just completely destroyed over the past few months.
What you talking about, Willis? What we talking about? Earth curve what? Earth curve these nuts, that's why, right? Zip it. I'm just fucking with it. But so what are you talking about, though? I really have no idea what the hell you're talking about.
Really? I got it here a couple seconds ago. They're clearly talking about spherical excess.
Oh,
yeah,
okay.
It's hilarious.
No, because I'm just sort of half and half right now. So I'm debating with this one guy in the chat.
It's not one guy. It's Gleam.
Gleam. I mean,
why bother?
I think the context is he's missing the context. Because I think I could be wrong. I just kind of skimmed through it, but I think the context is when it comes to reverse engineering a 2D image, right? Of like an image like a 2D thing of a 3D scene or whatever. Like for example, like I took a picture of like I don't know a bunch of trees and shit, right? If you're trying to reverse engineer that, and try to figure out the object's distance and all that, that's kind of hard to do. But I was talking about that foreshortening kind of effect where things kind of look flat the further they are, and I'm trying to tell Gleam that that's understood. I mean, Lily Blender does it. I mean, it's obviously understood. I think we're having two different conversations, and I don't think he realizes that. But yeah, I could be wrong though. But from what I've skimmed through, though, it does seem that it's a weird reverse engineering thing. But anyway, that's what's happening in the chat. But so what Napalm here though was talking about spherical. What was it? Excess? Because I was kind of only half listening really.
Yeah.
Okay.
It's funny. You get so what you do is you have three triangles that are on top of each other, right? At various elevations, but you don't measure the elevations. You don't measure like a bottom, a middle, and a top and connect all of them. You just do that conceptually. Your measurements are actually done line of sight and you get 180, but then you conceptually imagine what would take place on a globe with a specific radius where those measurements that you're getting line of sight 180 on would have three different triangles of different elevations, and you connect the one point from each of the three triangles together to get a spherical excess triangle. It's pretty cool.
They're just measuring the azimuths.
Right. And when you do line of sight measurements of azimuth, do you get a triangle with greater than 180 degrees?
If you add up those angles, you get more than 180 for big triangles.
Nope. You have to have three triangles of varying elevation.
3 azimuths.
Yeah, 3 azimuths of varying elevation.
But you don't actually doesn't matter, does it?
But you don't actually measure the 3 triangles of varying elevation. You just assume that there's deviations in the plumb lines that make up the points of these.
You don't have to assume that. If the azimuths are exceeding 180, you don't have to assume that.
But they don't exceed 180. Not when you just measure you have the line of sight measurements.
It does for big triangles.
Can you explain to me how a line of sight measurement of 3 angles, line of sight, mountain peaks, can ever add up to something other than 180?
Yeah, sure. You're reading azimuths, and the verticals are not parallel.
Oh,
that's not going to add up to 180.
So how are you determining that the verticals are not parallel?
By adding the azimuths.
But the azimuths add to 180.
Not the bigger triangles, no.
Yeah, they do. That's the problem.
No, the big triangles don't. The small ones do, and they fluctuate a lot. So the fluctuation goes beyond and below 180.
So the big
once
triangle,
you get a bigger triangle, that fluctuation is entirely above the axis, so you don't get any 180 degrees.
Are the big triangles the line of sight?
I don't know.
So how are you measuring the big triangles?
Probably the same way you're measuring the small triangles. I haven't seen anyone saying they were measured differently.
That's line of sight, sir. That's why you hesitated.
Huh?
The question is, was it line of sight? Small, big,
I said
medium?
I said I didn't know.
Yeah, I'm telling you. Yeah, you listen? Yeah, you did hesitate. But I am telling you, since you don't know, it's line of sight. That's what he's telling you. You're just not listening.
Well, he didn't say the bigger triangles are also line of sight. He was asking, but if it is, then that's in my point. That makes my point, not his.
How are you ever going to have a line of sight triangle of azimuths that don't add up to 180?
You don't need a triangle. You just need 3 azimuths. If you add
can
up,
can you draw this out for me? Like,
sure, I have done that on Blender. Let me see if I still have saved it. If you have 3 points and the verticals are not parallel, you don't get 180 when you take the azimuths, because the azimuths are the angles pivoted on those verticals.
You're just taking a visual line of sight azimuth.
That doesn't matter.
Non-parallel is what's in contention, bro. You can't just assume that.
Huh? No, I'm not assuming. He's asking how could they exceed 180? They could exceed 180 if the verticals weren't parallel. That's how they could exceed 180. So if they do exceed 180, that demonstrates that the verticals aren't parallel. I have this one I did for Brian.
But a line of sight, mountaintop to mountaintop, how are you ever going to measure a triangle that's greater than...
You're measuring a triangle, you're measuring 3 azimuths.
Yeah.
Yeah, so the 3 azimuths add up to more than 180.
That's not what takes place. Even Zanuck admitted that. He says you have to have 3 different triangles of varying elevations, and then you connect points.
That's why I didn't say you're measuring a triangle. I said you're just measure the azimuths.
Yeah, it's the same. Up. It's the same azimuth. Here's the problem, Bacon. It's the same azimuth angles, but what you're doing is you're creating elevation between them, and then you're taking different elevations. So a single point, so let's say the top triangle, the highest elevation, we use point A, and then the middle elevation we use point B, and then the lowest elevation we use point C. Now we connect those points between the varying elevations, and that's where we get the spherical axis. But we don't actually measure line of sight the 3 different triangles that we're connecting together the points. We just assume that if there was varying elevations for these 3 triangles, if the plumb lines were not parallel, based on our assumption, then we would be able to calculate what the spherical excess would be for these triangles based on the distance.
Yeah, I'm not talking about calculating them. I'm talking about measuring it, right?
I thought all measurements were calculations anyways, so it works out perfectly. This is how the Earth was measured to be a globe, conceptually, not in reality, though.
No, if you're measuring azimuths, and you're adding them up, they don't add to 180.
I wish that was the case. But according to Zanuck, there's 3 different elevations of azimuthal angles, but you only measure one elevation of azimuth angles, but you assume that there's 3 different ones with the points of each elevation varying based on the assumption of a non-parallel plumb line between the locations. Non-measured, we didn't measure a deviation in the parallels. It's assumed. Yeah, the
azimuths were measured.
Correct.
Right, so if they add up to more than 180, then it implies the verticals aren't. So if they add up to more than 180, that implies that if they add up to more than 180, it implies the verticals aren't parallel. Otherwise, they would add up to 180.
But they're not measured that way, though.
Zanuck said what way?
That it's not.
I didn't specify how they were measured.
Oh, I thought you said it was a line of sight measurement.
No, I thought Rakia said you said that. I didn't say that, and Rakia said that you say that, and I wasn't paying attention. So I guess you said it.
And how did they make these measurements? How did they make these measurements in the survey?
Well, when you asked me, my answer was I don't know. And then Rakia said that it was line of sight, and I wasn't paying attention to what you were.
That's not what I said. I said he was saying it was line of sight, and I asked you if you knew, and you said you didn't know if it was. Yeah, exactly. You don't have to interrupt me when I'm telling you exactly what happened. You don't have to interrupt anyone.
So you agreed
really.
with me.
Why are you interrupting?
So you agreed with me.
No, I don't agree with you. Stop interrupting me.
That's just what I said.
Stop interrupting me. Thank you. If you're making line of sight measurements, then it can't be more than 180, right?
Of course it can.
Oh my God.
Yeah, the azimuths can exceed 180 if they're if the verticals aren't parallel. So here's an example.
I don't think he gets it, Rakia.
I know he doesn't get it. He already admitted he doesn't even know if they're using line of sight, and then says if they are using line of sight, then it can add up to more than 180. You don't know what you're talking about.
I never said if they were.
And then when you say exactly what he says, I never said that. If they're measuring line of sight azimuth,
you can go to the live stream and prove me wrong.
You're cutting me off again. If they're measuring line of sight. If they're measuring line of sight azimuth zenith angles, right? That's what you said, right? If you don't even know if they're using line of sight.
I wasn't. Oh my God. Yeah. Are you asking me a question you want me to answer or not?
Nah, you sound asking me a question. Keep going, bro. You're doing good. Sorry, I butted in.
So I'm gonna answer the question you asked me. You didn't allow me to answer. So I didn't mention line of sight. I didn't care. I wasn't appealing to the measuring line of sight or not. All I said, if you're adding up the 3 azimuths and the verticals aren't parallel, you're going to get 180. Regardless on if you're using line of sight or not, if you have 3 azimuths between 3 points, I don't care how you're measuring it. I wasn't appealing for that.
How do you measure or not they did line of sight,
so whether or not, I think you're interrupting me.
Rocky, let him finish.
Yeah.
Who said that?
So whether or not they were,
where the frick were you for the last 10 minutes? So we're talking about measuring line of sight, mountaintop to mountaintop, right? Isn't that the context?
I don't know, but you're interrupting him, and you.
Yeah, I know, but I'm trying to clarify so we don't waste more time with y'all people.
But that's what bacon.
I don't have that excuse.
Mountaintop to mountaintop, we're talking about line of sight measurements, right?
Right. Yeah. But that's
okay. So
that doesn't change anything. Yeah, but that's
that you don't know if it's line of sight or not.
Yeah, but
when they definitely have to.
I said many times I didn't know.
Mountaintop to mountaintop. So is it line of sight or not?
No. I said many times and I don't know. And according to you, apparently they were, and according to Napalm.
No, I'm asking you if they're mountaintop to mountaintop, how would they be measured if they weren't line of sight? That's the question to you that you keep avoiding.
I don't know. I have no idea. I don't know why
you don't know.
How's that relevant?
There you go.
No.
He doesn't know. Thank you.
Yeah, I already said it, like that's the fourth time we say that. And I don't see the relevance of that actually.
So Napalm, do you think that Bacon just doesn't understand, or does it seem like he's actually trying to obfuscate the point?
Me and Napalm were having a back and forth before I interjected. Maybe Napalm can continue his point.
I don't know, but it's kind of funny because, like, Zanuck was trying to tell me I didn't understand, even though I perfectly articulated his exact point back to him. And then
and asking a question means you don't understand because you're asking a question.
Right. But my question was literally, how was the measurement obtained in reality? And then he went back to, well, it's only conceptual. So I guess no measurement was actually made in reality, according to Zanuck. And then when Bacon comes in, I'm explaining Zanuck's explanation as to what took place. And I'm asking, how were the measurements made? He doesn't know, but he can tell me how you measure spherical excess on a plane or a globe. But can you do that with line of sight? Would be my next question to Bacon. Can you make a line of sight measurement from based on 3 mountain peaks that equals more than 180?
I was asking like if it's practical or if it would still add up to more than 180.
I'm asking you if it's physically possible within the reality in which you and I reside for somebody to obtain azimuth angles from 3 different mountain peaks to one another and come up with anything other than 180 degrees when it's solely based off of line of sight azimuth angles.
Yeah, I'm not sure about the practicality of doing the measurement itself. Like if it's too far, you wouldn't see or something like that. But if you can get line of sight to a big enough distance between 3 points, and the verticals aren't parallel, then you would get more than 180 degrees when you add up the azimuths.
So I didn't ask about verticals being parallel. That would require another measurement. Would you agree?
No, if you're adding up 3 azimuths and they add up to 180, that demonstrates that the verticals aren't parallel.
So let me restate this again. Is it possible in our physical reality to make 3 azimuth measurements and have them equal more than 180?
Yeah.
Has it been done?
Yes. I'm not sure if it has been done. According to those documents, apparently, yes.
If you're getting line of sight and you're only using line of sight from each location, you're not creating multiple elevations, you're just using line of sight, it's physically impossible. If you implore different elevations and an assumption of deviating plumb lines, or however you want to describe that, and then you connect points between these various elevations, that's how you can calculate spherical excess based on that assumption.
Are you saying if I have line of sight to 3 points on the sphere, I wouldn't have spherical excess? I don't have it wouldn't exceed 180 when I added up the azimuths?
Correct.
That's demonstrably wrong. I have it right on the screen. So this is an equilateral triangle, which means the internal sums of the internal angles are all 60 degrees. This thing here is clearly more than 60 degrees as it exceeds the triangles if I look it from above the plane of the triangle. But if I look from the top view of each point, it actually aligns with the triangle, which represents the azimuth of each point. So this point would measure this thing here as the angle between those other two, because this is the top view, this is the horizontal plane of this observer here. This is the horizontal plane of this observer, and that's the horizontal plane of that observer. There you have it. Those 3 match the angle that they were measured, and they clearly exceed 180 since each one of those angles on the triangle are 60 degrees, and they're clearly more than 60 degrees. And if you add something that is more than 63 times, you get more than 180. So yeah, there you have it.
Can you zoom
Line of sight,
in?
3 points.
Hold on. Go to another angle, right? Go to one of those points.
Like this.
Oh, so you're drawing your triangle. Oh, okay. I get it.
This is the angle of this observer.
Can you give me a side view of that so we're not looking top down?
Like this.
Can you give me a side view? Show me the connection.
This side? Well, what side
view? Yeah, zoom in. Those don't meet.
Sorry? I'm not getting what you want me to show. Is this what you want to see? Can you be more clear on what you want?
Napalm, are you still there?
Yeah, I'm trying to get his visual here, but it doesn't look like these planes actually add up.
Yeah, each one of these is horizontal to each point. So this is the horizontal of this point, that's the horizontal of that point, this is the horizontal of this point, which is how you measure the azimuth. So you measure on your horizontal plane. So if you look at top view from those two lines, they match the horizontal, the angle on the horizontal, which is exactly what the azimuth is the angle between those two directions at that horizontal. So if this angle here is bigger than 60 degrees, I think it's 63 point something. And so is this one, but it aligns with the line when you see from the top. And so does this one. So when you look at them from the top, those lines align with the horizontal angle, which is by definition what the azimuth is.
You're automatically flipping the verticals. You're tilting the verticals. That's what's in contention.
Exactly.
Looks like he has
the whole.
coming
One
from
second.
the core of the Earth. Are they all? Hey, Bacon. Are all those lines coming up from the center of the Earth? Are all those lines coming from the center of the Earth?
Those verticals, yes. Those
three lines are angled down to the center, but they're supposed to be parallel.
Yes, they're all orthogonal to the. They're all orthogonal to the surface. And
they're not parallel with each other though, because they're coming from an angle.
Exactly, they're not parallel with each other. That's the whole point.
So how is that measured in reality?
I don't know. Responding to your claim that if you had line of sight in the 3 points on the globe, you still wouldn't get exceeded 180, and I think that's false. And I think this demonstrated. So, yeah, whether or not this is sorry.
I thought you said the lines were supposed to be parallel.
No, I said if they're not parallel, then you're gonna get more than 180.
Does that make sense?
Can you do me a favor,
the center of the Earth? Does that make a difference, Napalm? That they're drawing it from the center of the Earth? Is that how it's supposed to be?
Well, I want him to do me a favor, right? Because he's got these little planes that are not actually. So he's got a triangle that does kind of connect there where we can see it, and then in each corner he's got these other planes, right, that aren't really part of that triangle. So can you do me a favor, Bacon? And you know what I'm talking about? The little corner pieces.
Mm-hmm.
Can you extend each one of those corner pieces? Yeah. That guy. Why doesn't that guy go and touch those other 2 points? Oh, it doesn't.
This angle is bigger than. Well, of course, the angle is bigger than 60, and those are 60 degrees.
That's not. Yeah, because that's not what you would actually measure in reality. That's my point.
You would, because the azimuth, it's a horizontal angle. It's not just any angle. So it's the angle you get from the horizontal plane on those points. And this thing here, it aligns with those lines when it's on the horizontal plane of this observer here. So when I'm looking from the top view of this observer, which is what I'm doing right now, I'm going to put this observer right in the center. Those lines now align with the other two. If I make it bigger, you can see they align, because this is the horizontal angle of those two. This is what an azimuth is. If you want me to lay down them on the same plane of the triangle, they would be tilted downwards for this observer and would no longer be an azimuth. The azimuth is the angle you get on the horizontal of this observer. That's why they can exceed 180 on a sphere, and they wouldn't on a flat surface. I don't know what's so complicated about it.
But your assumption is that the horizontals are deviating. How is the deviation in the horizontal
What do you mean the horizontal is deviating?
How is the deviation in the horizontals measured?
It's measured by only taking the horizontal.
The deviation in the zenith, how is that measured between the 3 points?
By adding up the azimuths? I'm not sure if I understand your question, actually. Do you understand his question?
Yeah. Yes. Yeah. The measurement's taken by they don't measure the angle between the two locations. They fix the they fix the theodolite such that there's when they turn it horizontally, this is the only thing that they're measuring. They're not measuring the actual angular separation. They're only measuring the horizontal component of the angular separation. And by doing it that way, they're taking the azimuth of each angle between each two stations.
So, for example, now I'm looking from above. This is the top view of another observer, and in this top view, this actually aligns with the lines of the triangle, because from the top view of this observer, which means on its horizontal plane, you get 63 point something degrees. So, for example, let me delete this and put something like to represent the scope of a theodolite, or just hide it. I can pick that up later. So I'm going to add a cylinder here to represent, let's say, the scope of the theodolite.
So they don't actually have like a measurement to those mountain peaks because their theodolite crosshairs will never actually meet that mountain peak.
No, they do have.
Is the mountain peak always going to be below their horizontal?
It can be above it or below it.
Yeah, to measure azimuth, all you need to do is to align with it on a horizontal plane. It can be above or below, as long as it's in the center horizontally. That's how you measure azimuths. So here's like the scope of the theodolite, and even if I tilt, one sec. Oh, where is it? It's not where I thought it was. So even if I tilt it down to match the line, like this, for example, let's say it is, even if the crosshair was pointing at the mountains, if the rotation of the theodolite is still around the vertical axis, you're still gonna get an axis. That's what I'm gonna show you. So if I rotate it, let me make it thinner. If I rotate this by 60 degrees.
Okay, now, bro, everything you're acting like you're measuring is what's in damn contention, bro. I couldn't talk a minute ago. I was listening. Bro, let's talk about what's in contention. Okay, what's measured is the angle between station A and station B. That's what's measured. You keep talking about the azimuth. All right, so you don't start assuming latitude lines and using a common line between every triangle, because that's not what's measured.
Hold on.
Good point.
This what I'm showing right now is simply a response to the claim that on a globe, if you added up the azimuths, you still wouldn't get over 180. I'm not talking about
there's no set azimuth, bro. There's no azimuth. I mean, there's no set azimuth. You are in naked virgin territory, bro. All you have, okay, is an angle measuring device and points to fucking measure to. That's it, bro. If you're gonna try and prove something with these measurements, that's what you're gonna start with. So throw out the azimuths, bro. These are horizontal angles
Yeah, Brian.
that we're measuring. Okay, there's no
Brian, that's
unless you're gonna assume, the latitude line.
That's what it means, man.
Okay, now they're all based on line of sight. That is specified in and it's one of the first things they specify is that they built these towers to get line of sight for these measurements. Okay, so don't throw any orientation changes. Don't throw in no assumptions, bro. Just measured angles, and when you measure these angles, you get 180 degrees.
Yeah, I'm not doing assumptions. I'm simply pointing out that on the sphere you should still get more than 180. Whether or not this is true,
you can't.
It's actually. Oh, why not?
Bro, you didn't see my video? I put toothpicks on a globe. If it's line of sight, I showed the triangle underneath the line of sight triangle, and yeah, it's curving all you want. But as long as you have line of sight, I could fill the whole globe with triangles. I could encompass that globe with strings tied to toothpicks, and every one of those triangles is going to measure 180. That's my point. Every single one of them, encompassing the whole entire azimuthal globe.
And there's no curves.
Doesn't matter. They're all going to measure 180 as long as they're line of sight.
Here, if I... No. The azimuths won't.
No curves when you're measuring a triangle. There's no curves.
Why am I not getting at 180 here?
Bro, we'd have X, the way you're explaining it, we'd have excess on a flat earth with the azimuths, bro.
No, of course not.
You're describing it.
No, of course not. Obviously not. Oh, let me show you.
You're using a circle, right?
What do you mean?
You're using a circle. You're using a central azimuth, it's basically a portion of a circle.
I'm sure if I understand the question.
Oh, man. What do you mean when you say azimuth, bro? When you say azimuth, I think you're talking about the horizontal, like around a central location, basically.
The horizontal angle between 2 points.
Why do you keep saying azimuth like it changes anything besides angle? You keep saying it. I'm wondering if I'm missing something, bro.
It does. The pivot, like the axis of rotation of a regular angle, is usually
around a central point, right?
1 second. Not around a central point, around an axis. If you're dealing with 2D, 1 second, Brian. 1 second. If you're dealing with 2 dimensions, then you're pivoting on a point. If you're in 3 dimensions, you're pivoting on an axis. If that axis is parallel to the plane of the triangle, it would add to 180. If you tilt that axis and measure that angle again, you get a different value. You don't get the same value.
You realize 3 points in free space on a globe, 3 line of sight points in free space, period, is coplanar, no matter how you tilt it, no matter how you turn it, right? So the whole thing in contention is that the verticals are changing orientation. That's what's in contention. So quit saying that that's what you're measuring. That's what we're fucking asking you to prove. You're not measuring.
Yeah, but if the azimuths exceed 180, then the verticals have to be not parallel. They have to be diverging or converging.
That's the refraction and all that crap.
Wait, what?
You're presenting metrics. No, you're presenting metrics that do not account for a curve while using a curve to present the metrics. That's the confusion.
What do you mean? It's pretty simple. I don't know how to get more simple than this.
You can't bend a triangle. That's what trigonometry is based on. There's no curves in those degrees.
I'm talking about bending triangles. I'm not even talking about circle triangle here anymore.
Doesn't matter. You can't have a circle triangle, but you got a circle and a triangle on your image here.
I don't have any circle. What are you talking about? If you're talking about the sphere, I can remove the sphere.
You would agree? Would you agree? I could cover the whole globe with 180 degree triangles above the surface.
I'd love to see that.
What do you mean?
It's not difficult. I can above the surface, like not touching the surface, like on mountaintops, like line of sight. I could encompass your whole globe with 180 degree triangles right?
Yeah, you can create like an icosahedron around the Earth, and I think all the
right. So that's what we're measuring. Now, what we're asking you to prove is the orientation change. That's what's in contention. I'm just throwing that out there. I'm saying these line of sight triangles are going to be 180 degrees no matter how you do it if it's line of sight. Now, what we're asking you to prove is that the orientation's changing. That's what's in contention.
No, that you're wrong when you say that if it's line of sight, then they would measure 180. No, if it doesn't matter if it's line of sight.
Well, watch my video real quick, man. It's like a 3-minute video, and I put 2 picks on a globe. I tied off 3
for more
than
3 minutes. You could very well have explained the whole content of your video already.
Anyway, I lifted this one side of the string and lowered the other one. I tied 3 separate angles into a triangle, and I lifted one side, dropped the other, and no matter what I did, I've got a 180-degree triangle. Until I invoked an orientation change, I showed the spherical triangle underneath it on the ground. That was different.
Okay,
the line of sight, the line of sight that's measured was 180, bro. So you're not going to intrude on another triangle unless you change the orientation. And
that's why I drew this triangle here. The triangle itself, of course, it's the triangle you create by connecting the 3 points. Obviously, is going to add up to 180, but none of those angles are in the horizontal plane of those observers, so they're not azimuthal angles.
That's what we're asking you to prove.
What are you asking to prove?
What you just said. Like they're not in the same horizontal. Like that's what's in contention.
No, I'm explaining how it would work on a sphere, because regardless on whether or not this is the case, we can still agree or disagree on whether or not you would get 180 on a sphere.
Only disagreeing.
Well, would you agree with this? If once I introduce a slight orientation change, then I can calculate a spherical excess, right?
I'm not talking about calculating the excess. I'm talking about just.
But I could do that though, right, Bacon? Would you agree that I could calculate a slight spherical excess by adding a slight orientation change?
You mean you should tilt the theodolite?
No, if I calculate and add in to my measurements a slight orientation change, change in the vertical, then I can.
If you're adding values to
you're adding values excess, right?
You're adding stuff to the thing you're measuring. Is that what you're describing?
Yeah, then I could do that, right?
Of course, that's going to add up to then more than 180 for.
You think that maybe that's how they did it? Just maybe, though. Maybe that's how they did it.
Sure, I'm not even. That's not even attention whether or not they did that. The whole point here with this Blender model is that on a sphere they would add up to more than 180 if you added up the azimuths. You don't have to calculate or do anything. If you're on a sphere, that's what would happen with big enough triangles. This one, for example, each one of those angles is 63, which means there is at least 9 degrees of excess. But this is a very huge triangle compared to the size of the Earth. Okay, a more realistic triangle would be much smaller, and so would the excess. But the bigger the triangle, the bigger the excess.
So you're saying triangles make the Earth curve?
Yes, of course. That's exactly what I said.
I'm trying to figure it out, man. I'm still trying to figure it out.
Bro, I did 3,000-mile triangles, like a pretty close to 3,000 or 4,000-mile triangles, to show that. Yeah, there should be a ton of spherical excess, and the spherical triangle underneath it on the ground is way off. But the line of sight triangle is 180. So my whole point is, go ahead.
Oh no, actually, I'm not sure how to show this.
I've never seen a triangle with a curve. That's all I'm saying.
Yeah,
I'm trying to show the triangles that prove a curve, and I'm like, well, they're still triangles.
No, I'm not saying that. Yeah, not saying that. Like, I'm not even appealing to the triangle itself. All I'm appealing to is the azimuths. So you don't have to care about all that.
They did it. I think they're basing their azimuths off the 39th latitude, which would you could get excess if you're using azimuth triangles. You can invoke excess on a flat plane just as well, you know, because it's in a circle. The latitude is a circular line. You know what I'm saying?
Okay, I don't get it. How are you getting excess on a flat Earth?
Well, if you're using azimuths, bro, then if I invoke the 39th latitude,
what is that?
My triangles, if I maintain on and around the 39th parallel, and call that, you know, my baseline for my azimuth, then I could invoke excess, like circular excess, not spherical excess, but circular excess.
What is that 39th latitude that you're referring to? And I don't know what you're talking about. Can you clarify that? Because that's the first time I hear it. That's a new one to me. And I'm really lost.
Well, with line of sight, if I did it line of sight, then I'm always going to get the same thing. Even on a globe, I'm going to get 180. I should just stick to that point because I showed that even on a globe, man.
Even with the azimuths? Okay, I'll check your video.
Yeah, but, I'll post it real quick, and I'll post it real quick in live chat.
Your video is contradicting geometry if you did that. Hey, what's that Sputnik if Kosho?
I'm just still waiting for degrees of triangles and angles to bend, curve.
To be honest, I'm very confused about this. I don't know.
Because you got 90 degrees here, 90 degrees there. I mean, I still don't see a curve. And then you're trying to tell me that you add up all these 90-degree right angles or whatever, and then all of a sudden there's a curve? It's like, but you're using straight edges to present your case.
It's because you couldn't. Okay, so if you were to do 3 90-degree angles, right, that could not. That physically just could not happen on a flat surface. I mean, there's no way.
Actually, you can have 3 90-degree angles. Period.
I mean, like forming a triangle, though, is what I'm getting at. If you want to be a smartass, I mean.
Well, I have to be. You can't have a triangle cannot be 390 degrees.
333, whatever they want to tell you, but technically it'd have to be 33.33333 forever, and then they'll
That's
finally.
What I represented. Sorry.
I don't know what's going on here, so.
That's what I represented on the globe as one of them, like 3 turns, 390-degree turns.
Right.
I did it. I went real far. So, but guess what? The line of sight don't care that that it's 90 degrees. It takes the shortcut, and it traces the straightest line between the 2 points, and it makes 180-degree triangle. You know, it doesn't care about your orientation changes or anything like that. Line of sight doesn't care about any of your globe curving. It just finds the shortest point between the 2 obstacles. So unless they invoke our vision curving, then they can't say that there's spherical excess with line of sight.
Yeah, then you got refraction and density and lensing and all that stuff. The fact of the matter is the basic metrics is line of sight.
What's wrong with line of sight besides the
I'm gonna step in here just because I'm curious and I just kind of want to invest in this. I'm gonna ask the globe earthers because this is not my argument. I'm just curious to know for all the globe earthers, what is the argument here?
It's like the spherical excess thing.
What?
Basically, so spherical excess. Have you heard of spherical excess?
I know my math, but just explain it. I'm watching the screen. Explain something.
Well, I don't know too much of it. I just know enough. But basically, I think the idea is that if you try, okay. So I know that basically, if you try, making a triangle on a spherical, object, that the triangle will have angles that add up to greater than 180 degrees. So I think the idea is that in real life, if we do some of these triangles or whatever, right? That we
let me ask a question. Are you
Right, go on.
I might be interrupting, but I want to get some clarification here. Are you adding like the vertices, the endpoints? Are you putting them like right on the top of the sphere?
That's a good question.
They're measured line of sight. No, they were measured line of sight from mountaintops and towers that they had to build to get line of sight.
But it assumes you're on a ball, though.
Well, I mean, if you're on a ball, if you're on the ball Earth, I mean, the vertices would be on the sphere, right? I mean, technically, I mean.
So they have some height. The vertices have some height in them.
We're not.
Well, yeah, they have some height to them, sure. I don't think that really changes much, though. Yeah, no, because I think the height, the main reason why we have the height is so you can actually see the targets. Because if you didn't have the height, then you're not gonna be able to see some of these targets, you know.
Just trying to understand this here.
Yeah, because the idea is that because I imagine, even if you didn't, let's say we didn't have height, and let's just say the Earth was like a glass ball, you could see through it. That would still check out whether you have height or not. It's just a matter of having to turn towards that that object or mountain or whatever the fuck it is, and then getting that that angle or that that amount of degrees or whatever. It would just be if you try doing that, it would be your triangle that you would make would end up being greater than 180. Yeah, the height is just simply just to see the thing. That's all.
Hey, Arma.
What's up?
Do you know how to switch from one camera to another camera?
I think you have to click the camera, and then I think you have to hold like either Shift 0 or like one of those things. Hold on, it's one of, or is it maybe Control 0? It's one of those. Let me real fast pull up another camera.
All right.
But while you're selected, let me see camera 1. Let me create another camera 2. Because it's like really simple. I mean, well, I mean not simple, but it's like very like I'll know in just a second. Hold on. So let me see. Okay. Okay, yeah, it's Control. It's Control 0. Control 0.
Here, so
if you hold Control and then you press the 0 on the numpad, it'll. But while you're already selected, so you have to select the camera first, though. So you have to click the camera, make it.
I didn't create the second one. Okay, I did now.
There you go.
Oh, it's already selecting this. Okay, so let me try to select the other one. I click on it and Control numpad 0. You said?
Yeah, Control and numpad 0.
Oh, okay, thank you.
There you go. Yep.
Are you measuring the distance between the vertices, or?
I think they're just.
I don't know what's going on here.
Oh, I think it's just the angle. I guess between vertices, I guess, because it would be two. Because you would be at a vertice, and then from one vertice to the other vertice. If I had to guess, you'd be measuring that angle, I guess.
Yep. Here's the problem I have. That would be completely independent from a globe. I don't know. I don't know what this proves here.
Independent from a globe.
It would be if you're just having three triangles.
They can't comprehend that, bro. I've been trying to explain this to them for fucking a year. Not a year, but it feels like it. They don't comprehend that above a sphere, you could encompass it with a million line of sight, 180-degree triangles, man.
Well, hold on. So let's take this to the extreme, right? Because that's always good for logic. It's always good to at least how I do logic. I could be totally wrong. That's just how I fucking do shit, right? Anyway, let's take it to the extreme, right? Let's make it where this triangle has 3 90-degree angles, right? So let's also say that
that's impossible.
Well, that's what I'm saying. On a ball Earth, that would be possible, and that's where this argument is kind of going. But if you're on a ball and you have 3 vertices, right, and let's say they're spaced out far enough to where this is possible, right? You measure from one vertice to the other, you get 90 degrees. All right, that only works on a ball.
So are you saying that in the vertices,
a right angle on a ball is 2 great circles, bro? A right angle on a ball gives you a prime meridian and an equator. You'd never get that from line of sight, ever.
You would get it. Bacon, can one of us like show this on Blender just so we can get? I'll fucking show it, all right? Because I'm getting tired of this shit.
That's the only parallel lines you have on your ball, bro, and you're acting like they converge.
Look, I'm gonna show it right now, all right?
I can show it. I already have it here.
I want to show it because I'm getting tired of this shit. All right, it's getting annoying now. This has gone on for far too long. All right.
Okay.
I meant perpendicular. That's the only perpendicular lines you have as far as right angles, and you act like they're converging somewhere in the middle or something. Like, I don't understand your way of thinking. Like, if I look at something, my line of sight's going to be the shortest distance between 2 points, and don't think about the downward curvature. Think about free space. No matter how you chalk it up, it's going to be 3 coplanar points if you're above the surface of that sphere, if it's line of sight.
Here, I'll show it too as well. All right, maybe Bacon and
keep in mind, keep it short and simple when you're talking to me. So what I'm getting at from your guys is that if you put the vertices on a globe, not that we're doing that, each vertices will be 90 degrees in between on top of the globe. Is that what you're getting at?
If it's big enough, you can have three. You can have 3 angles where all of them are 90 degrees.
But here's the problem: it wouldn't be a triangle at that point. Realistically, I can visualize this pretty well.
Well, hold on. It would be, I think, definitionally.
The lengths would bend. That's what would happen.
Yeah, but the thing is,
but then there's no triangles here.
Hold on. Here's the thing, though. I'm pretty sure triangles don't have to be Euclidean. I think as long as they're on a surface, I think that counts as a triangle. So the surface of a sphere is 2-dimensional, in maths and whatnot. So I think it still counts as a triangle, so long as it has 3 angles, and within that surface, the lines are straight. All right. I mean, obviously they're curving because it's a sphere, but within that surface, they don't count as curving. That's
what I mimicked in my video, bro. I mimicked 3 right angle triangles and drew it underneath and draw the 270-degree triangle. But the straight line of sight didn't matter. Didn't care about them curved lines. It took the shortest point, the line of sight.
Do you have 3? Do you have it?
It wasn't quite that far, but that's what I was going for.
Do you still have that?
I think I'm gonna have to side with the flat earthers here. Sorry, but because I have a hard time. I don't think you can have 3 90-degree triangles like on the globe. It wouldn't be a triangle at that point.
It would be a circle triangle.
Well, yeah, circle triangle. Which is there you go. If you want to get really, really technical.
The way you have it on Blender is exactly the way it would look like. You would have a triangle that would be like off.
Oh. No. Okay, Arma, create a new sphere. Add a new sphere there.
Add a new sphere. Okay, hold on.
But an equal one. No. Let this one. Let this one there. Hide the triangle you created.
Hide the triangle. Okay, hold on. Yeah.
Yeah, create a new sphere, an equal sphere, not a UV sphere.
Oh, okay, equal. I call it Ico, but it probably is pronounced equal. Okay, hold on. Yeah.
No, it might be Ico. I mean, I learned how to pronounce this stuff before I learned English, so it's probably Ico.
Let me see. Where is the Ico?
No, it's a UV sphere. Sorry, UV sphere.
UV sphere. Okay.
Yeah. Put more segments like
how much?
I don't know, 100.
Shit, I fucked it up. Hold on, give me a second. You want 100? Okay.
You're gonna have to create a new one.
Yeah.
No, Ed.
Yeah,
Ed.
my bad. Yeah. I'm just sort of
UV.
There we go. So let's do 100. Oh, fuck me. Why does it keep
No,
happening?
you still can do it. I think no, you can't.
Oh, sorry.
What are you guys doing?
I don't know what they're doing.
You see. 100 segments, 50 rings.
You guys just deep in your non-globular programming passions?
I'm having fun here, Joe. Don't worry.
Okay, so now what?
Right. Go to wireframe. No, make it bigger. Yeah, than the other one.
Okay. You want wireframe?
Okay, go to wireframe. Yeah. Look up. Numpad 1.
Oh, numpad. Okay.
Sorry, numpad 7.
7. There we go.
No, this looks like globular programming, not globular. Although I see that looks like see right there. Pause it right there. See right there. Just hold that screen for a second. That's a sphere, right?
Yes, technically, I guess.
See how it looks? See how it looks like an azimuthal grid from above?
Sure.
Yes, that's the idea of an azimuthal projection.
Ding, ding, ding.
Okay. Anyway,
we have a winner.
Okay, Bacon. Okay, so now what?
Okay, now tab. Go to edit mode.
Hold on, wait. Edit mode. Just go to edit mode.
Get vertices.
Vertices.
Yeah. No. There. No, sorry.
I'm gonna go with my logic on this. I am 100% certain that if you have any point on the Earth and you put them 90 degrees, it wouldn't be a triangle.
Okay. It's a circle triangle. Yeah, I'll show you. Wait your intuition until you see something, and then you can.
Now what?
Okay. Go to your mouse a little bit to the left inside of the screen, a bit higher.
Are you guys doing like a presentation or something of like with content, or are you kind of more just talking to it? Because you guys
No. It is something. Use the middle button to do that.
You want me to do this
that
kind
works.
of thing? Like this and this?
Yeah, exactly. Yeah.
All right, I shared his thing on the live stream, so if you want to present something, it's showing now.
Numpad 1 and remove the button. Yeah, exactly.
Okay.
That's the spherical triangle. Now,
isn't a spherical triangle just like a smaller part of a hemisphere?
Oh, I kind of fucked it up.
Oh,
You get the point, though. Let me fix that. Let me real fast make it a little bit better. Okay.
Oh no, you can still fix it because there are some. Yeah.
And
no. There's some extra. No, you now you do it more.
Oh yeah, my bad. Yeah, sorry. Oh, you know what? Why don't I just
yeah. If you take the right angle, the 270-degree triangles, you'd get 4 of them would make a hemisphere. To get 10,000, to get 4 right angles, you got to go 6,200 miles from the equator to the North Pole, and then
here we go.
And then a 90-degree angle back down to the equator. 4 of them will make
change the color of this.
Freaking what you call it?
Oh, go back to edit mode.
Oh, edit mode. Okay.
And then select everything like A. Type A.
Where the?
No. Right click.
Right click.
Smooth.
Oh yeah, smooth. Oh yeah. Hold on, I know what this is. Well, I like doing it here, but yes, that's shading.
Oh yeah.
There we go. Yeah, nice and beautiful.
Yeah, that's a circle triangle. Where is him? Shadow.
Yeah, Shadow.
The Batman guy.
Or
the.
What's up?
The vampire.
Oh, I'm here. I'm watching. I'm staring at the screen. I don't know what the heck you guys are doing.
Hold on, I actually want to.
That's
make this.
I'm just enjoying myself staring at this.
That's a circle triangle.
Yeah, hold on, I want to make it different color. Here we have RGB.
I like to call it a tricurva line.
Yeah, it needs a different
that has
name.
a name.
It needs a different name.
Yeah,
It's not, what did someone just say? That was funny. That's what it should be called.
That's not a triangle, though.
It's a spherical triangle, not a triangle.
Well, it's like a shield.
Tricurve.
Tricurve.
Oh, is that what you guys were getting at? Like 390 degrees?
A tricurve.
Yeah.
That's actually a good name, dude. Tricurve. It's a tricurve. That's a better.
I like it.
Yeah.
I like it. Yeah.
Because they really have to try hard to make it curve.
Yeah, a trick curve.
Oh, you can measure it.
That's pretty good.
Yeah. Wait, where's the?
Hey, I see where you guys are getting at. I get it.
I get it too.
I
So
see that.
I got a question though, Bacon. We're making these azimuth measurements based on observations, right? Line of sight observations of things in the distance, right?
I'll accept that is true. Yes.
Cool. How do we view the
I'm
world?
going after napalm.
Do we view? Nothing comes after napalm. It leaves nothing but scorched earth. No. Do we view the world? Let's use railroad tracks as an example, right? So these are parallel lines that appear to converge in the distance, even though they don't actually converge. So when we're viewing things in the distance over extremely long distances, and we have things at varying distances, like multiple, like mountain peaks or something like that. Wouldn't you say that our perspective, based on how we're viewing these objects in the distance, would give you some sort of, let's say, deviation in what their actual locations may be?
No, perspective doesn't affect directions. Perspective is simply how a 3D space gets projected into a 2D surface.
So I have a question for you then. If I have light poles going down the road to one side of me, if the light pole is right next to me, right, and they're in a straight line, meaning I'm 10 feet away from this light pole, so I'm 10 feet away from all of the light poles, but the light poles appear to move towards my center of vision, even though they don't actually physically come closer to me if I drew a straight line of sight from myself straight forward, right?
I think I'm following.
Yeah. So
that's not
your perspective would play a role in how you're viewing things and angles you're getting to things. Kind of like, we see an azimuthal grid of vision. So if we have an azimuthal grid of vision, that would necessitate like a sphere. And then we're equating that sphere to being something of Physicality.
That,
I like we
to
do a
make it
celestial
specific
navigation.
answer
That's
to what you were
interesting.
saying
I
before.
get it.
Okay, so yeah, the light
Lost
posts,
on that one.
the direction of the light posts aren't being affected by perspective. The direction in which you see them could be very well the direction that they are. You'd still see them approaching your.
What is the name of that spherical triangle?
Spherical triangle.
Spherical
I
triangle.
know. I'm still looking.
This one's particularly I named Josh.
It's a tricurvural.
It's a yeah, that's
It's
a
a
good one.
twerkle.
I don't keep track of these terms.
Yeah.
A tricurvination.
Okay, listen to this. Listen to this. Are you done, Napalm?
Hold on, what was that?
Napalm, you
Sorry,
good?
my wife just
Are you
got home.
good?
I didn't hear you.
Are you done?
Yeah,
good,
I didn't
Bob?
hear his response because my wife just got home. But go ahead.
Okay, listen, for these spherical triangles, right? We look at a building, we look at two buildings in the distance, and we go to measure our spherical triangle. The buildings are leaning away from each other, right?
Should be, yeah.
I know, but bacon.
They have a huge triangle on this one that they're screen sharing. They have such a big triangle; it's taking up like a third of the whole globe or a quarter, whatever that is.
Yeah, 1/8.
And two of the lines are at the equator.
Yeah.
You know, like in the east, south. You know what? Like in two, like and then the other one's pointing up. So yeah, they're all. If you had buildings at all those points on a sphere, they would all be completely pointing in 90-degree different directions.
Yes, but this is an exaggerated version, just to get the point across. It's just it's not,
Yeah, I'm saying if we're looking at Armbar, your mic's low. So if we're about to make our measurement of spherical excess, and we look out in the distance, and there's two buildings that we're using the site, they're going to both be leaning away from each other, right?
Technically, sure, but it's not going to be anything, like measurable. I don't think. I mean, it depends.
Let's see where it goes.
Okay, so I'm looking in the middle of these buildings, right? And the ones on the side are going to be leaning to the left, and the ones on the right side are going to be leaning to the right a little, right?
Let me see.
Is that correct, or?
Oh, what do you mean?
They're going to be pointing away from each other.
It depends.
Yeah, that's what I mean. One's going to be pointing to the left a little bit. One's going to be tilting to the left. That's on the left side, and the one that's on the right side is going to be tilting to the right a little bit, right?
No, they're tilting
away.
From
no?
Yeah,
no,
I mean,
are
you talking about tilting? Are you talking about the tilt because of the curvature of the Earth? Is that what you're referring to?
Well, the buildings have to be.
Sorry.
When you measure these spherical triangles, isn't this all because plumb lines aren't parallel?
Mm-hmm.
Yeah, they're diverging.
So the buildings are basically. Let's pretend the buildings are all plumb. So they're going to be tilting away from each other, right? So the ones if I'm looking straight down in between them, the building on the left-hand side is going to be tilting to the left a little bit, and the building on the right-hand side is going to be tilting to the right a little bit, right?
No.
I don't have all night for this. I don't know. I'll be back later, maybe, if I can.
The answer is yes.
Well, hold on, Bacon.
No, they're tilting away from you, not to your left or to your right.
Well, I think what he's trying to get at is
if you're between them, I think.
Well, I think what Jeremy's trying to say is like what my picture is kind of showing, where like, although I guess he's not really describing it well, but I think he's getting at this though. See how like the red and the green are kind of like pointing in their own direction, kind of thing. I think that's what.
Yeah, but it's not like to your left or to your right. Like it's just away from you. They're simply away from you.
Yeah,
it is to your left.
Depends on where you're standing. That's what he's saying.
Yeah, just like where he has on the screen share right now. One's going left, one's going right.
Yeah.
Okay.
Face it though, then it's
okay. If that's what he meant, then yes. I thought he meant something else. Maybe I misunderstood him.
Okay. So we all understand how this would work on a globe, right?
Yeah. Well, that's still gonna happen on a flat Earth, right? If you're looking in between them, they're. Oh no, yeah, they'll be parallel.
Is there stuff that you can measure on a globe?
Yeah, they're claiming they can measure these spherical triangles. So, okay, the building on the left is tilting to the left, and the building on the right is tilting to the right. Now, let's pretend I have a third building that's a little bit farther to the left, right? So I got a building on the left, building on the right, and there's a building a little bit off farther to the left. You with me still? And that building is going to be tilting to the left, right?
Mm-hmm.
Even more, yeah.
Yeah, so
should be.
You're coming in with me?
Mm-hmm. I mean, I assume you're looking like around the middle of the first two, right?
Yeah, I'm looking in the middle of the first two.
Okay,
So the ones on the right are tilting to the right, and the ones on the left are tilting to the left.
Mm-hmm.
Okay, but don't the two building? I got two buildings on the left. They're both tilting to the left. Don't they need to be tilting away from each other?
They are tilting away from each other.
On the globe, they should be.
They're both tilting to the left, though. They're not tilting away from each other. They're both tilting left.
They're still tilting away from each other. Like one is more than the other.
Yeah, one would just be slightly tilted more.
Yeah, they're still tilted away from each other. If you go to one, that one is going to be tilted away from the other one, and vice versa.
There we go.
Hold on, I forgot where I was going with this now.
Oh.
I know. I know.
I've been waiting all day to spit this, and I finally got it, and now I forgot. Hey, how's it going?
I already
I'll be
visualized
back.
this. I even drew it on my whiteboard here, but I don't really have much to go because I don't know what. Anyway, can you guys draw a straight line by any chance?
A straight line.
Your mic is breaking up.
Is it?
Yeah.
Can you draw it? Can you draw it? Thank you.
It's got like
Can you draw
some
a straight line?
static. It's got some static, like loud, like clicking noise going on every time you talk.
It's like.
Oh, I thought you said satanic.
I don't think it does, but I can check.
Well, how come the Globers have been telling
does.
us for a long time? Yeah, your mic sucks, bro. How come the Globers have been telling us for mad long that we would never see the building tilting to the left or the right? It would only be tilting back. That's why Bacon was so confused just now. I don't know if anyone caught it, but Bacon was super confused because
I didn't know you were looking at the center of them, and you're using that talking about your vertical, like the vertical you see.
It was a moment of thought. It was just a moment of thought. Just thinking.
Yeah, if you think about 3D space, they're tilting away from you. But if you're thinking about like taking a picture, pointing at the center of them, then yes, on that picture they're going to be tilted away from the center of the picture. That's right.
So, can you draw a straight line? Yes or no?
Straight line where?
Blunder.
Where?
Well, you are just waving the thing way too much. So.
Sorry. All right, where do you want the straight line exactly? Because I could do like a 3D version of that if you want. Like I could do maybe like.
Okay, the bottom vertices.
The bottom vertices.
Yeah, the just pick two endpoints.
Oh, so it's like this one and this one. Okay.
No, pick that one.
Hold on, I'm gonna try to
straighten it out.
Actually,
Yeah, see that chord line.
You should have rotated by 45 degrees from the start.
Yeah, I should have.
What are you using to verify that it's straight? What exactly is that?
So
don't worry about it. Okay, anyway, we go. Here we go.
Okay, no.
That
Rotate
chord
90
line
degrees.
right now, that chord line on there shows what it would be if you were like looking over the hump of a sphere or whatever. That it shows how, like the Selenelian eclipse and all that stuff that's just supposed to be hidden by the ball. It shows there what you'd have to do. You'd have to see through the ball for that observation to be possible. Or the Earth is just planar and it's coplanar points.
Here we go. So this line kind of does it. I mean, it's the best I can do.
No, 90 degrees straight up to the z-axis or whatever the fuck that axis is.
Assuming you're on a ball here.
90 degrees. What are you talking about?
Like that. See that blue line that's in the middle?
Yeah.
At the center. That like rotated exactly like that.
Bro, your mic's mad crackly.
Yeah, you got to do something with your mic, man. It's broken.
Like this?
It's already.
I already checked. Mic's fine.
Like this?
Not fine. We're telling you, it's not fine, dude.
Go back and listen to yourself on the YouTube stream. It's brutal. It's crackling, and we can hardly hear what you're saying. It almost sounds like you have like a voice changer on or something. I don't know. It sounds something's wrong with it.
It's definitely crackling.
I don't mean that you're using a voice changer. I just mean like it's like
Stop
so. It's like
overtalking.
so. I know what your voice sounds like without it, and it's so like distorted and crackly. So yeah, something's going on.
Well, I'm listening. All right, he's like part robot. All right, so you guys.
It sounds like it.
Don't be mean. All right, wait. Okay, what were we saying though, Shadow? Anyway, what's up? So I did that. That's a straight line. No.
Why is there a ball in this image? You're showing me straight lines. Why is there this big ball?
All right. Anyway, look. Point is, all right. There are two angles. This is the 90. All right. This is what happens when you try to do the thing. All right. Go from here and to here. That's 90. But then, if you actually like want to like, do this triangle, that one's 60. That one is the 60 degrees that you guys are talking about.
But I still don't see any curves in the vectors. Like
this is where you live.
One loses.
This is it.
Flat earthers.
Put snacks right on the side of that ball, and there you go.
You live on a fucked up golf ball.
I know, it's weird.
Yo, so if we were to go to the Burj Khalifa, or whatever it's called, Burj Khalifa, whatever that tallest building is, and we were to get some shit with crosshairs, we could look to the side of it and see it tilting left or right. Probably if we were to get way far away and up high.
Probably not. It's not. I don't
Why?
think it's not.
If you're pointing at it, it's not going to be tilting to the left or to the right. It's going to be tilting to the left or to the right if you're pointing somewhere else.
Yeah, we're going to point somewhere else. We're going to point off to the side a little bit of it.
Yeah, then it might. Yeah. Well, how much though? That's
that's the question.
I think you're going to pick that up with the camera.
We'll get a theodolite or something.
If you can see it from, if you can see 700 miles away, you would only see it tipping 10 degrees.
Yeah.
So,
well, we should be able to measure a one. We should be able to measure a 1 degree tilt, right?
From 70 miles away.
They give us
from 70 miles. Yeah, the Burj Khalifa. How big angle would it be? Big enough angularly?
1 degree. Not gonna.
We need 2 Burj Khalifa.
Armbar's lost. That's a shocker.
No, 1 degree that's not enough. What the hell are you talking about?
Why? We can measure arc seconds. We can't measure 1 degree.
Because you might.
Dude, you're not measuring. Dude, you're making an angular measurement of your device and measuring arc seconds. That's not the same thing as measuring an object that's in the distance and measuring how far it's angled from its own vertical. You need more sophisticated equipment for that, like GPS.
That's much harder to measure than the excess, because if you have the thing in your camera and you zoom in, you're making your field of view very small, and you're only fitting in your scope a very small region close to that building.
I'm saying it's way too many fucking
I give you 5 to the idea, but I don't think it.
Well, this is the whole base.
You get a cookie, but that's about it.
The spherical
what?
That's right. It's based off plumb lines not being parallel. Dude, isn't this why the plumb line you get the spherical triangles because they're diverging and you can measure 2. So we need the Burj Khalifa and something else next to it to be able, some other skyscraper to be able to measure it.
Right?
Yeah,
I'm still.
You need to put Wiz Khalifa out there.
You need to measure it. Measure it from its own vertical.
If the black and yellow lines are parallel.
I was trying to throw a
Wiz. I know there's no curve on those lines there. I mean, what the heck?
Is a plumb line straight or is that curved as well?
I guess they're all.
Jeremy, what about this way to test it? We put 3, like poles in the ground at different distances, and then have a drone fly directly up and basically make like an invisible plumb line, and then measure the distances between those drones. And if the Earth is a sphere, that distance is going to be much greater than it is on the ground.
Wait, isn't that just spherical axis again, or okay.
Yeah, but it's doing it with
drones.
Me
and Brandon went over that.
Wait, so
me and Brandon went over that one night measuring plumb lines diverging, and the
It's tough because you need it. Who's mumbling? That's tough because you need to have a lot of distance and very tall plumb lines, like ridiculously.
Yeah, you'd have to have multiple. You'd have to have multiple drones. You'd have to have like 50 of them.
Well, what is the chances that we get some of those dudes to build other two Burj Khalifas? Very far away from the current one, but not that far that you can see it.
There you go.
You know, they're building a 175 kilometer long buildings, twin buildings next to each other, 175 miles long or kilometers long. Both of them higher than
wait, how high are they?
Skyscrapers. How they're I forget the height, but I think they're higher than most skyscrapers. I forget the exact height. But just imagine like the tallest. Yeah. So taller than the Empire State Building, taller than that kind of shit. I'm not sure if it's taller than the Burj Khalifa, but
well, when you look at a city skyline, the buildings are all parallel. But
yeah, you could achieve this measurement with
you don't
GPS.
see the top of the buildings angling off.
I don't know. All this angle shit is, I don't know. It's a little, I just don't think it's gonna happen. It's.
If you had a bunch of buildings all lined up on a globe and you could see them all from far away and they were very tall.
Very tall.
It is conceivable that you could see actual diversion.
Yeah, it would have to be really tall and that's not happening.
You tell me how sensitive is your camera, and what's the minimum amount of angle you can measure with that. And
we're gonna do it with infrared. We're gonna do it with sensors and infrared and show the plumb lines are not diverging.
Yeah, what I mean is, it's easy. You can easily get a prediction for that on globe, like how much you should measure at which distance.
But do you know what infrared sensors are? We could set up actual physical sensors that are like 1,000 miles away or more, and use the infrared. The infrared will actually pick up the sensor and then we could measure from there whether they're actually diverging or not.
Interesting.
Are you sure not going to claim refraction if it happens to match the globe?
I can guarantee you that one or more people will claim that, yes.
What? Claim what?
And it's refraction if it happens to match the
globe. Claim. I'm sure that will be mentioned more than 5,000 times, but yeah. Indeed. Well, but then it has to so now what? You would take it actually should be diverging on a globe, but refraction makes it planar? That'd be tough. Why would you know what I mean? Like for you guys, if the results are planar, what would you have to say? Oh, refraction is now bending things out left to right as well. It allows us to see around corners and it just flattens out curves left to right.
I think
I would never appeal to left to right refraction.
Oh, so you'll just avoid it overall. Or you won't appeal to it?
No, I would say you guys have a point. Like if the
okay, nice.
Yeah,
that's legit.
Yeah, I mean,
I'm still waiting to see a curved angle. I want to see a curved angle.
There is no curved angle. What are you talking about?
I know exactly.
Aren't all angles curved? I thought they were all like arcs, aren't they?
Wait,
aren't they like a section of a circle that we create between two directions to determine how separated they are? It looks like a curve to me.
Oh.
That's how I conceptualize it, at least.
Interesting. I try to finish that.
Hey, I got the speed
definitions of the angles are straight lines, and that's what's weird. Is I want to see a curved angle.
Angle isn't like line.
I would say there's no such thing.
Talking about degrees and triangles and vectors and everything. But
I'd say there's no such thing because
straight line.
An angle requires straight lines. Yeah.
Exactly. I'm still looking for the curve there.
Yeah. Well.
I don't think you're never going to find it, but if you keep looking, I'm just letting you know.
No, I'm not. I'm interested. I'm not looking. I know it's kind of weird and nonsense because you're dealing with straight angles. and lines to determine vectors, which are angles. And then they got this ball that gets thrown into it. And I'm like, okay, what the heck?
Vectors aren't angles.
Vectors.
But yeah, you can get angle between directions. They work like straight lines and directions.
And now you're talking about perspective.
To be straight. Sorry. I mean, if you're taking angle between two spots you see, and there's reflection.
Straight lines. That's based on the spot that you see, based on your perspective.
Give me a second to finish. If you're measuring angle between two spots you can see, and there's refraction, you're already measuring angle between two curved lines. Because the path light takes to reach you to form the two spots that you're seeing is bent by refraction, right?
So you say.
Obviously, you can do that. I don't think refraction is this thing. You don't think it bends light?
I see straight lines on a ball, and I'm like, well, one is different from the other.
Never mind.
Well, that's it.
So. What are we talking about? What we're talking about?
But yeah, the tri-curve. The tri-curve thing that you can put on a sphere is definitely not a triangle. But it is lines that are intersecting.
By definition, you can't claim that it is. That's why I think it's weird. So.
Well, we said.
But it is lines that are intersecting at a ratio.
I mean, that's why we say spherical triangle. I mean, if you know.
That's your point of view. That's your ability to turn 360 what you call degrees and view what you're perceiving. That doesn't mean you're on a ball.
No idea.
Well, you have to believe it. Otherwise, we'll point our fingers and laugh at you till the end of time.
That's actually
definitely the metric of degrees is what they claim is the whatever it is based on straight lines and angles.
It's
angular measurements.
Yeah, and we build with squares and straight lines and horizontal planes. We don't build with that.
Just look at this. Look
that
at this
amount of curvature involved that would actually need to be there. Yeah.
Time.
Can I share my screen for a second?
Yeah, I mean, I'm done pretty much. Hey, where the fuck?
That was kick-ass. Thank you. Looked like cat or something like it.
You can, Kosho, but it's pay per stream. It's $1.99 a minute.
Okay.
$1.99. All right.
I don't know why I thought of that. I just remember those phone services things that you could call.
Yeah.
Yeah, I was using one last night.
This one for this game. It was called Space Quest. This is actually a really good game. Roger Wilco is the dude's name. He's actually a janitor and he's a space hero. But these games were called Space Quest. They came out like in the early 90s. And there's like 6 of them, 6 different games by that company named Sierra. They also made like King's Quest and a bunch of other games too. But Police Quest as well. But anyways, these Space Quest games. Anyways, there's one where, well, pretty much with all those games, but they used to have a hotline. So it's like an adventure game, and there's like puzzles, you have to pass through and all that. And so if you got stuck or whatever, since there wasn't the internet that you could just go Google it, they had like a phone line, and you would call this line, and it would charge you like $2 a minute or something. And then it was just like a automated thing where you would, if you're on stage 1, click 1, stage 2, click 2, so you had to like pay $2 a minute to go through this whole automated thing to get the hints for the game. I remember that. It was funny.
Oh yeah, I've seen that. They used to make a lot of money. Those was like before cheat codes, like before they had those cheat code magazines or the websites with cheat codes on it.
Speaking
you could actually call in and they'd give you tips how to beat the game, how to level. I forgot which game did that. What game it was?
You said what now? You said what game was that? Is that what you said?
I'm trying to see what game Gio was talking about, because I saw a thing that said that. But
Space Quest.
Okay, real quick, I'm just sharing something.
The game I was talking about is Space Quest.
Yeah, Space Quest. Yeah.
Literally about a janitor who is a fucking, the hero and goes around saving the fucking universe.
That's what I'm fucking talking about right there.
Yeah.
That's what's up.
This is Jeremy when Jeremy turns to a Glober.
That's how I envision my life playing out, just like that, where I save the universe.
This is you when you realize it's a globe. This is what it's going to become of your life.
I just posted
an superhero.
I just posted an image in the chat. That was like, I guess that's the trilogy. So maybe that's 1, 2, and 3. Anyways, it's kind of a goofy. I just had it in my folder because it's like this dude that's like spaced out, but that's actually Roger Wilco, although it's a funky drawing of him. But yeah, Roger Wilco is the main guy in those games.
Yeah,
that's what's up.
I'm sleeping out here, so don't get too comfy in the couch.
Look at that shit. It's like right around his head. It's fucking crazy. What is that?
But anyways, that was the game that had the call-in thing. Yeah, that was what I was talking about. They also have like hint books as well, like a hint book. So you could like buy the hint book. That's an actual physical book. And it had like a little like highlighter thing, and you had to like choose to like highlight it if you wanted the hint to that part in the game. But then they also had like a hotline thing at one point back in the 90s that you could call and get a hint to the game.
Yeah, I used to have that on Nintendo magazine that they sent out. But then they had the hotline, but also they had the Game Genie, which was fire, bro.
Yeah, I feel like
Nintendo Power.
Nintendo Power, that's the name of it. I still got the Zelda map that was an insert in one of the issues.
Yeah, games. I feel like games nowadays don't really do that shit. It's kind of sad. At least that's what I feel. I mean, I could be totally wrong because I got out of gaming for the most part. So
all right, okay, let's get back on track before Armbar derails this whole fucking thing on us. We were
talking. Wait, what the fuck? We were talking about games, and I'm like, okay, let me join it, and now it's like, oh, we gotta derail this.
I derailed it. I derailed it. I made a joke about a hotline. I first made a joke about Kosho being charged to stream, jokingly, and then I mentioned that they used to have this hotline for these games. I derailed it, but
I know I was just fucking with Armbar.
Those Space Quest games are funny though. You know that movie Spaceballs?
Spaceballs.
Yeah, I saw a TikTok for it earlier.
Space Quest is kind of like the whole game has like these little parodies on like Star Wars and almost like Spaceballs, like not the exact same, but yeah, it's like this the janitor, like the hero who's like he's like saving the universe. Yeah, because he's not like he's not like the necessarily classic like hero in a sense, but he's like also like funny and he anyways, there's a lot of like comedy in there and stuff. It's good.
All right. Okay. Back to Kosho's thing. He was been trying to show a thing for like a good.
What is this? What are you showing, Kosho?
Yeah. What is that actually? It looks like a fucking like a drum. What's it called? Cymbal.
This looks like one of your terrible Blender attempts.
Oh, that's all right.
Hey, listen, ass cheese. Mr. sleeping on the couch tonight because he fucked up. Okay?
No, I didn't fuck
up.
I
heard you fucked up, did you?
It's so I wake up
on the
with
couch
the kid.
tonight, man.
Yeah, it's because I got to get up with the kid in the morning, and I want to make sure I'm up and at him when he fucking headbutts me off the couch.
I'm just messing with you. But
What is it?
Yeah, what is it?
This is basically a recreation of the sort of theodolites they used in these spherical axis measurements. It's almost perfectly modeled. Okay, not really, but they were like they were like the size of a man, and they included both these. They see that base circle, the brown one, and the circle on the axes. One of those represents the vertical component of the angle, and the other one represents the horizontal component of the angle. So you could read the numbers on that horizontal plate, and it will and you turn it to point at the other two stations, and it would give you only the horizontal component if you took only that value. This was useful to them because this is exactly what they were measuring. I didn't finish this animation. I just wanted to show you, because I'm basically going to compare what would happen on a flat plane, which this is on. Three theodolites set up. Shit. 3 theodolites set up on a flat plane, and I'll do it on a curved surface. And if you take the angular separation between the other 2 points on both models, you're going to get 180 degrees because that's just a triangle. Okay. But if you take the horizontal component though of the angles, if you do it here where the verticals are all the same, you take the horizontal component, yeah, you'll equal up with 180 degrees. But if you take the horizontal component of the angle as you point the theodolite from one station to the other on a curved surface, you clearly end up with greater than 180 degrees. So you can take the measurement on either a flat plane or a globe, and it will show you the difference depending on.
So you know what would be good? Through all of Kosho's rambling just now, I just thought of a good idea. You know that 250-mile place, Canago? We go there, where you can see 250 miles. Ooh. You should be able to look to the right a little bit or the left a little bit, and that shit should be tilting, right?
That was a great idea.
Yeah. Why would it not be tilting to the left or the right if we move to the left or the right? But we're looking 250 miles, bro.
Well, you're gonna have to be looking straight at it. You're not gonna be able to look at it from your peripherals. So you're only ever gonna see it angling towards you or away from you, or actually in every case away from you. You're never gonna see it tilting sideways. So it doesn't make sense.
Wait a minute. Wait.
If you look straight at it, yeah, but we're not going to look straight at it.
Yeah.
We're going to look off that. We're going to look off.
You're gonna look at it. You're gonna look at it. You gotta look at it in your peripherals. You'll get a great shot.
On the side of the lens. What are you saying? There's gonna be lens distortion?
No, I mean, there's gonna be all sorts of problems when you try to view. Imagine taking a picture of somebody and pointing the camera fucking somewhere else and hoping that you catch them in your peripheral. You're like, okay, I got him. It's a perfect picture.
It happens all the time. People get photo bombed and shit all the time by doing it. You ever see when there's like 10 people in a picture and there's somebody way off to the left and way off to the right?
That's true. That does happen.
Yeah, Arma. Keep at it, man.
No, but I'm really trying to think about this.
But what if
you first
get up on a huge mountain like that and get a huge view, and have lasers as your plumb lines, and have drones at the end of the lasers, and see if you can get any visuals of the lasers, and then also measure the distances between the drones and the position of the drones as related as they are to the ground. And then you could actually measure the triangle in the sky if it exists.
Well, you know, I've always thought the best way to do that test, actually the best way, the only way I would ever do it, or accept anybody else's measurements who did it, is if they use GPS. Because GPS...
fucking gay, bro.
Because GPS using precision points, like centimeter level precision, you could take the base, 4 points at the base of a building and 4 points on any other floor, but you could use the top of the building and create a rectangular prism with that. And you can compare that to a rectangular prism anywhere else in the world, let alone, the next city over. And you can easily compare whether their verticals were parallel or not.
Absolutely not. It's silly. We already know they can fake it. So why are we going to trust them?
How could you fake that? What are you talking
Oh my God,
about?
are you kidding me?
If you're getting coordinates, how can you fake that? I don't understand that. How could you fake the shape of a building? The shape of the building is correct. It's like, okay, this is correctly representing a rectangle, just as I thought it would. But for some reason, it's angled. It not knowing that I was going to measure this other building happened to magically make its angle different than the other one.
Bro,
Doesn't
I wouldn't. That is the only thing I wouldn't accept. That's the only thing you would accept. That's silly. That's the only thing I wouldn't accept.
Fucking
yeah, Coach. So that's a weak position because you can't verify what GPS really even is ultimately. So
If Pete Shea came in here, if Pete Shea came in and was like, I got a leg bone from a dodo bird and I'm gonna measure the building with it, and then you were like, well, I'm gonna use GPS. I would go with Pete Shea's fucking dodo bird dinosaur bone leg measurement.
Yeah, okay. Okay, dudes. I wouldn't die on his hill, Geo. GPS is an amazing piece of equipment, and anyone knows that.
Yeah, if you guys were to take bets,
no, I would literally take. I would be willing to accept anything else as possible other than GPS at this point.
Seriously,
wow, dude.
Really? What if money was on the line? You had to do the dinosaur bone like thing.
What if
and then
aliens
GPS?
attack? I mean, come on.
I don't know. I don't.
Well, if the dinosaur bone's got a nice, solid length to it, you might be onto something there. Just one bone at a time. Mark it with a crayon as you go. It'd be good.
You guys are hilarious.
It looks like Kosho ate all the crayons trying to make this blender drawing he's got going. What is this?
I'm with the dodo.
Is this a video game? Like, what am I looking at here? Is this a tower defense game that you're building? I love those tower defense games. Is that what you're making here, or what is this?
Yeah, I'll be.
Go ahead, let him have it, Armbar. Let him have it.
I'll be honest. I'm kind of with Jeremy. I'm not exactly sure what I'm looking at.
Yeah, Coach, what is this? Periscopes looking up through the floor?
That's what it is. Submarine periscopes.
I thought maybe it was I don't know, from far away, it kind of looks like ballerinas, with that little little skirt, whatever
I
the fuck that
definitely
is.
don't see a curve anywhere here.
I think he was using those as if those are theodolites looking at each other.
Okay.
I don't see a curve. Anybody see a curve here in this?
Sounds like Kosho went to get another Zima.
No.
Hold on, I need to see this stuff. I need to see this whole.
Yeah, you have to have grown up in the '90s to even get that.
That was hilarious. I used that a couple months ago. Did you hear that from when I said it, or?
I got it.
Maybe because I probably hadn't heard of Zima in years.
I used to love some Zimas, man. Bro, you never get a breathalyzer, man. You drink Zima, dude.
Put a Jolly Rancher in it.
Ah. Do they even sell them fuckers anymore? Something different.
I don't think so.
Hey Yarma.
So,
you want to speed run that thing?
Speed run?
The orbits thing.
So Zima was introduced in 1993, and then it says they ceased production in 2008. But then it said in 2017, Miller's Coors announced a limited release of Zima for the U.S. market. It was sold again in the United States in the summers of 17 and 18, and did not return in 2019.
They want. Dude, Bev and them, Bev and them never even heard of V8, bro. Like a V8 vegetable juice, like that shit's like local to America, I guess. I mean, who hadn't heard of V8?
It's because Earth's tilted and they're all walking sideways over there. Remember them?
That's what I was saying, dude. I was comparing the hump and the curve, the hump and the drop to people who are walking with somebody who ain't had their V8 yet or some shit. They didn't know what I was talking about with the V8.
Well, hold on, not to you should have had a V8, but like, hold on. I'm trying to figure this out here. This whole tilty.
Are you playing Kosho's tower defense game?
No, no. No, I'm messing around with Blender or whatever, and I'm sort of noticing like this whole. Remember the whole thing you brought up, like the tilting, like mountains or buildings or whatever the fuck.
Yeah, I remember.
I don't know. I feel like if you're getting like that much, in view, I feel like I don't know. I'm trying to do it right now, and at least in Blender anyway. I don't know about real life, but in Blender, looks like the buildings even on a flat plane, they look like they're tilting away because you're kind of getting a whole lot of. I mean, maybe I'm just doing this wrong though. Hold on.
So you're saying we would measure spherical excess on a flat plane?
No, that's not what I'm saying.
You're about to be the flat Earth hero right here, Armbar.
I never said that. All right, no.
That's essentially what you just said.
No,
you said it looks like it's tilting, even though it's on a flat plane.
No, forget I said anything. Actually, all right.
No, we're not forgetting that. I want you to share your screen right now.
No, I'm trying to figure this out. What is going on?
No, share your screen.
Hold on.
Get Kosho's bullshit tower defense thing out of here and put your screen on and show us the tilt on the flat plane.
Hold on. No, you know what? Actually, now that I think of it, hold on. This actually might be.
If they sold tickets to it, I would buy it.
I'm
hoping you can show me here.
Well, first off, it wouldn't be excess or whatever because the tilt. Let me see. Hold on. So
if it looks like they're tilting left to right, okay, listen to me. They only measure spherical excess because it's tilting left to right. Okay, first of all. Second of all, if it looks like it's tilting on a flat plane, left to right, that's what you need to measure spherical excess. So you would probably measure it if it observably looks like it's tilting. I mean,
well, I mean, where do they measure the like how do they like measure the base of the thing or do they measure the tops of it? Like I don't. How does this work?
The spherical excess thing?
It doesn't matter.
It doesn't matter. All right. I mean, I don't know. I mean, because I'm not really sure what is going on here. Let me see.
Hey, real quick. Hey, Gio, are you there?
I can't figure that out.
Hey, Gio, you here? Hey, Upside Down Australia was asking for permission to talk. He's one of the guys. I just came from my other server, brought people over here. He was one of the dudes that I spoke about a couple days ago, if not yesterday. He is from Australia, and he's a really good person to use for the argument against the whole Southern Cross, all that bullshit from ballers that what they bring up. But yeah, can you give him perms?
Against the Southern Cross?
Yeah, I think he's unmuted.
Okay. Australia, you unmuted?
Oh, yeah, thanks, man.
Yeah, that's what I'm like. Cool. There we go.
All right, I'll mute myself. Go ahead.
What's up with the Southern Cross?
Sorry about earlier, APOC. Yo, listen, Armbar.
So,
it's all good, Jeremy. Like, I was really mad, but I love you, man. You're good.
I went to unmute you and you had gone already. So
yeah, I was really mad. Like, I was so pissed, but it's okay though. It's okay. It's all good. It's all good. Hey, man, it happens. It's all good. It's all good.
Armbar.
So Bacon.
Oh, go ahead.
Oh, I think Bacon was asking what's up with the Southern Cross.
I think
yeah.
What's good with it?
Yeah, I don't have any problem with the Southern Cross. I think you guys do. Me personally, I don't.
Do we? What do you mean?
Well, I mean, you think that you can't see it from the Northern Hemisphere?
Of course you can.
Oh, so you can. So it's not a globe.
Why wouldn't you see it from the Southern Hemisphere?
Oh, the Northern Hemisphere.
Yeah, I shouldn't see it. I'm at 20. I'm at 29 degrees. and I could see the motherfucker barely.
Yeah, I mean, why shouldn't you see it?
Because we shouldn't see it past about 10 degrees, bro. 12
Why?
degrees.
So from the northern hemisphere, Bacon, are you saying that you can see the Southern Cross from the northern hemisphere?
I'm guessing people can see from the northern hemisphere. Yes. I don't know. I haven't been there, but I'm pretty sure you can.
So it's not. So it's not a sort of constellation that proves it's a globe.
Maybe not, but you said there's a problem for us.
Oh well, for you, you're here. You're conceding that it's not a constellation that proves it's a globe. So maybe it's not a problem for you. You understand that the Southern Cross has nothing to do with the Earth being a globe. So that's great.
I think all stellar observations have to do with Earth being a globe, but
I think Bacon. I think the main problem, Bacon, is that if you can see the Southern Cross from the northern hemisphere, then it's no longer a ball, because otherwise you would be seeing through dirt.
No,
Dirt
hold on.
being dirt.
What do you think is
yeah.
Hold on, can I elaborate? Can I elaborate? Well,
Here we
the
go.
tip of the southern, Acrux, the tip of the Southern Cross, is the southern point of the constellation. What do you think is the declination of that star?
Hold on a sec. What you said? Just say again. With the tip of the star on that, I missed it.
The Acrux is this most southern star of the Southern Cross.
Southern from where? So like southern being, if you looked at it from which angle? So like you're saying it's that star is the most southern part of it.
It's the it's between all the four stars, it's the one that's going to be furthest from the north, from your north direction.
So further from the north.
From the equator, bro. From the equator.
Hold on, real quick. Kosho.
Yeah,
Come on, real quick, and then you guys can. All right, go ahead. Yo, Kosho, recreate one of the triangles in the fucking trilateration thing from the Arc of the Parallel 900-page bitch ass bullshit document, and then let's see how much.
That's right.
Let's see what radius you come up with.
That's right, Kosho.
Yes.
Listen to Jeremy.
But back
That
to
sounds dope, right? Yeah,
so
go ahead, get back to it. My bad, guys.
The Southern Cross, though, I want to hear this shit, because what I'm seeing right here, the coordinates on it, on the celestial sphere, whatever, the tippiest tip of the Southern Cross is, what is it?
63 south.
Yeah, 63. Yeah, exactly. So we should still be able to see it like around 27 north, right?
Wait, no. Acrux ain't 63. I thought it was like 70. Okay, what's the southernmost one then? Crux?
Sigma Octantis? What do you mean?
No, that ain't in the
Sigma Octantis? Isn't that the claim one where all the south stars rotate around?
He didn't mean that, bro. There's no Sigma Octantis in the almanac, dude. I don't even know why he said that. I'm asking, what's the furthest south declination? What's the furthest south declination? Ain't it one of the stars in Southern Cross?
Oh, it's Acrux, the one I was talking about. It's 63 south.
So that's as far south as the stars go from the equator for navigation. Ridiculous, dude. Fucking ridiculous.
Hey, what are you talking about?
No, go ahead, man.
Why is that ridiculous? That is literally
see it from where I'm at. I still shouldn't see it from where I'm at, though, right?
You should be able to see it. You should see the.
Where are you?
Hold on a sec. All right. So hold on a sec. Like he said, no. So like Procopron was pointing out, I didn't get his name. The guy who just basically, what he said is he shouldn't be able to see it now. So when you say you can see it from certain parts of the northern hemisphere, we're talking about like Hawaii and northern Africa. So like, are you telling me they can look through the ground? They can see through dirt?
No.
You don't have to see through dirt. You just have to be in a latitude that allows Acrux to be above
latitude. So lines drawn across a thing on a flat plane.
Oh my god!
But so let's not go into that, because obviously let's not go into that. Obviously, you don't like that, but so explain it to me. So you're in Hawaii. So hold on a sec. Explain it to me. So you're in Hawaii, right? And you look up at the sky and can see the Southern Cross, from where you are.
What's the latitude of Hawaii? I don't think so.
Yeah. What is the latitude of Hawaii? Let's see.
You can't see it from Hawaii?
Hawaii latitude. Yes, you can see it actually, because Hawaii's latitude is 19 north, or close to 20. So you should be able to.
Okay.
Yes, but okay, we get that. We already know you can see it from Hawaii and Northern Africa. We know that you're like, what's the word? I don't know, but you're going to say you should be able to on this globe because of these numbers. But what we're saying is, so what? How are they looking at it? Through the ground, or are they looking up at the sky?
They're looking at it
close to horizontally, but still above the horizon, given that they're not that far from the equator north.
Yeah, I mean, it's
So
pretty simple. If you're, let me explain.
So any of you's able. Any of you's able to show me this, like, for just as an example. Like, I don't care if you use a basketball, a volleyball, and little toy soldiers or whatever. Can you just like position them and then draw a hypothetical Southern Cross and show me like which direction they would have to be facing and looking to be able to see this claimed like Southern Cross?
Sure.
What 3D models? That's fine.
Yeah, I'll do it right now. I create a new one so I don't screw up the.
From that angle. Okay, guess what, guys? Like, newsflash: if the Earth was the ball, and you were at a certain angle, you should never see the Southern Cross, because if I was living on a basketball and I was northern of the center of it, I should never see the bottom of it. Like, I don't know why you guys try to fucking fight this subject at all. Honestly, it's fucking retarded. But hey, correct me if I'm wrong.
Okay, I'll correct you. If you're at the equator, the celestial equator is right overhead. You have Polaris at one side.
Not at the equator, bro. You're north
the furthest
of the
north
equator.
we should see it is 26.5, Bacon. It's 63.5. I shouldn't see it.
My point? Can I get to my point? Thank
Yeah.
you. So if you were at the equator, I'm not saying that's the response of why you can see acrux in the northern hemisphere. I'll get there. If you don't get triggered.
Hawaii's not at the equator, bro.
Oh, too late.
Neither is Northern Africa.
Exactly. It's not at the equator, bro. You're literally. Go ahead. I'm sorry.
Bacon, you just invoked. Sorry, but in fact, Bacon, you just invoked the equator. Now, if the equator has nothing to do with it, so talk about Hawaii. Don't talk about if you were at the equator. Talk about Hawaii.
No, I'll explain how things work on a globe. You're not allowed. I can use the words I want to use to explain what I want to explain, right?
Okay, but the argument is. The argument is saying.
I know the argument.
I'm not cutting you off. I'll say one last point, one last thing, and I'll shut up. The argument is seeing the Southern Cross from Hawaii, not the equator. Thank you.
Thank you for repeating what I already know for the fourth time already. If you're at the equator, you have the celestial south in one, like at your left. Let's say you're looking west, and you have the celestial north at your right. So there's no star you can't see. Every star you're going to see at some point if you're at the equator.
Well, you're not at the equator at Hawaii, bro.
He understands.
Now, the Southern Cross is going to be at your left if you're facing west, and when the Southern Cross gets the highest point in the sky, the acrux, which is the closest to the celestial south, is going to be 27 degrees above the horizon.
26.5. It's 26.5, but he's right, guys. But still, I still shouldn't see it at 29, bro. I'm telling you.
Exactly.
I know you get it,
bro.
Let me.
You're trying. Hold on.
I'm trying to finish.
Hold on. You're Bacon. You're trying to tell us.
Dude, I won't try it. I won't try. Just if you're going to keep encouraging me, I won't even try.
Just real quick. You're trying to give us a measurement from the equator, but we're not talking about the equator. We're talking about Hawaii.
He understands.
All right.
He understands.
So then why does he keep saying that?
Hawaii's fine though.
Okay, so let me get something right though. Let me get something right as well. So he's saying you should be able to see it from 26.5 degrees. Is that what you're saying, Bacon?
Yeah,
He's up. Okay, and then the other guy you said
it should be on the
the
horizon.
other guy.
26.5. Yeah.
Okay, and the other guy you said you can see it from 29 degrees.
Yep, I'm in Florida. Yep.
So about hold on a sec. So about 300 plus kilometers further, you can still see it.
That's impossible. You guys realize that, right? You guys
I'm
realize
not quite
that.
at. I'm not quite at 29. I'm at like 28 and like
Yeah, all right.
28.7 or some shit. But still, it's past.
Okay, yeah.
I'm past where we should see it.
Yeah.
Exactly.
So 1 degree
past
is about 111 kilometers. So about 200 plus kilometers further than
I'm closer
you
to
could
2
be able to
degrees,
see.
man. I'd say.
Yeah, right.
Right.
Okay,
Right.
what's the what is the latitude in which you can observe a crux?
So put yourself on a basketball, and now you're saying that somebody that is above the equator of a basketball can see the bottom of the basketball. That is false, bro. Because you're literally looking through the basketball. What don't you get about that?
They don't get it because they don't want to address the fact that to be able to see it, you have to see through the physical curvature of the earth or you have to be staring through the ground. Those are your two options, buddy. You don't get to look up at the sky. You don't get to stare up at the sky and still see it.
No,
Simple.
Exactly.
Hold on, no. What are you talking about? What latitude first? What latitude first? Hawaii. Hawaii's latitude 19.
Okay, I'll try to finish. I'll try to finish the point that I started.
Yeah, fair enough.
So again, if you're at the equator and the Southern Cross gets the highest point in the sky, the acrux is going to be at 27 degrees, around 27 degrees above the horizon. If we start moving north,
bro. 26.5.
Sure about that?
26.77.
Wait, at the equator? At the equator or at Hawaii? What are we talking about? I'm confused.
That's a slam dunk.
Declination is 63.23.
It's a slam dunk, bro. It's a slam dunk in pun intended. It's a pun intended. It's a slam dunk because you're looking through a basketball.
Can we just let Bacon finish, please?
Yeah, let's let Bacon finish. Let's do this.
Yeah, go ahead.
Right. Okay. I'm going to round up this. So 63.2 you said, right?
63.23, so 26.77.
Yeah, okay, 26.8. Let's round it off. So 26.8 degrees. If you walk that much towards the northern hemisphere, then the Southern Cross is gonna get lower and lower in the sky. When you get to 26.8, the acrux is going to be at the very horizon, right? So if Hawaii is within that range, obviously you'll be able to see the constellation. So pointing out that you can see from Hawaii is completely non sequitur. Now, if Brian says he can see it from 29 latitude, he has an observation that contradicts Stellarium. He's gonna be the first one. It would be nice to have a picture or something.
So you're gonna hand wave the fact that somebody that is above the equator can see the Southern Cross, even though technically there is a ball that you have to look through to see it. Based upon
6.8, yeah.
Yeah, but
What
he said is
here's what he's saying, bro. If you're at the north, the only way you're going to see no stars in the southern hemisphere is if you're at the dead North Pole. And then that's the claim
right?
on the claim on a ball is that you'll see
guys are
no
fucking
stars
crazy,
at
bro.
all.
No, that's not
They're fucking crazy.
How is that crazy? How is that crazy?
That's crazy as hell, bro. Like even when you talk about
through the Earth's ball, bro.
Geometry. I should drop kick you right now, man. What are you talking?
You're looking through the Earth's ball, bro.
You don't know what you're talking about. You're crazy.
All right, so what about this? Because I'm not familiar with it. But how do they get the longitude and latitude? How do they get it? Like, what does that even mean? Latitude and longitude.
I can explain that. So one way you can get it is if you can look at the sky and see
which part of the sky?
Stars.
Any part of the sky?
No, you look at a star that is at the celestial equator. So, for example, the most northern star in Orion's belt is pretty close to the celestial equator, right? Or you can take star trails. Like if you take star trails, you're going to see exactly where the celestial equator is. If the celestial equator is vertical to you, if it's going straight overhead, it means you're at the equator. That's where the equator is where the celestial equator is right above your head. Now, if you move north, let's say, I don't know, a certain distance, the celestial equator is going to start tilting, and it's going to tilt southwards.
Anybody
So
with a brain.
The amount of degrees the celestial equator tilts is your latitude.
Yeah, so you're talking about like an angle. Is that would that be right? Like as an angle? Like so from that point.
It's a line. It's a line on the ground. It's every point on the surface of the Earth in which you get the angle to the celestial equator.
So you need to be. So you measure it.
Altitude.
Fuck's sake! I'm trying to understand, and you're just saying all this stuff at once. So, it has to be taken from the ground. You're saying, like it's from the ground to the star, an angle.
Yeah, it's a line on the. Yeah, it's a position on the ground.
Yeah. So you said, oh, for fuck's sake! So when you're underneath it, it's directly above you. You're saying, like, I don't know what tool you're using to measure that, apart from your eyes or whatever. But so you just look at it, and it looks like it's straight above you. Is that what you're saying? So no equipment. Do you use it? Do they use any equipment? I'm asking. Do they use like any equipment or anything, or they just look at it?
You can use a theodolite for that.
Or a telescope.
If you were using a theodolite to measure this angle that you're speaking about, if it is at a certain angle above the equator, you would not see the bottom of the ball or the Southern Cross. What do you not fucking understand about that?
The Southern Cross is not in the bottom of the ball. The Southern Cross is not in the bottom of the ball. Maybe that's your confusion.
Yeah, I think you're confused.
That's not
with
the celestial south.
pole.
What do you mean it's not at the bottom? What?
It's not the south celestial pole.
It points to the south. It's not
there
at the
is
south.
no south celestial pole.
You're in Australia. What the fuck? You're in Australia.
Dude, that's like hold up. That's like me and my cousin being on a hill, and when he's behind the hill, if I can say that I can still see him, that means I'm seeing through the dirt of the hill. What don't you understand about that, bro? It's such a fucking like, come on, dude. It's nonsense. It's fucking total nonsense.
It's just you not understanding really simple geometry. That's all.
No, it's not, Ruhip. You're just being an idiot. It's not about not understanding it. Because someone, hold on a sec. Because someone says something which is outrageous, right? And it's like people point out the flaws in what they're saying, and then people just sum it up to not understanding. No, I understand exactly what you're saying. So does he. He understands the claim you're making. We're just pointing out the absurdity of it, and then you say you don't address the absurdity. You say, "Oh, it's because you don't understand."
Exactly.
Bacon is drawing it on screen right now.
Yeah, he's drawn. I can draw Superman. Is Superman real?
You said that there's no south celestial pole. Did you literally say that there's no south celestial pole?
Yes. Show me the south celestial pole, please, Ruhif.
Yeah, I will point my camera at it tonight if you like.
Okay, yeah. So you're pointing out a star and claiming it's the pole. Do you know what a pole is, Ruhif? Do you know what a pole is, Ruhif?
I'll do a time lapse and show the rotation around a single thing. That is the south celestial pole.
A long, slender, rounded piece of wood or metal, typically used with one end.
Usually cylindrical.
Another term for perch. Propel a boat.
Usually cylindrical.
Anyway, Bacon is drawing the Southern Cross geometry now, right?
I crushed the software. I accidentally typed 53 subdivision on and it crushed
on a sphere.
I love how they use the ball model to prove the ball model. It's fucking comical.
It's called circular argument. Circular reasoning.
Not possible on a sphere. We're showing you how it is possible on a sphere.
You're not showing us. You're showing us on what was that? No, I missed it. What was it? CGI, AutoCAD. What was it?
Right. It's geometry.
Microsoft Paint.
Wait, hold on.
I'll do it in Paint.
Hold on.
This is
hold on,
just to
hold on,
help you visualize the
Hold on.
points.
Why does he have the? Why is he allowed to make his claim saying you can't see this, you can't see that, right? But then when we actually try to go, and show it, right? Like it's not enough. Like why don't you show?
You didn't show it. You didn't show it. You drew it. We can draw it too. Well, I asked you to. Well, you didn't show us anything though. You didn't show us anything.
You're making a claim that it's not possible. We are showing you that it is. Very simply.
No. Oh my God. No, we're not claiming that's not possible. We're telling you that on your ball it wouldn't work, and then you're just drawing it.
What?
Yes, because it would work, and for some reason you don't see why. That's why we're drawing, to help you understand why it should work.
I can draw anything. Does that make it like real? Just because I can draw it. Jesus Christ. Like, just because I can draw it, all of a sudden, I can see the Southern Cross from Hawaii because I drew it on Microsoft Paint. Like, no.
Do you make the claim that it's not possible to see the Southern Cross from
Which
Hawaii?
claim did I make? No, hold on a sec. Which claim? We said you can see the Southern Cross from Hawaii.
Right?
Yes.
Are you claiming
Then we
that's
said
not
you
possible
shouldn't be
on the
able to see it. Then we asked you, show us the man standing in Hawaii, how he has to look. How does he look? And then show the hypothetical Southern Cross where it is on that ball. Then show me standing upside down in fucking WA, looking at it as well, and show us how that makes sense. Then draw a line between those two men and show us, please. Thank you.
Right, so you want me to go to Hawaii and take a photo?
Oh, so now you want me to actually demonstrate it opposed to using Microsoft Paint? Yes, please. Yes, Ruhif. Thank you.
How would you like me to demonstrate that?
But I did. So see how I just told him, right? I said, you want to draw it? Draw it, right? Now show me the man standing in Hawaii. Show me which direction he has to do it really specific, right? Tilt his head. Show me where his fucking eyeballs are, right? Then show me mine standing upside down, looking at the same thing. Then draw a line between me and that man on Hawaii. Now use it to scale. Use the globe model to scale. Show me it like that, please. Thank you.
Bacon's doing that in Blender. Are you satisfied?
Well, I joined Bacon's stream and it said the stream has ended.
We'll join it again.
Yeah.
No. Even still, you're literally trying to like say that the person in Hawaii is looking through a Earth ball curve to see the same stars. Like,
no,
hold
we're
up.
not.
Like, hold up. I don't know how you guys can even fucking fathom the point that somehow, some way, if we could just like reduce it to a basketball, okay? The basketball is going to have a north and south pole in your belief. Then how does somebody above the equator see the Southern Cross that is only visible to those beyond the equator? Because if you're above the equator, you can no longer see it. Like, what don't you grasp, bro? What don't you fucking grasp?
What don't you grasp, Brockfon? Do you understand the declination of Southern Cross? It's like 63 degrees, not 90.
No. Wait. You're dealing with numbers and angles, but they don't even match up in reality.
Yes, they do.
Again, if I'm above the equator, technically, if I'm above the equator, this imaginable fucking point that you're trying to put me at, if I'm above the equator, I should not be able to see anything that is south of it because it's a ball in your model. Holy fuck.
Just incorrect, Brockfon. Just wrong.
Yeah, I'm showing here if you want to
think about it, bro. Wait a minute. If you're at the equator, should you not see any north too? Then what are you going to see, bro?
Oh, that's a good point, actually. Look at you, Brian.
These guys,
you guys
bro,
need a
it's
flat earther to
fucking
tell
like,
you when you fucked up, right?
holy fuck, Ruhif. Come on, man. Like, what are you even saying right now, bro?
Brian, can you tell Apocryphon that he's a fucking idiot, please?
Bro, shut the fuck up.
Because the way y'all explain it, bro, the way y'all explain it is fucked up. Like,
Ruhif.
it is.
What are you doing, dude?
So where's
Well,
that
I have the worst
depiction?
explaining skills in the world, bro. But I still hold true that if I'm at 28.5, how the fuck am I seeing it?
Where's that depiction?
Well, I mean,
exactly.
Wait, the whole thing? I mean, yeah, you won't be able to see the whole thing, but you still see, the stars that are visible, though. I guess.
Yeah, I don't think you're
So
going to see.
okay, all right. Hold on a sec. Hold on a sec. Hold on a sec. So the guy, because I'm not looking at the screen. I'm looking at things, depiction. The guy that's saying 28 degrees. Can he tell us like what position do you look? Like, do you stare straight up or do you look like out? Like, how do you look?
To the horizon. You look south. You look south, close to the horizon.
Let him answer.
Yeah, for me, it's sitting dead on the horizon, and
So you look at the horizon and you can see it.
Do I have to fucking draw a picture for you fucks?
Look at the
Use your
light.
crayons.
Oh fuck! Okay, we're looking at the live. I'm looking at the live stream, but you're using the same globe model to argue for the globe model. But I'm waiting for you to show me. But hold on a sec. Yes, but I'm still waiting. I'm still waiting for you to show me upside down looking at the Southern Cross and the man in Hawaii looking at the Southern Cross.
Right. You're claiming that this is not possible on a globe, and we're
I'm
showing
waiting
that
for you
it
to
is
show me.
possible.
No, it's not. It's not. You're claiming that you can see it, and it's fucking impossible to see
Right.
it.
No.
Okay, so you are claiming that it's not possible, correct? Are you claiming that it's not possible to see it?
Listen. If you wanna draw up a fucking model, a CGI fucking computer generated fucking interface for your ass to understand the way you can see around a fucking curvature in your own paradigm, like guess what, bro?
See it around.
It's bullshit.
Jesus Christ.
Okay, look at it. Have you seen the live stream of Pokerphone?
I'm watching you, Bacon.
Oh, but I mean, apart from saying you have to see around the ball, like
Where did you put the Southern Cross? Where's the Southern Cross? Like in the sky? Where is it?
it's on the tip of their line. The line points towards the direction.
Which line? That one there?
This one.
What? That tip of that line?
Bacon.
Yes,
Bacon.
tip of their
Hold
line.
on. Bacon. Can I point out something real quick, Bacon? You are looking at this fucking point from like a puppet fucking side-eyed view, bro. But in reality, if you were to zoom in to the point of Hawaii,
This is Hawaii. This is Hawaii. That's what I'm doing
it,
right now. This is Hawaii. That's where the
if
star
you were
is.
to zoom in all the way down to the ground,
star.
If
That's
you
what I'm doing.
hold on.
Yeah, like a Pokerphone saying no, because you don't see it. Bacon. Listen, a Pokerphone's trying to tell you zoom into the ground. Show me the man from his point, not here. How many kilometers are you claiming to be above the Earth right now?
Exactly.
To be able to see that point.
Like 50 fucking miles up, bro. He's fucking like
keep going, Bacon. Keep going, Bacon, all the way down to the ground, because that's where we stand, Bacon. We stand on the ground. So from the ground, Bacon. Quick.
Everyone relax a little bit, please.
Obviously, you're still gonna see it from here. Like
no, from the ground.
No, Bacon. You're fucking missing. No, Bacon. Your fucking point of view is miles up in the sky to see that fucking star. Fucking put you on actual Hawaii. Zoom in.
This is Hawaii. This is Hawaii right here.
Bacon, just go all the way to the ground, like you can do with Google Maps.
All the fucking way.
This isn't Google Maps.
Can you set the coordinates, Bacon? Like, can you actually
That's
type
the
in?
max of your fucking little fucking computer generated system, bro.
But you see how he won't go to the ground? You see how he won't go to the ground? Like he just won't do it?
There we go. All right, what are the XYZ coordinates?
They can't go to the ground. They can't. I'll tell you why they can't. Because if you zoom into the ground, you will not fucking see it. Bottom line.
Right? He's doing it apart from. We're just trying to figure out.
And honestly, I need to ask something as well. So, Bacon, you know how you said that line, the tip of it is the Southern Cross? Bacon.
Points to the Southern Cross. Yeah. Points to the.
No. Okay, all right. Hold on a sec. So, where is the Southern Cross in that depiction? Where is it? At the tip of that pole.
Yes, exactly. Yeah.
Okay, so what's the distance of that pole? What's the length in kilometers or miles, whatever you want to say?
You got to think in terms of no perspective at all, bro. And you got to think in terms of like infinite fucking distances, and then you can make
yeah.
better sense of it.
Yeah, but I need to know. I need to know for. But hold on a sec, Ruhif, Bacon. You guys have asked us to look at this, right? Now I'm looking at it and I'm trying to ask you for my understanding, so I can understand it properly, not just stare at a fucking screen. So that white pole there, is that a certain amount of distance, or is you just drawn a line and claiming that the Southern Cross is at the end of that?
Yeah, the Southern Cross will be much further than that.
So
Dude,
draw the line to where the Southern Cross is supposed to be, please. Thank you.
Dude, you're fucking
That white
floating
line.
on the ball, bro. You're floating on the ball miles up to see it. Zoom in to Hawaii
right at the surface.
on
It's
the
right
ground.
At the surface. It's right at the surface.
Zoom in all the way, bro. Oh
Yes,
my
it's on the
god,
surface.
these fucking dudes.
Wait, Bacon, real fast. Can you clip
He's
to
not
the
gonna
ground?
do it.
Will the Southern
It's on the
Cross?
surface.
Will clipping on the
It's
ground?
on the surface.
Okay, I see.
No, he's not. He's above
Yes,
the
he
earth.
is.
That's why he can see.
Go back to your camera view, where you can see the camera. Like, there we go.
Go all the way to the surface. You will not fucking see the Southern Cross. Go all the way
Listen.
zoomed in, bro. You're
You know
such
this
a
will be a lot
fucking
easier.
deceiving
No,
liar.
you still see it. You still
There
see
you
the
have
Southern Cross. It's right there.
That's not the ground.
No.
That's not the ground.
Okay, Bacon,
That's not the ground.
just put like a pixel clipping through the ground, because at that point
You're
he really
literally
can't say shit.
floating above the ball. You're literally floating above the ball, bro.
But hold on,
God
Bacon,
damn
just put a pixel into the ground, like literally just clip it, because I think it's still enough, you know, just to satisfy his.
Let me say something real quick, Arma. They're
What's
saying that the Southern
already
Cross,
there.
like Acrux is 26.5 degrees or something like that away from the South Pole. So that's why you'd see it a little bit north of the equator. But still, I still maintain the argument that I still shouldn't see it by over 100 miles.
Okay, but who's the other guy? Who's the guy who said,
evidence,
"Oh, you're not on the surface yet"? Who's that guy? What's his name?
I'm saying you're not on the surface.
Look, he's literally in the ground now, all right? And you still see it, all right? So you need to, you know.
You're not on the ground though. You're not
No,
though.
is.
You're
He's
not.
literally he's literally clipping through the freaking geometry of this fucking sphere.
You're not on the ground. That's not the
Inside
ground. That's literally not the ground.
Well, that is.
Okay, all right. Hold on a sec. Hold on a sec. Listen. You know, on Google Maps there. You know, listen. You know, on Google Earth, right? When you when you zoom in and out, it tells you what's the claim elevation, like 100 kilometers above the ground or whatever. Now, if you go and use the Google Earth and you go to the view from what it will be from like, and we're humans on the ground, so maximum 0.0 whatever the fuck it is, 1 meter, 2 meters above the ground, right? You don't see that. It doesn't look like what you're showing us. That's the problem.
Let me tell you the trick, though, bro. Let me tell you the trick. What they do is, no matter where you're at on the equator, they're going to put the North Pole, like let's say the North Pole, Polaris. They're going to put it over your head, no matter where you're at on the equator. It's going to be directly 90 degrees. That's the trick. They do the same thing with the South Pole. So you could be on one side of the equator, and it's directly over your head. You could be on the whole other side of the equator, and it's directly fucking above your head still. You see what I'm saying? So that's and Ruhif, that's what they're failing to. They're just throwing perspective out the door and not explaining that
literally perspective and
bullshit.
Hey, here's what's funny. Even their own motto will not put them at ground fucking zero on the elevation of it. Their own motto will not allow them to zoom in that close. It's fucking hilarious.
Show him that the camera's at ground
I meant a
level.
tangent from your feet. Sorry, I meant a tangent from your feet. From anywhere on the equator, it's exactly 90 degrees around the whole entire Earth. It's a tangent from your feet. So that's the y'all should explain that a little better.
So Ruhif was all. Yeah, so Ruhif was all like, Bacon's doing it in Livestream now. And I'm still not seeing what I asked for. Like, I'm still not seeing anything close to what we've asked for.
All right, Bacon, can you show him that the camera is at eye level? Is at ground level, sorry.
Okay, that's not what you see at eye level. We can verify that by being at ground level and seeing. We don't see that amount of like area with our fucking eyes, man.
Now,
Look where the camera demonstrate it because they couldn't show you enough space in between to ever demonstrate it perfectly.
Look where the camera is.
You're saying that this is what you see. Hold on a sec,
bro.
Fuck's sake, man. Listen. Sorry, bro. Sorry, not you, Apocrypha. But is he saying that if you were at ground level, eye level, this is how much you would see?
Look where the
This is
camera
what
is.
you would
It's on
see.
screen right now. Look where the
Yeah.
camera
Fuck's
is.
sake, you're an
on
idiot,
screen.
man.
No.
Look where the
Why?
camera is.
Hold on. Wait. Hold on.
No name calling.
Let me say this. Let me say this.
Dickheads.
The visual that he's doing on his fucking graphic, if you can see this ball fucking shape curve, then you are not on the ground, because on the ground you will not see the way he's representing it. And this is it's so fucking disingenuous right now. It's so
You're just being dumb.
disingenuous.
Look where the camera is.
This is not a perfect sphere. It's made of vertices. As you can see,
Yeah.
there's a lot of lines there. So obviously, it's not gonna look like a perfect sphere
Oh,
because we have vertices.
Wait, how many vertices actually? How many polygons? How many polygons?
100 segments and 50 rings, or the other way around. I can make a better one. Maybe.
Yeah,
But you might get too late.
I end up
Alright, got
using.
perfect spheres.
I use icospheres for this kind of thing, and I also mine is like 138. What is that? 137,000 triangles. Mine is kind of smooth at the surface, but also, I mean, I don't know, but yeah, you got it though. You got this.
Hey, but hold on though. Every example you showed, it still shows the curvature of your model. So if you're seeing the curvature of the model, you know, all of us know, when you're standing on the beach, you do not see that fucking view, bro. Get the fuck right. Stop lying.
Did you listen?
Mine doesn't have
listen
curvature.
to the explanation?
You guys
stop complaining.
Yeah, can we just show the camera sitting on the surface, and then we go past
Can you do
that?
this? Can you do this, like, for the sake of this, to clarify? Can one of you, like Ruhif, can you put up your live stream, right, of do the same thing he's doing, but from Google Earth, and show us what we see from ground level?
Exactly.
Below the surface now.
Exactly. You're not
Can
going
I
to
get-
see what he's showing. Exactly. Because he's literally hovering above, probably
No.
like fucking 40
Listen.
I was
miles up
literally
in the air.
below it.
Listen. Look at the screen. The camera is on the surface. I go back to that.
No. Hold on a sec. All right, let me do it. Let me do this, please.
Leave it there.
Let me do this,
right?
Let me do this. All right, I'm trying to clarify for the sake of it, because it seems to be the point of confusion right now, right? Ruhif, you're claiming that on Bacon's screen, up in some little point, it says this is what you see from eye level. Now, clearly, this is in a computer. Now, when you go to Google Earth, we do not see this amount of area from ground level. You know that. I know that.
Exactly. You're never gonna fucking see, because what he's showing on his graphic, you're literally like miles up in the sky to see that.
No. Shut
But
up.
that's not from
Look
the
at
ground,
screen.
bro.
Look at the screen.
Ruhif, that's what I just pointed out, Ruhif, though. We've looked at the screen, but what we're saying, what your argument, Ruhif, is you're saying that on the screen it says this is ground level, but you know and I know from reality this is not what you see from ground level.
Exactly.
Bacon, can you just show them that it's on ground level again, please?
See though, he's just going to keep saying that on the screen it says
You
ground
keep saying
level,
it's
but
not on the ground level.
because we know
It's on the ground.
Okay. No, your screen says this is what you would see at ground level. You know, I know, Apocryphon knows, everyone in this server knows this is not what you see at ground level.
Look
all know that.
Look what he's posting. That's not fucking ground level, bro. God damn.
Yeah, and I'm
I think I
below
give
the
up.
surface. This is below the surface. If I go up,
No, it's not.
No, that's not what you
It
fucking
is.
see from that
Yes.
surface, bro. Your
I'm below,
model is
below,
fucking
He's
wrong,
showing us,
dude.
bro. He's showing us areas of land mass. He's showing us areas of land mass and saying this is what you see at ground level.
Hey, guess what? Hey, guess what, guys? When I'm standing, guess what, guys? When I'm standing, guess what? When I'm standing on the ground,
I can't
guess
see
what,
the star
guys?
a couple of degrees above horizon.
Listen.
Guys. Hello. One at a time, please. Thank you.
Okay. Here's the deal. Here's the deal. What they're showing, they're representing that when I stand at the shore of the west coast of America, I could literally see the whole continent of fucking United States from my position based upon their fucking graphic that they're representing. Because if you look at it, it's literally a high elevation, but
No,
they're
it's
trying
not.
to claim that no, this is ground level. That's bullshit, bro. Total bullshit.
We have shown you several times it's on the ground.
No, well, Ruhif, I've asked you to do something, and I've asked you politely. I've said, you're saying, and I've addressed it, right? I've addressed it. You don't want to address that. If I would appreciate it if you do address that. This question, where I said, me and you know both, we both know that this is not what we see at ground level. I'd like you to address that. Now, the second thing I would like you to do is put up Google Earth on your screen and show us what it looks like when you zoom in the same way he's zooming in, and it shows you that you're a certain height above the ground. I would like you to do that, please. Could you please do that, Ruhi?
I can't put stars on Google Earth, right? I can do it
No,
on
because Ruhif,
Valerian.
hold on a sec. Don't cut me off, Ruhif. I'm not asking for the stars right now. For some reason, we've moved past the start. We're still trying to get to Southern Cross, but at this point, we're trying to establish what you see at ground level. So, could you pull up Google Earth and show us what you see at ground level, and then we can verify if it looks the same or not as what Bacon's showing us.
Are you talking about curvature left to right? Is that what you want to?
No. I'm
So what is the
asking
point
you
of
to
this?
just simply I'm just asking you to simply pull up Google Earth, zoom in. It will tell you in the bottom screen the same way you're pointing to Bacon's screen and going, it says ground level, it says ground level. On Google Earth, it will tell you 100 kilometers above the surface, or elevation, which is sea level, obviously.
But are you
50
talking
kilometers.
about seeing left to right curvature?
No, Ruhif, now you're
No. So what's
obfuscating.
the
I'm just
point?
asking you to do Google Earth. I'm not asking you to ask me what I'm asking, right? You already
Well, I'm
heard
not
what I
going to
asked.
go to any effort unless you tell me
I
what the point
asked
is.
you to show me Google Earth and just show me
Yeah.
that it's the same as what's on Bacon's screen. Thank you.
In
If you
what
can't do
respect?
that,
Left to
please
right
stop saying
curvature?
that it's at ground level, because it's not. Thank you.
The same in what respect? With left to right curvature? Is that what you're trying to say?
No, forget the curvature.
Then I'm not going to do
Ruhif,
anything
forget
until
the
you tell me
curvature.
why
We're
I'm
not
doing
asking
something.
about curvature. We're asking, this is what we're saying. Okay, so you keep asking me. So now I will break it down for your simple mind, okay? So on Bacon's
We're about to
screen.
find out that you didn't listen.
Okay, now
Right?
I'm trying to break it down. And you're speaking over me. You asked for clarification. On Bacon's screen, me and Apocryphon are the main ones voicing this concern, okay? That what Bacon is showing us appears to be what it would look like if you were very high above the surface of the Earth. Now, if you pull up Google Earth, which will show you real images, okay, when you zoom into a certain point, when you zoom out past a certain point, it shows you generated images, okay, computer. But when you zoom in the bottom right corner, it'll tell you 400 kilometers above the Earth's surface, 300 kilometers above the Earth's surface. So being that what we're talking about is being at ground level, being able to see the sky, could you zoom in all the way to ground level as much as you can and show us what it looks like from ground level? Because
Hey, let me ask you guys a question real quick. If you're 10 degrees above the equator looking south, how much of the southern hemisphere would you expect to see? Just out of curiosity, what do you think?
Nothing within 10 degrees of the celestial pole. No,
Not
it's
you.
upside down Australian.
I'm not asking you, Ruhif, for fuck's sake.
Well,
I'm
upside down
asking them.
Australian has asked me to do something in Google Earth, and I'm asking, when you say does it look the same, I am asking you, do you mean in terms of left to right curvature?
Okay, this is called a stall. This is called stalling. So opposed to just showing Google Earth and then being able to look at the screen and then go from there, you are refusing to do it, and you're simply stalling by asking me, well, what do you mean? Well, does that change your ability? Hold on a sec. Does it change your ability to pull up Google Earth? What I mean by that? No, it does not. So pull up Google Earth, because what I mean by it, or what Apocryphon means by it, or what anyone else in the server means by it, doesn't inhibit your ability to pull up Google Earth.
Okay.
Hey, let me ask you a question. Let me ask him a question, Riff. If I'm
Were
at
you
the
listening
equator,
to Bacon when he changed the number of rings and the number of slices on the sphere? Do you understand
So
what
no
happened there?
Google Earth. All right.
Do you understand that explanation?
They don't. They don't
no,
engage.
they don't, and neither do
Okay,
we.
well, let's
Listen. Hold on, Ruif. Let me ask him a question to clarify. If we're standing on the equator looking at Polaris, which is like dead over the North Pole, where would you expect to see that on your horizon? If you think you were on a globe, like if you think you were on a globe, where would you expect to see Polaris if you were at the equator?
Okay, is this Google Earth on his screen? Great. Finally. So Bacon's got it up. Ruhif had the courage to do it. But let's see. But don't take offense. Ruhif, don't be offended. You're from Sydney and Melbourne. It's natural. It's natural.
Because you didn't understand the explanation, right? Just because you're an idiot.
Shush, we're watching Ruhif. We're trying to watch the stream. Bacon, zoom in, zoom in. What do you got? What height are you?
Zoom in closer. Zoom in closer. You're not on the ground yet. You're not on the ground yet, Bacon. Zoom into the ground.
All right. You can see it here. His camera is 3,936 meters. His camera is 1,956 meters.
Zoom in closer.
Keep going. 937 meters above the ground. 928 meters above the ground. Keep going. Zooming in.
Zoom in. There you go.
He's still 800. He's still below, just below a kilometer above the surface.
No, he's not. Look at the
eye level,
camera.
bro.
Look at the camera.
That's the camera.
Height and the elevation to the right. Camera 835, elevation 801. He's on the surface. Now, what is your point?
No, he's not on the surface.
What do you mean he's not on the surface? Bro, hold on a sec. Listen. Hold on a sec.
He's not on the surface yet.
Ruhif, are you saying... Are you
floating above it?
The camera height is 716. The elevation is 690.
Listen! Fuck Ruhif! Wait, listen, please. This is frustrating at this point. It's frustrating. Listen, Ruhif, if you're standing on the ground, okay, now let's pretend you're 2 meters tall, Ruhif. You're 2 meters tall. Now, let's give you a 5-meter pole, okay, to hold your camera on. Okay, you got 7 meters camera height. Go.
Go, yeah. Zoom into 7 meters. Go ahead. Go ahead. Go zoom into 7 meters.
And the elevation is 690.
Bro.
Why is he doing this though?
Zoom in to 7 meters, bro.
Okay. But let's ask him because he's going on about the camera height and the actual elevation. Yeah. What's your point? What's your point to that? What's your point to that, Ruhif? Because we're talking about.
Bro, in their model,
30 meters.
If a star is 90 degrees, they could go all the way to the moon.
679 meters is 30 meters now.
No,
why can no one's bro? We're not following the friggin' argument here, man. Everyone's saying right. So
he's at 716. The elevation is 679. He's 37 meters above the surface.
Everybody sees that he's not fucking zooming in to 7 meters above the fucking elevation of the Earth.
Listen. Stop for a second. Just all right. Address what he's actually said. So what I'm saying is. What he's trying to say now, if any of you's missed it, he's trying to say that 675 meters is above sea level. Correct, Ruhif? That's what you're trying to say? Okay, and so you're saying that, and now you're saying that we're 37 meters above the earth, the ground.
Yes.
Okay, so, but we're talking about, fucking hell. Okay, but we're not talking about why are you 37 meters above the ground? Why are you giving yourself this much height?
It makes no difference in their model. It makes no difference.
This is how much.
So but why can't he show us what it looks like from? I gave him 2 meters tall with a 5-meter pole. Okay, so if it's 37 meters, can you go a little bit further and show us what it would look like from 2 meters? Could you do that?
You seriously fucking whinging about 20 meters?
Yes. I'll tell you why. Because that's what we see with our own eyes.
You know what happens if you fall from 20 meters? You know what happens if you fall from 20 meters?
Their build is much higher than 20.
No, we're not talking about buildings. Shut the fuck up,
guys.
Bacon.
On their model, it doesn't matter how high you are, guys. It doesn't matter. The stars follow you up, and so does the sun. It follows you
but it's not about what matters. It's not about what matters. We're trying to establish something here. Like I know what you're saying, bro. I hear you, bro. It doesn't matter. They're gonna. I know. They're gonna change it. But for the sake of the argument, can we get specific and go to that ground level, please?
I already said
we're 25 meters up. Just fucking deal with it.
25 meters up is not ground level. It's not ground level.
Dude, 25 meters is not a fucking person standing on the ground.
Hold on. Aren't there places on the planet where the elevation is greater than 25 meters up? So isn't this technically valid?
No, it's not at all. It's not at
Places
all.
where the elevation is higher, though, so it is valid.
They can just go to a shoreline, Bacon.
I mean, for the most part, I guess.
They can go to a shoreline and do street view, man.
But
okay.
This is such a.
Let me tell you something. Let me tell you something.
You weren't listening and didn't understand. That's what we're doing.
Hold on, you guys. You guys
Again-
gotta try to go. Hold up. You guys got to go one at a time. Remember, there's people listening, so if you're all talking at the same time, it's hard to hear what's being said. And then Arma, you had that mic thing again. You had that loud crackle thing in your mic.
Yeah, and again, they're back to what they were doing with the other screen, where they're saying,
Gio, they're misrepresenting the true height of what.
Yeah, but dude, he's in Hawaii, and there's nothing pointing south that low in Hawaii.
What?
He can't go. He'd have to go like to the water. Which I
Yeah,
don't know why
exactly.
you don't just do.
Go to the
Go to the
ocean
water.
line. Yeah, exactly.
Yeah.
Go all the way down. Not 100
Thank
kilometers
you.
up.
There we go. So there we go. Now we're at what? 2 meters. Camera height 27 meters.
Yeah, it's still 25 meters again. I mean,
Okay, now look. Now look at what you see when you're 2 meters above the ground.
I'm 25 meters. I can't get.
Okay,
closer.
again, you don't. Okay, so me and you. Oh, fucking hell. So me and you know that when you're standing on the ground, you don't see this much area, right?
Exactly.
You can draw a line right now. You can draw a line right now from that point, like
it's an airplane.
From the screen where the water is. You can fuck, man, what don't you get about it?
Look how high he is. Look how fucking high he is. That's not fucking relative to a fucking person standing on the ground, bro. Like,
He's not at the ground. He can't show us at the ground because I don't think Google Earth even allows you to be directly on the ground. Actually, you can go to Street View. Go to Street View, please.
You can go to the ground.
Point of all this. This is going to show us that you weren't listening when Bacon constructed his sphere. This is what it's going to show, right?
This is fucking bullshit, bro. At this point, you're a fucking airplane. Okay, go down to the fucking ground, overlooking the fucking beautiful oceans of a resort, and then fucking try to say that you can see through the earth, bro. You guys are so fucking full of it.
Closer than this.
Yeah, it literally won't let you get any closer. I'm like doing it right now.
Exactly, because your model is not going to allow you.
No, that's not why.
No, your model won't allow you because it's going to fucking it's going to throw your whole theory out the window. That's why.
Maybe that is as low as it'll let you get. Maybe.
Yeah.
Okay. All right.
There's
now.
something called. Oh no.
Okay. Now.
Guys, can you guys go?
Now you wait.
Guys,
hold on.
They're fucking full of
Can
shit.
you guys please go one at a time so we can hear what's being said? Just let one person go at a time, please.
Yeah, I'm actually following the.
No. It was my turn, dude. You interrupted me.
No,
There's something
I
called
didn't.
Yes, you did. When you're dealing with rendering, you have to establish a closest distance you can see and the furthest distance you can see, and you will only render. You will only render within that range.
No one's following
Google Earth,
the
they established.
Bacon.
So Google Earth established that range to be apparently at 25 meters. So if I get any closer, I would be seen inside of the Earth, just like what happened in Blender.
Let me address something, please. Okay, so I'm trying to actually follow the original point, which was seeing the Southern Cross from Hawaii. Now, it had to go into this because you were saying that that's what you see from ground level on your screen, Bacon, previous to this. Now, you're obviously looking at the ground here. We're talking about seeing, Southern Cross in the sky from Hawaii.
Okay.
It's fine.
Which is fine. It would still be 5 degrees above the horizon.
But Bacon, you cannot position this fictitious fucking angle because you are not representing somebody on the fucking ground. You are literally an airplane right now. That's not what we're talking about.
25 meters above the
25 meters.
The airplane is way up the fucking sky.
I'm just a building, dude. I'm just a building. And actually, in Hawaii, you have mountains.
What building is fucking 30,000 feet in the air, bro? What fucking building are you talking about?
I'm 25 meters. I'm 25 meters above the ground. What the fuck are you talking about, dude?
Oh, 25 meters. Okay. So tell me, what fucking human being with their own eyes is 25 meters above the ground, bro? Tell me
Near a
that.
building.
One that lives in an apartment.
floor
One
building.
that lives in an apartment.
No,
So you're,
no,
okay, all right, no,
dude.
let him go with that Apocryphon. But Apocryphon, let him go with that. And so what you're saying is, you can see the Southern Cross from Hawaii from apartment buildings that are 30 meters tall.
No, you can see it from the
Probably
ground.
can see from the beach. If you're in
Okay, so if you can see it from the ground, show us from the ground.
We can't get to the ground.
Okay, so you
There's a
can't show
minimum
us.
of
So you can't
25.
show us, Ruhif. Okay,
There's
so
a
thank
minimum
you.
of 25 meters.
Okay, so hold on a sec, please, because we brought in Google Earth because you said that Bacon's screen before was ground level. Now you're conceding that you can't show us from ground level.
The Google Earth map that he was showing can't get lower than 25 meters.
Oh
His
my
modeling
God,
in
bro.
Blender, his modeling in Blender can.
Please let me say this. Please let me say this. Please. You're saying that Google Earth cannot get lower than 25 meters. Do you understand
Not the
Google has
browser one.
street view? Do you understand Google has street view down to the friggin' you can be out the front door?
Exactly.
Yeah, but we don't have this in Hawaii.
Exactly. Dude, these guys are
Those are
so
pictures, a
fucking
car.
dude. They're so
That's not the model.
disingenuous. They're so disingenuous. Honestly, they're so disingenuous.
And you're
Because if
fucking
you were,
retarded, Apocryphon.
I'll
You're a
tell you
fucking
what, Ruhif.
retard.
I'll tell you,
Okay,
Ruhif.
Jeremy, hold on a sec. I got a message about saying idiot. He's just calling Apocryphon a fucking retard. So is he going to get pulled up?
If he's going to call me disingenuous, I'm going to call him a retard.
Is he gonna get
right?
pulled
And then
up for that?
And then we'll see how fair the moderation is.
I'll
Don't
tell
call
you
me
why.
disingenuous,
Hold
or I'll
on.
call you a
I'll
retard.
tell Ruhif.
You're being
Ruhif.
disingenuous.
No, you're being a
Ruhif, I'll
fucking
tell you
retard.
why, Ruhif. I'll tell you why you're disingenuous because you are
You're being
trying
a
to
fucking
equate.
retard. You're fucking
Hold on.
retarded, Apocryphon.
Hold on.
You're fucking
Hold
retarded.
on.
So double standards in this server. Yep.
No,
Hold
don't
on.
call me disingenuous, or I'll call you a retard.
I'll tell you what. You are trying to equate.
You guys, come on, guys, stop with all this, please.
Geo,
I'm happy to. Absolutely.
Geo, real quick.
Yeah,
They're
Apocryphon,
trying-
you start. Yeah, just don't do that, dude. Just say your point. There's no reason. Just
Okay,
to
okay.
start
I'll say my point. I'll say my point. You can. I'll say my point. You cannot. I'll say my point. You cannot equate 25. Was it feet in the air to represent a human being on the floor? That is so disingenuous because that is not even capable mathematically. If you want to mathematically, Ruhif, if you want to take a person standing on the ground and then you want to say that, well, we can take a mathematical, global program to make me, 2,500 feet above the ground. That is not the same as a person standing on the ground. That's why I said you're being disingenuous because that is not accurate. That's not right. That's not true. That is not the truth. And you only have to equate the 100 feet in the air to make your argument stand a point. But that totally negates what we're trying to point out. What don't you
25
understand?
meters, Apocryphon. 25 meters is like 75 feet.
Oh, even still,
it's still not ground level.
Oh,
jeez. 75 feet
It's
in
still
the
not
air.
though.
75 feet in the air is not the same as 6 feet in the air. Bottom line.
Yeah. And so Ruhib, can you, because you're the one that keeps like trying to defend this whole being high, would you agree that like 75 feet above the ground is not being at ground level? Would you agree?
Of course it is. I also agree that it makes fuck all difference.
So that's a contradiction. You can't say it is when you're saying so. All right. So for example, no, hold on a sec. No one's ever. Yeah, listen. So I'm standing on the ground right now. I'm standing on the ground. Now, if you measured me from the ground and took that ground from, am I 75 feet in the air? Yes or no?
No, of course not.
Thank you.
Okay. I guess that's a win for you, is it?
But aren't there places on the Earth where the elevation's higher, like naturally? Like, 75 feet. I feel like it's not.
Hawaii has a fucking mountain.
nothing.
We can go hundreds of meters above sea level. There's an observatory on the top of it. So
Yeah.
Obviously,
My point is that
So your
75 feet
argument,
is
so
not.
your argument stemmed into just the fact that elevation is taken from sea level, and now you're saying there's certain points. Can we get specific, and can we talk about exactly where you can see the Southern Cross from Hawaii, whether it's on a mountain, whether it's on the ground, or whether it's in an apartment, or whatever you're trying to say? Can we get specific?
On the beach. On the beach, yes. 0 meters above sea level, you can see it, yes.
You can see as you've seen on my picture.
So you're 0 meters above the sea level, which is not 75 feet.
Right.
75 feet too. You could do 75 feet. You could do 0. I mean, climbing both.
Well, no, well, we're not talking about. So, okay, like he just said, right? When you're on the beach and you're 0 meters above sea level, you're not 75 feet. Okay,
Exactly.
It's 0 meters.
Okay, listen. This is. I think
You're 6 foot at the max. You're 6 foot, 7 foot at the maximum.
You're gonna see the
lay
same
down
star.
on the beach.
Doesn't matter if you get a couple of
Nah,
tens of meters
you
higher
guys.
or lower.
There's
That doesn't change.
incongruity. Hey,
I was in the middle of my sentence. Okay, go on.
The incongruity going out. I can't even fucking talk right now. I'm so drunk. But listen,
obviously,
but you guys are stating.
Yeah, I'm not drunk.
You guys are stating that from ground level of a human being to see a star, they cannot see the Southern Cross in your model. But the fact that they do see it, it just negates your model. Why you guys argue that is simply because you cannot accept the fact that this is even a possibility because it destroys your ball model. And that's
how is
fair.
this taking so long?
I just wish that you guys I just wish that you guys had half the heart to accept your reality without introducing your incredulity and not believing it, because this is reality. The reality is if I'm standing on the shorelines of fucking Hawaii and I can see these stars that you guys claim that are beyond the equator of the ball earth you believe in, then you guys are simply just hand waving the fact that you shouldn't be able to see it. Bottom line.
Okay. All right. Okay.
Honestly, I'll just go to bed.
Yeah, no, but Ruhif, now, like, all this got brought up because you said that Bacon was going to show us on his screen. Would it be fair to say now that you can't show us on the screen?
Can't show what on the screen?
What we were originally talking about, which was the reason Bacon opened up that computer software and started saying you could show us what it would look like. We've already, now at this point, we've sort of established that you actually can't show us on the screen because you don't have the ability to do so.
When you say show you on the screen, show you what? Like, what am I?
See, so you've forgotten what? So, all right. So have you forgotten what we were talking about in the beginning?
I can't get
or you're just doing circular rhetorical questions, and you're just going to ask me a question every time I ask you one.
Right. So what are you expecting me to show? Is it left to right curvature?
What we were even talking. No, it had nothing to do with curvature. Is what we were talking about in the beginning. It was talking about what. So again, hold on a sec. You're asking me, so let me answer. In the beginning, I asked you if you want to show me on a basketball with little toy soldiers, do so. You guys wanted to do it in drawing. You even said, I said it sarcastically, but you said, yeah, I can show you on Microsoft Paint, right? So what I asked for, and this is what I asked for, if you can't do it, just say what you're asking for is not reasonable, okay? Say that. So what I asked for was showing me the Southern Cross, the hypothetical in the sky, showing the ball, showing me in Australia upside down, showing the person in Hawaii, show me them, which way they have to be looking at Southern Cross, show me their head, their angle, everything like that. Like, show me that. If you can't show me that, then just say so. You didn't say that. You went on to say, we can show you in Bacon's screen. Then we had an issue because on Bacon's screen, it did not look like what you see from ground level. So we invoked Google Earth. Then we got to Google Earth.
To see from ground level? This is my point. What are you expecting to see in Google Earth that is different to what Bacon showed? Is it?
Well, it was different.
Curvature?
Wait, no, you keep hold on a sec. You keep trying to make it about left and right curvature. It has nothing to do with it. Please stop repeating it. It has nothing to do with left and right curvature.
What's different about it? What is different about it?
You're not listening. Because you're not listening. Hold on a sec. When on Bacon's screen, what he was showing us was claimed to be what you would see at ground level. When we went to Google Earth, it's not what you see at ground level.
Exactly. What is the difference?
Well, the difference being, when you're at ground level, you don't see you don't have a bird's eye view from ground level. Put it that way.
Right. Where are we seeing
what you were showing us? So what you were showing us was a bird's eye view, not a ground level view. It's a bird's eye view.
Exactly.
Sorry, in Bacon's blender, are you saying that's a bird's eye view?
At the end of the day, it's fucking bullshit that we are even fucking arguing this, because they are just fucking hand waving the fact that at Google Earth's fucking perception, when you are on the ground, mind you, a human being on the ground, you are having to literally look through the dirt of the curvature of the Earth to see your so-called fucking position that you claim. God
Seriously,
damn.
go to bed. Just go to bed. So
How
but this is how.
The camera
Yeah, but that's what happens, right? Everyone forgets.
I'm speaking. The camera is at the surface, and it's pointing at the star. How is this bird eye view? It's pointing horizontally. It's pointing along
No,
the
it's
surface.
not though. It's not though. Bacon, stop lying. Stop fucking lying, because that's obviously way above. Because nobody can see the view that you're pointing out in your fucking. Anybody on the fucking beach shore will never see what you're fucking explaining on your fucking CGI fucking computer generated fucking model ball, bro. Get the fuck out of here, dog. For real.
And this is the point. This is the point. All right, if you follow the argument, it's seeing what. So the people that see Southern Cross from Hawaii are standing on the ground. So therefore, you have to show what it would look like from the ground, not from this angle, not from that angle, or this height, or whatever. You have to show it from the ground, because that's the only point that it is seen, man.
Exactly.
That's
exactly.
You're just completely pulling out of your ass that this is not from the ground, because
there we go.
It's not from the ground.
Hold on.
It's not.
Hold on. This is flawed. Hold on. This is flawed, because if we're gonna say
how long we've been on this point, like everybody should just like take a moment of reflection right now and acknowledge the half an hour we spent talking about the difference between. Yeah, I mean. And what are you doing? Does anyone give a shit at all anymore?
I do.
You know who your opponent is.
Yeah. All bullshit.
That.
You're right. You're right.
Yes, I do know my opponent is. It's fucking.
Yeah, drunk.
Yeah, your opponent just spanked you. That's who your opponent is.
No, your opponent. No, you guys didn't do jack shit. You guys are just talking.
Yes, I did.
Words.
Denial. Fucking talking out the side of your neck, bro. To say that you're gonna get
names around. Let's do some name calling, you bitches.
No one called a name.
I did it in Blender too. I actually did it in Blender too.
I'm just kidding.
I did it in Blender too.
Yeah, but I'm down for that.
Hold on, I did it.
My point still stands, y'all.
Hold on, I did it in Blender too. All right. If you guys want to see that as well, all right. Not to take the spotlight off of Bacon, but I did it in Blender as well. I have little cross, little Southern Cross. I mean, it's not like a Southern Cross; it's like a legitimate, like perfect, like
Now I got to switch phones. Hold up, I'll be back.
But I did do my own, and it is what is it like? I did like 60 something. Let me see. I did 60 degrees at the center, but the lowest point is like a 63. So I can prove that actually.
But how high are you though?
I'm literally clipping through the ground.
Apocryphon, no one here is higher than you.
So tell me though. Tell me, Arma. Tell me, Arma. In what reality are you a human being on the seashore, fucking beach? Where do you fucking represent that you can see 70 miles up in the air? Or I'm sorry, 5 miles up in the air. Tell me, bro. Like, you are representing a falsehood.
I know. I'm in the ground. I'm not in the air. I'm in the ground. I'm literally clipping through the ground.
That's a good point. You're clipping through the ground. So you're saying that you can see through the ball earth that you believe in.
No, I'm not
seeing through the dirt.
No. I'm not seeing through the earth. All right, the sky is where the sky is. All right, I will be seeing right now if I look down. All right, I can see the inside. I'm not looking through the earth to see the cross though. That's a moot point. You're muddying the fucking like.
Arma.
What's up, bro?
Arma, it's so easy, bro. Arma, it's so easy. Put the fucking whole model of your whole graphic as a basketball. Okay, it's so easy. If you are above the medium of that basketball, you will never see the bottom of the basketball. Put that in your mind frame, bro.
Okay.
Put that in your fucking intelligence right now.
But look at my video. Look at my stream though. I could see the Southern Cross though, right? Look, I'm even proving that this is it's
but you're
roughly the right
hovering
size.
way above the fucking.
I'm not. I told you I'm in the ground. I'm in the ground. I'm not hovering. I'm literally in the ground. You keep saying I'm hovering. I'm
you're
not
looking to the ground.
Hovering. I'm in the ground. I'm not looking through the ground. I'm in the ground, but I'm not looking through it though. The sky is the sky. The ground is the ground. All right. I can literally look. If I look around, right? Yes, I can see the inside of the earth, right? But literally, I'm still looking above. There's still sky though. Okay. There's still sky.
You just said you can see the fucking inside of the earth. Come on, bro.
Yeah,
Are you
I can see the inside of the earth, but I'm saying I can still see the sky. Like, this is still sky, right? Can you not see the sky? Look, in fact, I can even color code it for you if you want. All right, I can make it fucking blue. All right. Give me a second.
How about I do this in fucking Pogray?
Jesus.
You can see it, right? You can see it. Come on.
It'll work better because there's
What's
no.
the fucking point in all this, bro? The elevation doesn't even matter. What's the point in all this?
Look. We got the stars too in the background. See this nice stars? Look how beautiful the stars are. Look, we got the ground. All right, check it out. All right, I'm on the earth. All right, and there's the Southern Cross. It is above fucking the horizon. Like. This shouldn't even be an argument. Like the fact you can literally just do the math, all right? Like we see roughly, 180 degrees of sky, okay? It goes without saying that the Southern Cross is going to be within that 180 degrees if we're like 19. If our latitude is like 19 degrees or whatever, no, not 19 degrees. Well, if our latitude is 19, all right, it just do the math. It fits in it. Like it you guys are ridiculous.
Dude, you're fucking so full of it, dude. You're literally taking a program.
I think you're full of it.
You're literally taking a program that's fucking. You have to understand this. Your program is based upon a falsehood because you are then invoking this whole fucking spherical Earth that doesn't even exist, but you are saying that I'm on the ground. And I could see the fucking Southern Cross. No, you should not be able to see it, bro.
Yes, you should. What math have you done to prove that you shouldn't be able to see it? We're literally telling you should see it. All right, we've done the math. We've even done it in Blender. We're modeling it out.
To the math.
Yeah.
Would we all agree that everyone's feeling a mutual feeling of disconnect from their opponent?
Maybe, I don't know.
You think you're seeing eye to eye?
Yeah, no, we're not seeing eye to eye. You're right.
There's no reason on their model you wouldn't see it.
Both sides are seeing eye to eye. I mean,
you're right. Okay, what do you want to cook? Jeez, man, what do you want?
Can Brian speak up to Apocryphon and upside down?
Hey, Arma. What elevation are you looking at right now?
The elevation, like probably negative something. I'm in the ground right now. I'm not looking through it, but I'm in the ground.
It doesn't look like you're in the ground. I'm watching your stream. It doesn't look like you're in the ground, bro. It looks like you're fucking way high, bro.
Oh my fucking goodness, man. Look, I'll show you. Look, I'm gonna zoom in. Hold on. This is ridiculous.
I want to ask.
I'll show you my camera. Hold on. Let's see. My camera is right here, and where is it? Right here in Hawaii. All right. If I actually go to it though, it's actually inside. All right. The point where it actually is inside the earth.
Go to Street View.
There's no Street View. This is Blender.
Yeah, exactly. Bro, you have a fucking program that's going to fucking validate your falsehoods. Do you understand that, bro?
No, I made this. This isn't a program. I mean, the Blender's a program, but I literally made this model, all right, and I put it together. Like this is literally.
I'm watching your stream. You're not fucking on ground level. I'm watching your stream.
This is progress from the initial Arma's Blender skills. This is progress.
me progress. My Blender skills are fucking amazing. All right, I literally have so much shit.
Go to ground level, bro. Go to ground level. I'm watching. I'm watching.
I literally
witnessing
I actually predicted moon phases on this. It was fucking crazy, all right? But I'm not gonna. We'll
I'm
get to that later,
witnessing
though.
it, bro. Fuck your moon phases. I'm witnessing your fucking zooming in, bro. Just go to the fucking ground.
I was at ground. Look, see, you see this? It's literally inside the ground. In fact, all right. That's how fucking ground level this is.
No, it's not. It's not though. It's not. You're still fucking hovering above it.
It's
If
not
you
hovering.
can
Why do
see
you
the
see
ground below you,
it's not fucking hovering. I'm talking
If
about
you're fucking- if you can see the-
yeah. But this camera, I'm pointing to the fucking camera. The camera right here, this little orangey dandelion color. This is the camera, right? I'm trying to show you that this point right here, though. Right? Yes, I right now am hovering, but the fucking camera isn't though. The camera, this orange fucking thing right here, that is in the fucking ground, man. All right, this right here, all right, is in the fucking ground. Do you see that? It's in the ground. I can literally see it on the other side. It's in the ground, right? So I'm gonna go in it now. See, I'm fucking in the ground. All right.
I like the sound effects.
Yeah, I like it too. That's why I added. But look, I'm in the ground. All right. And look, the Southern Cross is still visible, man. You see that? That's the Southern Cross right there.
How high are you in that? You're in the ground.
You're gonna complain that doesn't look like a Southern Cross.
Here, I'll make it more Southern Crossy. Oh, I can't. Never mind. I fused the two. Yeah, whatever.
It's Southern Crux. It's CRUX. It's not.
Well, it's a cross now on mine. All right, mine is a Southern Cross. Okay. I like. I like my Southern Cross.
Can I tell you something?
Hold on. There you go. Wait, is it a cross? Hold on. Yes, closer to that actually, but
yeah,
it's a little lopsided. It has to be like. Hold on. Yeah, it has to be like.
Crux means cross, dude.
Yeah, there you go. See, look. I'll just rotate a little bit. See, like, that's how it looks like. It's like that.
I want to ask something.
Can you click on the camera?
No, I know, but the astronomical name for it is Crux.
Yeah.
Did you just put the random location, or is that where it's actually?
Yeah,
I actually put the.
Arma, I'm gonna say it right now. You look fucking pretty high because a person is not gonna see what you fucking represented. Your eyes on the seashore in Hawaii is not gonna see that much fucking curvature and that much fucking like landmass. You're not or fucking ocean. Everything you're just representing is a fucking computer generated fucking mathematical algorithm, whatever the fuck you want to call it. That is not reality. That is literally a fucking CGI represented fucking calculated ball Earth.
All right, then what do you have to show? What do you have to?
And guess what, Arma?
Arma,
guess
what
what?
do you have to make? What do you have to make your point that on a globe you wouldn't be able to see the Southern Crux from there? What calculations or data do you have that would counter this?
It's real simple, Gio. It's real simple. If you have the equator, okay, and you're on the north side of their ball Earth equator, then you cannot see the bottom of the basketball round Earth that they live on.
The Southern Crux is not
on the bottom.
The Southern Crux is not at the bottom. It's off of center. It's significantly off of center of the southern pole rotation.
So, can you demonstrate that, please?
I want to do a screen share that I might think would be of value.
Look at this. Look at this.
The declination is 63 degrees. It's 63.5 degrees. So yeah,
see
it's
that?
definitely off the center.
Yeah.
So.
So in other words, if you're at the equator, you're going to see it at about 26 or 27 degrees above the horizon. So you would be able to see it in Hawaii, but my point still stands. I'm at 28 degrees, a little above it, and I can see that bitch.
Can you see like all of it, like even the entire thing, or is one of the stars like missing?
Yeah, I can see it sitting on just a little bit above the horizon, just barely above the horizon. Like not really all of it, but I mean damn near all of it.
What's your? I mean, there might be a few factors there. I don't want to jump to refraction yet, but there could be a few factors.
Horizon, like if I could see all the way down to the horizon, I would be able to see all of it.
Probably not. You're right.
Can you take a model it in Hovray, which has perfect spheres?
You gotta take a picture of that and check your GPS if you're actually at the latitude you think you are.
Well, I mean, hold on. Let me see. You mean whatever him, not me? Okay, my bad. You mean him? Okay, my bad. But yeah, check. Yeah, get your latitude, man. Brian, man. All right, but anyway, yeah. But mine is all set up. As you can see, I actually set up the camera at 19.89. All right, degrees latitude. As you can see, that's exactly.
All right. So, what does your program here show if you move it to Brian's location?
Oh yeah, let's do that real fast. Okay, so if I do, what was it again? He said 28.
28 and a half.
28 and a half. So what we would see here is a little bit of that tip actually. Hold on. Ooh. Let me see.
Just the tip.
It is, but it could also be. Let me real fast see if I got it 100% though, because I do have to make sure. Like, if I rotate it a bit. Let me see. Yeah, you do get a little bit of it. Let me see.
So would the actual location of the Southern Cross be important, like in your little computer image there?
Wait, hold on. Let me make sure I also got the exact position, this exact thing too.
Yeah, keep talking. So do you just place it wherever you like, or is it like a specific distance?
Hold on.
5 million kilometers away.
Okay, hold on a sec. Stop. Does where you place the Southern Cross on your computer image that you have right, does the actual location of that Southern Cross matter, or do you just get to place it wherever you like and then say, yeah, you can see it from here?
No, I mean, it's pretty close. I don't know if I have it like 100%, but it's pretty close. Like I have the center of it around 60-ish, but I might have to tweak some of the stars. So let me see. I have, because technically 2 of the stars. Yeah, let me see. So
I think it's even higher than that from the bottom of the very bottom of Y. Because from the bottom of Y is 18, 18 degrees north.
You need to put that Southern Cross exactly where it's supposed to be. And then you also need to just tell us how it's supposed to be there. Like the exact distance
is 63.23, right?
63. Wait, hold on. Can I get like the exact like things for each star or whatever? Like, okay, well, actually, give me the top one. Actually, what's the top one? The most northern.
A crux is 63.2 degrees declination.
The most north. No, the most north is
I got 63.5, Ruif.
57.
Hey, Arma.
57.
You might be going off old.
This is exactly 57. Like 57 what though? Like 50 is.
Okay, let me convert this arc minutes into degrees. 0.2. It's around
57.2 ish. Okay, yeah, so that's still a lot. Yeah, in fact, you probably really won't see any of that actually. In fact, if I'm gonna be truthful, let me see. Although yeah, so let's try that for now. That is actually below. Now it could be off, yeah, or a bunch of other numbers be off. Let me real fast see.
It could be off, yeah. Okay.
It
Arma
definitely did something wrong because I did the same thing and I got the whole thing above the horizon a couple degrees.
Hey, Arma.
28. Hold on, 28. Give me a second. Hold on, 28. That would be. Actually, do the math real fast. Let me first do the math and see what.
Put on the center first.
Hold on, wait, hold on.
Can you go to the north view? North pole
view? Sure. Give me a second. With my camera.
While y'all work that out, I wanted to point out that when you're looking at Stellarium and they're showing like the Southern Cross and all this stuff, and we're looking south, like say at the tip of South America, like when I'm looking in Stellarium and I look dead south, like I can see part of the E and the W. So that little circle that y'all making out to be some tight little circle, that represents 180 degrees in my vision, dude. Like that's what I see if I look due east and then due west. That's 180 degrees. That ain't just some tight little circle y'all are acting like it is, 62.
Yeah, actually, you know what?
But here's the problem though. Hold on. Here's
that should be visible. I might have made a mistake because technically, 28 and then 6. Yeah, minus 90. Yeah, you should in theory be able to see it. Yeah, 63.
But here's the problem though. We are literally arguing. Hold on. Here's the problem. We're literally arguing.
Oh, I know why.
Wait, hold up. Can you hear me?
Sorry.
Can you hear me? We are literally arguing a ball against a ball because you guys are using Stellarium that's all based upon a ball and all the math about it, but that is not reality. So we are arguing against your reality of what you're trying to proclaim. So you're using the ball math to prove
they're defending their model, bro. I mean, the claim was it wouldn't work on their model, so they're defending their model.
I know.
The issue.
But yet, they can show you using their model. They can defend that argument using their ball model, and that's the whole fucking point. That's the whole point. We're telling them,
hey, can I get
no,
in real
you
quick?
can't do this, but they're going to use the ball to
If they
explain
can show it on their ball model, then I'll drop it as an argument. You know what I'm saying?
Hold on, real fast. I figured out the issue though. I had it too local. That's why I just realized because look, this is what I had it originally. Right, I had it over like this, right? But that was local. See how local that is? If I actually bring it out further, hold on. Oh, I want to do that. Hold on.
Now we're puppet vision. Okay, yeah.
No. If I bring out further, check it out. If I bring out further, now I get to see more of it though. So I think most of it was mainly because I had it. Whatever. Let me see.
See how big I made mine?
Wait, where's yours?
If I can see more of it. If I just move it, yeah.
No, I'm saying because it was local originally. That's why it needs to be. Remember, in our model, it's like they're effectively infinitely far away.
Yeah,
you'll have to put it at light years, or else it doesn't count.
Exactly.
Hey, can I ask Bacon or Arma one question? If they could model this on their
you're making the constellation bigger with it. You have to make the constellation smaller.
I've
modeled it in PobRay. And PobRay has perfect spheres.
Yeah.
Wait, let me see.
Hey, is there any way? Hold on, guys, real quick. I wanted to ask Arma or Bacon a question. Is there any way you can model a sphere and then place the Southern Cross, like a faraway view? And then the second one, if you could do that, what degrees is the Southern Cross at? And can you demonstrate that, like that, like a faraway view? Yes. Now, where would it be?
Hold on, I'm trying to still fix
this.
No,
exactly
what
I
real
was
quick.
doing.
Back out.
That's exactly
well, no,
I'm
busy doing something else right now. No, another time, man. I'm trying to do this. Give me a second. I'm trying to figure this out.
This is what I asked for like a long time ago in this conversation. It said, does the actual distance to the Southern Cross matter, or do you just get to place it wherever you want?
If you make it farther and further and further,
he's kind of placing it wherever he wants a little bit. He's kind of adjusting.
Do you want an answer?
Yeah,
yeah.
He's trying to make up for he's making up for the discrepancies of the extra
there's no discrepancy. I literally had it local. If it's local, then yeah, that goes without saying. But if you actually bring it out to its proper, distance, then yeah, the math actually checks out.
No, Arma, no. You can't just say, "Let me fucking bring it out to its fucking."
Because it needs to be effectively infinitely far away. That's how the model works. That's how it works. It needs to be really far away. Popcorn, if you don't like that, hold on, Popcorn. If you don't like that, then I'll answer with this. I actually had it way too close. All right, that is official. Or we know it's not like within moon distance. All right, that goes without saying.
No, bro. You cannot argue the ball with the ball. You cannot try to get in. That the angles we already said, bro, you cannot see the fucking bottom of the basketball from the fucking northern part of the basketball, bro. We already said it, bro. And you hold up.
All right, bro. You might be repeating yourself. Wait. You might be repeating yourself. Let's let Bacon go. Unless you were gonna say something, but go ahead.
I was gonna say this. If you want to zoom out from the position of a human being standing on the ground to make your point, then that is not the fucking point we're making, bro. You are literally taking what we're saying and then just hand waving it because you can zoom out way above a human being's fucking height and say it's possible. That is not fucking reality.
That's not what he did. He had it all the way down to the ground, at least on his model thing.
Okay. Can I ask one last time? Can you put the Southern Cross where it's actually supposed to be?
It is where it's supposed to be. It is, yes.
On this computer software, can you do that?
That is where as close as I can get as of right now. Because I'm sure I could.
What's the distance then? What's the distance?
What, the Southern Cross's distance from the Earth right now?
And you have to tell me which point of the Earth, because it's going to be different depending which point of the Earth you're on. So where you've got it now, it's how many kilometers, and you can do the conversion of light years bullshit, how many kilometers it is and from which point. I need you to tell me that.
Right now, it's probably What is it?
No, not probably. Not probably. You said you know. You said it's where it's at. So
it's close enough. It doesn't need to be exactly effectively infinitely far away. It's close enough. Because look, I'll show you right now. Look, I'll show you right now because this is actually a fucking stupid argument. And I'll show you why it's a stupid argument.
I have a distance for mine.
Well, hold on. Before you do yours, though, real fast, Bacon. So I'm gonna real fast scale this. All right, I'm gonna scale this. Right, 10 times. All right, nothing changed. All right, I'm gonna scale this 100. Oh, now it's actually clipping out. Now it's literally too far away. But if I literally scale this two times.
All right, so you go further and it disappears. Now that's a problem.
No, it's because it's a clipping thing. It's a program thing. For fuck's sake, you guys.
Exactly.
Arma, you gotta.
What?
Exactly. Good point, Gio.
No, I'll make a comeback. Okay, hold on. I'll literally change the clipping. You guys literally understand programs.
Comeback.
No,
the ship is sinking a little bit.
It's not sink. Okay, look, there you go. Okay, it's a clipping, guys. Do you know what clipping is? All right, in a 3D program, right? There's a limit to how far the camera will look. Let me finish. All right, the camera has a limit to how far it'll draw stuff. All right, if an object is outside that draw distance, then it literally just doesn't draw it. All right, that's what fucking happened. Is you guys are like, oh no, I fixed it. All right, it's at its distance now. All right, nothing's changed.
So would it be fair to say from that, like you said, that it doesn't show it? Would it be fair to say that you can't show us on this computer software because the software doesn't allow it?
No, look, I literally have. Look, it doesn't matter how much farther I make it. It's literally staying the same. It's literally for us, it is effectively where it needs to be. Like literally making infinitely far away would not actually change its position.
How far? No, Arma. No, I'm not gonna let you get away with that. I'm not.
Yeah, can I make the point, please? Listen.
Don't understand, Matt. This is fucking sad.
I've asked the question. Does it matter where you put the Southern Cross? Does it matter? Okay, so that was my point because I feel like all you're doing is just putting the Southern Cross where you feel like it. Now, I've asked you to put it exactly where it's supposed to be.
It's farther than the sun right now. That is effectively infinitely far away. That is effectively in this scenario. That's good enough.
Right, you need to put it where it's.
How come our view isn't like a pixel size? You know how small a very tiny pixel is? Why are we seeing a giant like Earth when we should be seeing like super tiny? Like you see the little edge of Hawaii. It should if that's Hawaii.
We're literally inside the ground. We're seeing Hawaii from underground. We're literally under fucking ground. You see, I can see the rest of the Earth. I'm in the ground. I'm clipping through the ground. That's what's happening right now.
Why are you doing that?
Now
it's almost near impossible to get exactly on the surface. It's not that easy.
Arma. The white cross you have, now put it to where the Southern Cross in the distance of where it's supposed to be in your model. Put that fucking distance in your algorithm. Put it way far beyond because what you're showing right now is not.
It's sun distance. It's literally farther than the sun in my model right now. Okay, going any farther would be really hard for this fucking program to do. It literally fucking can't.
But to you, hold on, no. But to you, a Southern Cross. Hold on. Matter of fact, let me Google it and then I'll come back to you.
Yeah, it's the sun distance is good enough for that. You understand that, right? Literally, if I was to change this Southern Cross's position from the sun distance to what its actual position is, it literally would not change. Okay, a fucking pixel. Okay, it would probably change like a nanopixel. Okay, you're not going to get a difference. Literally,
how far is the Southern Cross?
Talking like light years.
Google it, dude. Okay, I'm Googling it. Another way of looking at is the top as 87.94 light years away. So Arma, put your fucking little fake ass fantasy diagram to represent the cross.
What is that thing called in math?
87 light years away. Go ahead. Thank you.
What's that thing? You know what that thing is called? I forgot what it's called in math though. But what is it called when like a number like is tending? Is it tending or trending? Yeah. Which one is it? When it tends towards like a number? It tends towards. We're literally tending towards fucking infinity already. All right. It doesn't matter if I actually brought it towards. If I did 87 light years whatever away, it would be literally the exact same position more or less. Okay. Maybe like give or take a nanopixel for fuck's sake.
See, the problem with this program is the problem with this program is we're looking at a large screen. The Southern Cross is 87 light years away, but it's huge. So the scale is off. Like,
No,
okay,
exactly.
the stars could be
The
tiny.
scale of the constellation isn't.
Dude, I'm literally talking, dude. Can I finish?
Can I respond when you get finished?
The stars are small, but they're still big in size compared to where you're at. But this screen is showing a large view of what we're trying to look at, but that's not what we see in reality. We have small eyes, and we can't resolve things that far in the distance. So
yeah, we can't resolve stars. We can't.
Look,
you're
you
right,
guys see this?
The Southern Cross is not a star; it's a constellation. Each star is unresolvable, and the angle between them, the angular size of the constellation, is actually accurate in his model.
It's like the pecker. It's like the pecker of Centauri.
Not the points that make up the drawing. Those points might be off, of course, because the stars are points. They're not like that big. But the size of the constellation itself, the drawing that those points form, is the same size. It's accurate there.
Yeah, you check this out. Look,
big dangling pecker of Centauri, man.
Hold on, check this out. Look, this is the constellation at one distance, right? This is at 100 distance, 1,000, 10. See how it's literally stopping? It's not moving anymore because it's literally tending towards that fucking infinity, distance. All right, we're good. We don't have to worry about it. Look at that. Look, 100, 1,000, 10,000. Literally, I don't need it to be at infinity. That's close enough. That is literally close enough for the sake of this argument.
The original argument.
If anything, infinity would actually help me out because it would actually be even higher. It would actually be higher than what it is right now. But by like what? Like by like. But like what?
The southern nutsack.
This is such a stupid argument because I'm literally giving you guys the benefit of the doubt.
It's not a stupid argument. Look, do you have your settings set to how far our eyes can see? Because our eyes can only see like 10 miles, right?
Oh my fucking goodness.
In the distance.
We don't have that's not a setting on Blender. You can't. I mean, if you want to do clipping, sure, but
you can't.
We don't hold on. We don't have a draw distance for our fucking eyes. It's not a video game.
Arma, you can increase the clipping distance.
I know, but we don't. But human eyes doesn't have a drawing distance. Though. I mean, making it seem like is that what I have to change? Like I'm not changing the drawing distance. That's stupid.
So then this model is inaccurate then because
you guys
that kind of model is not going to be the same from what we see on Earth. If we're trying to view, if we could see it from Hawaii, which is the case, it's what you're trying to model on this program is not accurate because it's not to scale. It's not taking into factor how our eyes see.
I can't. It is definitely.
That's not how that. Hold on.
Okay, explain
this is
it then.
The model, all right? We don't go by that, all right?
Give us the parameters you're using and make that coincide with what our eyes can see, like what our parameters of our eyes are.
On the ball.
And if you match that up and you show me and you say, look, here's the distances, here's the test we did for our eyes to know all the distances and factors. And if you could show me that, okay, I'll believe you. But until then, you're just modeling and form fitting and crunching the data to make it fit your model. That's
okay. We get the point.
Yeah, I just want to say something real quick to Arm. Real quick, I haven't said anything. Arm, first of all, this is fantastic. This is beautiful. Holy shit, good job. I can't believe you're doing this. But if you're interested in a more accurate model that does actually go light years, and might be more effective for convincing people, try Space Engine. It's only like $20 in Steam. And it's super good. Like that shit is a model of the universe in perfect manner.
Nickname Narnia.
Okay, yeah, exactly. I can't stand
Richard.
I can't stand when somebody is trying to justify the fact that you can see through a basketball. I can't stand that.
We're not saying that.
Honestly,
no, you are.
I'm actually wasting my time right now. I have
your whole model of this. Listen. This program that you're representing to see a certain cross in the sky.
Yeah.
This whole thing, you're negating the fact that
we are seeing through a basketball physical property, and we can see its southern part of the basketball. So if you want to,
APOC, listen, APOC, they're starting off on the equator. They're starting off with the southern, like the southern center at their feet. In other words, they're not placing it above the center of their ball. They're placing it everywhere around the equator. So you got to think in terms like that because it's so far away, bro. It's just how their model works. I don't agree with it, but
yeah, exactly. Which is retarded. It's totally retarded because nobody in the time of fucking history of mankind can see through a hill. Nobody can do that.
No one's saying that, you freak.
Can we have a couple of flat earthers to tell Apocryphon that this is not a problem for the globe?
Well, he
keeps a couple times, bro.
the,
I done told him
Yeah,
for the globe model. For the globe model, we would see it from Hawaii, bro. Absolutely would.
Answer, Richard.
Yeah.
Right, so Blender.
The basketball analogy is not analogous because a basketball is what, 2 feet in diameter or 1 foot in diameter. So that means you're viewing, you would be like the size of a speck of dust. So to model that would be you'd have to do the same thing. So you'd have to, like in this model that you're trying to do, you have to take the circumference or the diameter of the Earth.
Real quick,
Can I
real
finish,
quick. If you're at
please?
the equator,
Dude,
You guys, hold on a second. You guys, this is
please, man.
Yeah, somebody starts talking, and someone gets impatient and interrupts them, and then that person talks for 10 seconds, and then someone gets impatient and interrupts them. It's like interruption. Bacon was actually going to respond to Richard, and then Richard, you kind of interrupted him. So let's start with Bacon, and I think Brian wanted to get in. Please, guys, go one at a time, because otherwise it's really hard.
Yeah, all right, we'll get in line. Go ahead, Bacon. Sorry, man.
Dude, I was mid sentence.
Yeah, he was mid sentence, and you interrupted him, and then you got interrupted by Brian. So, anyways, Bacon, just go ahead, man, because Bacon's been trying to get in. He keeps getting over.
Then you interrupted me. No, I'm just kidding, dude. Go ahead, Bacon.
Fuck you, Brian. Okay, yeah, well, he was complaining about the configurations and the settings of the camera and so on. On Blender, it's simply a 50 millimeters rectilinear lens. We can just take a picture of the sky pointing in the same direction and compare with it. You can go to Stellarium and get it. It's not that complicated. It's not that. I mean, it's pretty easy. What you ask it for to compare. So
Bacon. Here's what I heard. We have computer programs that is going to justify the nonsensical claims that we can see something that in reality you shouldn't be able to see. But because you justify it according to a program, then all of a sudden that's reality. Am I wrong? Come on, man.
Yeah, it's only nonsensical to you.
Can I try and explain this to them? Because Gio put it good, man. Like, it's not in the center. So if we're looking at Crux, then the lowest star in Crux is if you're at the equator, it's like 23 degrees or so above the horizon. So of course we're going to see it into the north, but how far north is the question? If we want to get this argument right, we need to pin them up at about 28, 29 degrees or something, man, and show them proof that it has been seen. I think it's documented, but yeah, there's no problem of seeing it on their ball, bro, because like I said, if you're at the equator, would you agree you see Polaris at one horizon and where Polaris would be in the south on the other horizon? I mean, so it's way above the pole, like 23 degrees. So you'd see it. Yeah.
Hey, Brian, if you look at what I posted, they said that the bottom of it is approximately 232 light years away. Okay, so there's a huge discrepancy.
Oh, yeah, it's gotta be, bro. That's a given.
Yeah,
it comes with assumptions.
Yeah, exactly. So from 87 to 232 light years away. Like, come on, man. These guys are so. First of all, there's no such thing as that. There's no such thing as that light years away.
Yeah, I don't know. I agree with that. I could never agree with their shit completely, but
yeah.
As far as their model goes, you would see it from Hawaii without looking through the ground, bro. Just saying.
Exactly, bro. Bottom line. But these guys have programs and softwares and fucking computer animations to make you believe these falsehoods, and they don't get it. It's not what it is, bro.
Brian said you would see it.
No, but I can't get on board with the light year bullshit. But if I do assume that, I can make it work on the ball. But it comes with assumptions, is my point. But yeah, you wouldn't have to look through the ground if it were light years away. Let's say that, and we were in Hawaii. But much past that, we wouldn't see it. And there is a point where I think it's documented that it's been seen at like 29 degrees. And I can't see the whole thing. I can't see the whole thing, dude. I'm missing the bottom one, to be perfectly honest. But I can see like most of it. I can see most of it, but I'm at like 29 and a half actually, man.
Show us.
Here's what I see wrong with the model. What I see wrong with the model is it's not taking into account the average human size, which is 6 foot. Average, eye is like what, 1 or like 2 inches in diameter. And then plus you have to take the Earth, which there's going to be Earth curve in the way. So what we're looking at is just a flat line, a giant globe, but I don't see the globe doing any of the things that it's proposed to have. Like
mine?
Curves. Huh?
Wait, mine?
My model? How is any of them relevant though?
Because scale, the relevancy is the scale. Because
hold on.
we're looking at a. It's not the same view as like how you and I would view it. Somehow you're under the Earth or you're under the surface of the globe, which that's not like reality.
Exactly.
If you were the benefit. If you were higher or if your eyeballs were bigger, you wouldn't make the constellation go below the horizon or anything like that. Like that's
would
completely
make this program infinitely smaller. So it would be the same as how our eyes see it. Is what I'm saying.
If you make the whole thing bigger and the same ratio, nothing changes for the observer.
But Bacon, we're talking about reality, not a calculated global, program. That's not what we're talking about. We're talking about reality. So in reality, if you're looking at these lights in the sky, and you want to introduce this Solarium or Baker or whatever the fuck you want to introduce, that is not reality, bro. That is a simulated calculation, and that's our argument. So guess what? Honestly, Bacon, guess what? We can. I'll say it for everybody, bro. Flat earthers, guess what? We can't argue their motto because their motto makes sense to them. That's a fact. Their motto makes sense to them, and you cannot argue that. And I'm gonna fucking say it right now. We cannot argue the model. But our argument, model believers, is that your model is just a model and is fucking falsehoods, but you believe those falsehoods. We don't. Because it doesn't make sense. If you really, 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 really look into it, it doesn't make sense. That's it.
Can I point out one more thing real quick about Hawaii? Look at what we're looking at. This is supposedly Hawaii, right? The big island and the small little island of chain of islands.
It's not Hawaii.
No, keep it where you had it, dude. Why are you moving it?
Hold on.
Can you place it where you had it, please?
Wait, where
Can you put it where you had it before?
Hold on, I'll get to answer. Where's Brian though? Because he said 28, right? But like 28, at least from what I have, there is no land.
Okay, the view you had it before, which I was trying to finish the point, and then you kind of see. So can I finish my point, please? Okay, right there. What we're seeing is Hawaii, but we never see Hawaii like that. So why are you trying to model something that we would never see?
What are you talking about? I'm in the ground. I literally told you I'm in the ground.
What are you talking about?
The eyes, our eyes would have to be the size of Hawaii, dude. Or
no, they wouldn't. We're in the ground. I literally told you that.
Arma, there is land at 28, knucklehead, bro. All of Florida is between 24 and 30, bro.
Oh, okay. Oh, my bad. Because you know what? Because I thought we were keeping the longitude. That's why. My bad. You're right.
That's why I said he's on Florida, not in
my bad.
Anyway, I did look it up, bro, and I'm actually 29 and a half. And after Bacon told me to check it. And but yeah, like I said, I could still see. I mean, I know what I've seen. I've never seen the whole thing, but I feel like if I could see all the way down to the horizon, I might. It'd be close. I don't know.
Here, I'll change it to Florida. Ready?
Just rotate.
Hey, Arma, could you put it down to the horizon and make the view very small?
No,
like,
hold on.
make
29. I'm doing 29. I'm going to Florida. So first 29, and then I'm going to rotate. So Florida is here, right? Here we go. That's Florida, right?
Yeah, just go to like North Florida.
Well, yeah,
on the
that's 29. I'm not going any north than that. That's 29.
Yeah, that's fine. That's perfect. That's where I'm at.
All right, now I got to real fast rotate now the Earth because let me see where is it? I'm gonna do the day. Where's my southern crux? Where is it?
It's not visible.
Hold on, give me a second. Yeah, it's gonna take a bit. I gotta find it. Oh, there you go. So there it is. Look.
I think
now
it's
the
like
problem
at the bottom
with
of
what you
like
think
a
you're
ball
seeing
sack of
is
Centauri or
we would
something, man.
never see Florida that big, dude. Like, come on.
What are you talking about? Where are you seeing what?
Tiny eyes. You see how you think you're happy that you could see that
we
right
got a
there?
job, dude.
Like
Yeah.
we would never be looking at the Southern Cross like that. We are very, very small.
Who the fuck is floating above Florida like that, bro?
We're not floating. We're inside the fucking planet. Do you not see that? I'm inside the planet. I'm clipping through it.
You're not inside. No, your computer program's clipping at that. But when you set your look at dude, who the fuck can see Florida like that, bro? Look how high you are, bro.
No, we're low.
you
Guys,
guys-
I'm gonna say this one last fucking time. All right, we're in the ground. All right, we're literally clipping through the ground.
No, you're not. No, you're not. No, you're
I
not.
am. Look, I'm in the
Your
ground.
computer
I'm in the earth.
program
Do you see this? I'm in the fucking earth.
You
See this?
gotta
I'm
make
inside the
your
earth.
very
Concave
small.
earth. Concave
I think
earth.
what they
Concave
would
earth.
say, hold on, is that in this program, the land is not, it's like just there as the features. I don't think they're trying to say it's all to scale in terms of like the way the land actually is showing up on the surface. It's just there for the
dude.
sort of
Show
for
me
the
a McDonald's.
for the
Show me a
visual.
McDonald's right now, bro. Show me a McDonald's right now.
He's not representing reality.
Can we kick a Poképhone, please?
Can I have a second?
No, he's cool. We're just
Show me a McDonald's, bro.
We're
Look
all
how
a little
high he is,
heated,
bro.
man.
Look how high he is on the top of
I'm
the.
not high. I'm literally in the fucking ground. I'm just
big.
gonna tell you, I'm in the fucking
No,
ground.
you're not. No,
Look,
you're not,
No,
bro.
he's too big, dude.
No, I'm in.
His view is too big.
The concave
K-pop.
earth right now. You see this? I'm inside the
Okay,
earth.
that's like a helicopter view, bro. That's a helicopter
No, it's
view.
not.
bro.
Look, I'm in the fucking earth. How many times do I have to show you this? Look, I'm
No,
in the
you're
earth.
not.
What do you mean? I'm
Theo,
not?
I can
Yes, I fucking am. I'm inside the earth. Do you not see this?
Arma. Nobody is fucking standing at that position and can see land like that, bro. Nobody fucking can see the land like that.
I'm in the I'm in the ground. You absolute donuts.
You got to make your view smaller, Arma.
No, you
What's
don't.
the-
It doesn't matter the
smaller.
size. It matters about the field
This
of
is
view.
fucking
The field of view
retarded.
is what matters.
It's retarded. It's
I'm
retarded.
gonna throw you, all right,
Besides what we're
I'm gonna
doing,
throw you
dude.
to the
Come on.
fucking ice wall.
You're not
all right?
representing reality if you don't make your view smaller.
Okay, Arma.
Armatter, if your NVIDIA driver is lower than if it's lower than 400 something, I'll get you the exact number. You can install the free version of Space Engine.
Can anybody
check your driver?
Now
if
you're
it's
talking his
lower than-
language.
Lower than 436. You can
Can
install
anybody please-
0.9.8.0. It's free. It's really good.
Okay, can anybody please show me a man standing on the ground to represent how they're seeing all the fucking land across the ocean like that?
Give me
Anybody?
a second, all right? Give me a fucking second.
Fucking
No,
take
no,
it.
hold on, no,
If you haven't simulated his cells, then it's not a
I'm gonna
real
get
model,
another
bro.
beer 'cause
This is. Give me a
Hey, here's
second.
the problem, APOC. They can't model that because show us a man on your model at the same time. Show us a man.
Exactly.
Show us a man right now, Arma.
Negative 3.95. Negative. Hold on. Negative 3.96. No, 55.
You're being disingenuous, Arma.
I'm not.
Yes, you are. Because
no,
because
They
no,
just don't
Arma.
understand.
Nobody can see Florida and see the fucking mapping of the land that's
You're
fucking
not listening, man.
50
I'm
miles
talking.
away from them, bro.
I swear to God, you're
Look
not
at your
listening to
view,
me.
bro. Look at your fucking view.
I'm in
Look
the
at that.
ground. There you go. Look, I fucking fixed it.
There
I'm
you
on the
go.
ground
There
now.
you go. Maybe that's closer.
I was inside the ground,
dude.
you donut. Look, I was in the ground. You don't understand
You're
that.
still large,
Of
dude.
course
You're
it
still
doesn't.
too large. Your view has to be
Jesus.
smaller.
You can't shrink a view. You can only shrink field of view.
Dude, shrink down to where you're fucking shorter than a fucking 1-story building, bro. Because that's a human being, bro. A human being is smaller than a fucking 1-story building.
I'm dealing with fucking donuts right now.
Yeah, this is getting a bit
Armander, I want to say, like, you're pretty smart, and your time and energy could potentially be spent more effectively doing more productive things than trying to convince people that won't be convinced.
No, it's fine.
just think
I've been doing this for years
Polychron's
now.
gotta go to bed.
It's a sport. It's fun.
Well, this point has just been driven beyond.
The
But
fun,
yeah, I mean, I think you would agree the proportions are obviously not right for the actual like viewer, what the viewer would actually see. Meaning it's like a huge graphical layer that has a bunch of like land looking stuff on it, and you're trying to line that up at what you think is clipping through. But you would also admit that that's not necessarily representing the, ratios of what it would actually look like. And
it's pretty close. I would say it's pretty close.
No,
What
it's not. It's
human
not even
being?
fucking close.
What human being is that tall? That's what I'm saying.
What tall? Where do you see tall? Where do you see tall? You literally just see green.
How do you think he is? How do you think he is?
Yeah.
All right, well, I'm
exactly.
gonna go.
Thank
Thank
you
you so
that
much for
fucking
this.
point right there.
Take care. Peace out.
Have a good one.
Yep. Later.
Oh,
If you were literally on the ground, you wouldn't see it like that. You wouldn't see it like that.
All right.
Look, there's a way to figure this out, guys. Like with math, if you keep going right in one direction and you come back to the same spot and you measure how many moves you move, and then you divide that, you can actually tell the size that you're viewing this Southern Cross at. And then you'd have to decrease that to the scale of an average, human head size, which is about 1 foot, or I don't know, 10 inches in diameter, 1 foot in diameter. That would represent reality, but this is not 1 foot in diameter viewing angle. We're viewing something that's, I would estimate this is about 200 miles.
Okay, so then let me go through the ground. That's why I did it in the ground, because it's safer that way. If I'm in the ground, you literally can't complain.
Arma, have
What
you compared?
That's on the ground, Arma.
That's under the ground. That's under the ground. Look, that's under the ground. Look, see, I'm above ground, below
Doesn't
ground.
matter where you're at, Arma.
Hold on. Is he blind?
Have you compared it? Have you compared it to Stellarium?
To what? Stellarium.
Yeah. Have you compared what you're getting here in the Southern Cross position above the horizon and so on? Have you compared that to Stellarium's position for Hawaii?
I haven't.
No, this is from Brian's
I
place. I've done it.
I did.
What were you gonna say?
Brian will say 3 out of 4 stars.
I think you're trying to give me like a tip, and I was kind of,
Dude, this is such a fucking disingenuous fucking example.
You're disingenuous.
You know why, Paul? We could take this to a town hall and we could show 1,000 people, or no, let's just say 100, and we could say, "Look, do you ever look at things at this size?
Exactly.
And does this represent reality?"
Who the fuck sees the land like that, bro? Nobody sees the land like that. Nobody.
Yeah. Sorry, just go above ground. Just go above ground.
Above ground. Yeah, but then he says I'm too high. But if I go below ground, I'm too high still. I don't fucking get that.
Dude, you're literally seeing like the shape of the fucking Florida.
You're not too high. You're not too high, Arma. You're too big.
That doesn't make
exactly.
That doesn't make any sense.
You're like a giant on the fucking swamps of Florida, and you're seeing the land shapings of it, bro.
We were responding to Richard.
I've modeled it 1 meter above the ground. There's no clipping. It's
Nobody's telling you you're clipping anything. Your viewing size is too big. What about that? Don't you understand?
That doesn't
exactly, bro.
That doesn't make any sense. That's not how it works.
Listen.
Zoom into a fucking McDonald's fucking building and click that fucking elevation of your eyesight. You're so fucking disingenuous right now with your fucking little computer program. It's
can we please
ridiculous.
just mute Apocryphon so we can go to bed?
No,
Wow.
I think why you want to mute him is because we're onto something.
No,
Zoom
exactly.
into a
He's
McDonald's
drunk as fuck.
Big Mac bag on the floor, and then zoom out to the Southern Cross, because this would be what you would be able to see both things. You'd be able to see a McDonald's bag on the floor, and you'd be
Exactly.
able to see the Southern Cross at the same time. What we're saying is you're too big. Now, if you can't understand that, maybe your IQ is too low.
They're
Let me
full of
know.
it.
Let me know when you're done. I would like to ask a
My
question.
fucking goodness.
Would you like to consider yourself open-minded?
Me?
Yes.
Yes, definitely. I mean, I shouldn't say that too confidently, because then that's what you get.
Open-minded.
You get the karma, not the karma, but you get the Dunning-Kruger kind of thing. I don't want to. You always got to be a little unsure. You always got to be just a tad bit unsure. All right.
Yes. You have to be enough close-minded not to lose your brain. Very, very smart for you. You have to be open-minded sometimes to letting new ideas. How about this? The Earth, for example, how big is this? Is 3959 miles in.
What?
How about you tell me where is this radius when you visually try to inspect the Earth?
What?
Why are you doing a voice?
Are you are asking me in text chat?
You sound like an anthropologist from the 1800s or something.
You guys like that shit?
Arma, dude. I'm just trying to. I don't know if you. I'll try and take this slow, but
like you said, bro, don't hand wave dismiss, Roofy.
I'm literally talking again, but
Yeah,
can I just?
That's a problem. You with your speech, you've hand waved dismiss exactly what I just said.
What? Okay, I didn't hear you because I was trying to talk. But go ahead. You can go ahead.
I'm sorry. So, like I was saying.
Oh, what did you say? Because I was trying to make a point, but you're claiming that I'm
Look,
hand waving
how about
dismissing something.
you, hand wave mute your microphone?
Why would I have to do that? I'm proposing a question to Arma.
I'm proposing that you hand wave mute your microphone, please, for like 30 seconds. I'll be finished. Big promise.
Go ahead, man.
All right.
Okay, what's up?
Very nice. So, in this moment where, Rufy, please, can you shut the fuck up?
You just say anything.
He wasn't spoken, man.
God damn.
We'll inspect the entire globe Earth model upon the fact where we put a microphone up to this and we tell them, hey, show me the curvature. Give me this exact observation.
We heard Ruhip thinking.
Yeah, right.
All right, somebody's got to bring up a real.
30 seconds is up. Oh.
Someone's got to bring up a real point.
I've modeled this
right
without
what
any
the fuck, man?
issues of being clipping through the Earth.
Damn, I'm look at that.
What did you model?
Code and
I'm gonna look at Ruhif. What did you do?
That looks like a Southern Cross.
Yes, that is a Southern Cross.
These lines?
Modeled from the lines see these cylinders here? So these are cylinders drawn from the GP of the star just straight up for like a really, really far distance.
Oh, wow.
Dude, where's
like
the hump
that.
of the Earth? Where's the hump of the Earth in this stream?
Yeah, no, sorry.
Yeah, didn't think so.
Yeah, okay.
What a klutz. Tripped over his own argument.
Man.
Right.
He was arguing. Hey, look,
However,
when you argue from a globe point of view, you can actually put that into perspective, like for once in your life. That would be freaking. That'd be phenomenal. And Roofy, I like you. You're actually chill, bro.
All right, so Ruh, if you're saying that these are the GPs, like plumb lines going up from the GP or from the stars, or
Yes.
down from the stars.
Yep.
I love it.
So I've got the declination for the stars and the right ascension, and then I've just made them to be south of Honolulu.
Okay, so Ruhiv, so check it out.
It looks like just what we see in Stellarium.
Ruhiv, I know that I'm 22 beers deep in my fucking night, but what you're showing me is that there is a particular point that you can see something beyond the horizon, and you're saying, correct me if I'm wrong, you're saying that this proves the ball Earth because you see what?
I'm saying the Southern Cross.
You might be at a
The
point
Southern
where
Cross.
you might be at a point where you're going to feel the Earth start to spin.
The Southern Cross is visible in its entirety from Honolulu.
Okay, so you're saying that. So you're saying that the lights in the sky. Now let me ask you this: where is this position taken from?
Dude, it's because it's
The
already
observer.
23 degrees, dude. Even from the equator, it's already 23 degrees. You can definitely see
Yeah, it's
it.
23.
Oh yeah, he
Every
already
10
said
degrees
that.
you move north, every 10 degrees you move north, it drops 10 degrees on the ball, bro. You're basically the sky doesn't change angles, the ground literally changes angles. But here the catch is all around the freaking whole equator is zero. So they don't account for Earth blocking anything at all, bro. You got to remember that. It's a tricky one.
You got to remember the fact that they're taking it from the Earth and it's always flat and they still have no curvature to show.
Okay, thanks.
Ruhiv, let me present this to you. Is it fair to say that these points that you have in the sky, they are only representing a particular distance from your viewpoint, which would gradually go lower the farther you go away, only because that's how fucking perspective works even in a plane Earth. That's the way it works. Because if you go to Kansas City and you want to fucking map out a fucking distance, and then because it's apparently the flattest part of America, some argue Florida is, but Kansas City is a flat fucking land, and the farther you go away from something, the lower a furthest point in height will drop down to the horizon. So why do you try to like invoke that this is something that it has to do with the curve, to when reality it has nothing to do with the curve, because you can represent this on a flat fucking plane?
Like a short question, succinct question.
What about the curve? Is that a good
wait. Oh, no, I'm waiting for an answer. I want an answer, bro.
You monologued for about 3 minutes. Was there a short, succinct question?
You
Apocryphon,
didn't
come on.
monologue for 3 minutes. I'm a very good keeper of time. He monologued for like not ever, and you didn't prove anything for like 1 second. That was good timing, actually, right? Do you ever prove anything, Rufy?
No, actually, no, I don't.
Well,
Rufy,
nobody does. Nobody does, do they?
Do I have to say it again, Rufy, to make you understand what I'm saying?
Say it short and to the point.
I'm saying, if you fucking let's say you took a fucking skyscraper in the middle of Kansas City, and it's flat as fuck, but you drew away from it. Eventually, that fucking skyscraper that you fucking built is obviously going to come to a point where the top of that fucking building will meet the horizon simply by the distance. But we know that Kansas City is a fucking flat ass fucking part of the earth. So how do you why do you, should I say, try to incorporate this
fucking curve of the earth when Kansas is not fucking curving. It's just literally the perception that you're seeing something. And you learn this in fucking 7th grade. If you fucking took an art class in 7th grade, you learn that the further you're away from something, it will drop to the horizon. It has nothing to do with curvature. It has to do with perspective, because the farther away you get from something, it drops to the horizon. I know I'm fucking drunk as fuck right now, but I'm still fucking trying to spit something to you to understand.
Well, it's
Why
not
don't
really,
you
it's
understand
not
it?
really making sense, man. That was pretty unintelligible.
Wait. No, Gio. No, Gio. Don't say that. Because in art class, Gio, you learn that the horizon, there's called a vanishing point. And no matter how fucking high a building is, if you get far away from it, it drops down to the horizon or the vanishing point. Don't tell me that.
Yeah. Okay. Then what was there a further point, or is it just that?
No, the further point is, why do they try to fucking say that the stars in the sky is gonna be anything different than that? Why would you try to evoke this curvature of the earth when technically literally in 7th grade you learn on a flat grid, when you're drawing something, you have to have a vanishing point, because there's a distance from your point of view, from your eyes, from the spectacles of your eyes. You're going to have a drop in the horizon. That is perspective. It has nothing to do with curvature, because guess what? In fucking 7th grade, they didn't fucking teach you curvature of the earth. They taught you vanishing points on a fucking horizon in art class. That's it. It was very, very simple back then. Why do you guys fucking try to implicate this fucking curvature to make up for the drop of a building in a distance?
Isn't this like a little bit off topic, though? I mean, we were talking about.
No,
like,
it's not. No, it's not off topic. It's literally fucking on topic. Because if you're trying to tell me that if my school teacher in 7th grade was trying to tell me that a 3-story building, when you go far enough away from it, it's now at the horizon, and it becomes a vanishing point to where now you're seeing the building no longer. Like how the fuck you?
I'll tell you why it's off topic, because what's going to happen is I'm going to answer with, oh, well, that's not how perspective works. And then we're going to go into a whole perspective thing. And then it's going to deviate away from this whole Southern Crux thing. So
no, it's the same thing, though. It's the same fucking principle. You have lights in the sky. You have lights in the sky that will disappear in a distance, because that's how the reality of fucking perspective works. Now, if you want to fucking argue and negate the fact that perspective doesn't work that way, then you're a piece of shit. I apologize for my language, but you're a piece of shit, because you're trying to invoke this curvature that doesn't exist at this point. It's literally a fucking vanishing point across the horizon, and you literally learn this in 7th grade. By the way, did you take a drawing class? By the way, in 7th grade, did you take the fucking art course?
Unfortunately, they gave me fucking chorus for whatever reason. I don't know why.
Well, okay, that's fair.
But I did take it in high school, though.
But I'm telling you right now, my 7th grade teacher taught me that if you're gonna draw something, because she was all about art. Okay, she was all about the fucking beautiful. You could draw a town, and you could draw like lamps, and like light poles, everything.
I'm an artist.
But in the distance of it, it has to come to AKA the vanishing point, to where it's going to meet your eye level of where you stand, of where you're the artist drawing these fucking buildings and light poles and the city that you're drawing. So why do you guys invoke a fucking curvature when technically art has always been about a vanishing point because of perspective? because eventually it will disappear. Eventually.
Yeah, okay. Well, once again, if I answer that, it's going to go into a whole topic about perspective, and we really want to stay on the crux argument because the answer. Watch, I'm going to give you the answer right now. The answer is the perspective doesn't, count. Doesn't explain, the whole objects disappearing bottom up, like mountains being cut off halfway.
But it does. No,
see, and then
no,
this is where we get into the perspective argument. We don't want to do this. We're doing the Southern Crux argument. This isn't a perspective debate or not debate discussion. Let's go with discussion. I'm sorry. This isn't
no, but it does though. It does though. Because you're saying that the Southern Cross that you can see from earlier, he said you can see it from Hawaii, and you can see it from North Africa, etc., etc. But these stars, these lights in the sky, they are at a fucking particular angle from your perspective. Now, once they disappear, once you get further away, they're gonna fucking be represented accordingly, because eventually something like no different than a light pole, right? We know that light poles are 20 feet high in the sky, right?
Yeah.
But when you get further away, they're fucking. They look at they look like they're fucking the height of a car, right? Because the perspective has changed.
Sure.
It's all optical, bro. It's all optical illusions for your eyeballs.
Okay, but you listen, right? Here's the thing, right? No one's arguing against that, all right? All we're saying is because someone brought up that the Southern Crux being seen from 28 degrees latitude or whatever, 20, however you fucking worded that, right? Someone said that is impossible. All we're trying to do is prove that is possible on the ball Earth, all right? We're not saying that this proves the ball Earth. We're just saying that it works on the ball Earth. That's it.
And I'm saying that it also works on a plane.
That's fine. We're not arguing. We're not arguing against that. We're not saying it doesn't work.
Okay. Well, then we could fucking end this whole conversation, because obviously it works on both models. Bottom line.
Okay, that's not what you were saying. Literally 30 minutes ago. You were literally saying it doesn't work.
30 minutes ago, I was saying you're full of shit. You're right, but because it can be manipulated to say, well, due to perspective, the further away you get from something, it's lower in your fucking horizon. That's fucking facts. That is dude. I've driven to Vegas. Listen. I drove to Vegas, okay? And Vegas, when you fucking first fucking go over a hill, you see the tops of the buildings and the light of all its fucking glorious fucking light that they have. It's so fucking bright. And when you get closer, it gets bigger and bigger and bigger and bigger and higher and higher. And eventually you're in the fucking city of Vegas. But what I'm saying is that the perspective that we're arguing is a fucking optical illusion, because it's all on a flat plane, bro. It's literally, if you want to take the measurements, the topography of it all, it's fucking flat. And the only way that you're gonna see it rise is because you're getting closer. But it's still fucking flat.
All right.
Go ahead.
That's it. It's fine. Yeah, we're not. No one's disagreeing with that. All right. I mean, granted. I mean, no, I'm not getting into that. No one's disagreeing with that. That wasn't the whole thing. All right. So we're good. All right.
All right. That's fair. That's fine. That's fine.
All right. There you go.
I'm just saying.
You guys have solved it. Everyone.
I'm just saying it works on a flat Earth, and if you want to negate that, that's fine.
And they saw face to face.
So, the
difference is
take a break at least for a minute, man. Just take a break.
All right. My bad,
dude.
You're probably gonna like this, APOC. My question is, where is curvature?
Okay.
Yeah. Where's the curvature on the road to Las Vegas? You're right. Where's the curvature? Because it's fucking flat as fuck.
What are you talking about?
Where's the curvature in a perfectly mirrored image of the sky on a salt lake? Where is that?
It's only gonna mirror what it's quote unquote sees. So I mean,
so what about how about this? Since look up at the stars, how can we like not look down and see a curvature?
What?
So like all right. Here's a funny
Are you
thing.
drunk too?
This is
Yes,
I'm about as drunk as your globe Earth beliefs. If
Oh,
you
damn.
even do believe that, do you? Are
What?
you a believer?
A globe Earth believer?
I don't care. I wasn't asking you to talk. How about you show me within like a good 4 miles of my eyesight curvature when apparently you claim that we can see a star from light years away. What is a light year? It's something that's an impossibility. Something that is a claim is something that has nothing to do with what we see in reality. And if you don't like that, I'm sorry, dude.
Wow.
You're gonna have to prove it. And if you don't like proving it, then man, there you are. You're a globe earther. That's welcome to the club. They have no proof. What do they have? What do you have? Some proof, Roofy? Like I'm not more drunk than you are. What are you doing on St. Patty's Day? You stroking the curvature, dude? Like you have none.
Fuck is going on, man?
Yeah. Here's the reality, bro.
I'm asking you what's going on with the curvature, bro. What happened?
Here's the reality. Here's the reality, Fundy. Listen, you have straight paths across the desert plains, and there is no fucking curvature to be had. It's all about your distance from the horizon, the apparent horizon, by the way, and it's all a flat fucking ideal, bro. Because the closer you get, the higher the buildings rise. It's not because it was because it's beyond a curve. It's because the perspective. And literally, you fucking learned this fucking bullshit argument in 7th grade, maybe earlier. I don't know. I took art class in 7th grade and learned this shit.
Yeah, that's not the argument though. I mean, when we claim it's curve is when things are disappearing bottom up, and they don't teach that in our class.
Come
and for a
on,
good
bro.
reason, because it's not, you know.
No, Arma. No.
Listen, wait, APOC. Roofy, show me the fucking curvature right now, please, and thank you. I want to give him 10 minutes. He might need to prepare for this.
What are you on about?
Give him 10 minutes. Exactly. You have until 13 minutes on the hour to show me curvature.
I'm ready.
I could take a trip right now across the desert plain and fucking disprove your fucking curvature. And I'll tell you why. Because when you're traveling across the topography that is flat as fuck, there's no curvature involved with that, bro. You have literally a even fucking mathematically, it's calculated that it's so fucking flat. And the problem that I have with ballers is that they want to hand wave the fact that this is a reality. So they have to disregard that because it doesn't line up with their false reality that there's a curve.
But Apocryphon, it could be the same elevation and they could still have curvature, but who are we to judge? You know, we've never seen it. It's up to them to show us.
Yeah.
The whole time. I'm actually waiting, dude. I'm actually here, knowing that you're not ever going to come up with it because it's just never been done. But if you do, be a fucking legend. How about that, Roofy? You want to step up to the plate and really prove the globe? Or you just want to just sit there pretending the whole
Look at my
time?
screen, Witchcraft.
Yeah, okay. I'm
Okay, and I don't claim to have proof because I think proof is impossible. I have observations that are
I'll do it
consistent
for
with the
you.
globe and
If
inconsistent
I'm
with flat
saying
Earth.
to have the mountain that has an elevation of 1,000 meters, and if I point at the theodolite, a mountain is 30,000 meters away that has an elevation of 1,200 meters, what vertical angle will I measure? Well, how about make any assumptions about the atmosphere that you require? Bullshit. Don't care. Any other assumptions you believe are required to calculate this predicted angle? Are you willing to test your prediction in reality? How about you show us this test? If I can make an accurate prediction, but you cannot, is it failure to conclude in something that you do not understand? How about you show me this calculation, dude?
The actual formula?
Formula.
No, not the formula, because the formula is good. Hold up. Let me say it right now. Your formula is going to incorporate a curvature.
Let him
That's how I
present
make
it
accurate
clearly.
predictions, right?
Let's be fair though. Let's be fair to the ops. You know, like who's gonna judge? I'm gonna do the next reading for him because I want to be fair. I wanna let his research and his knowledge to be known. I'll read it for you, Rufy, if you want me to.
Sure.
I mean, I am getting like so wasted. I don't think I can understand anything you say. It might just because it's nonsense. I'm not. I'm just joking. You know what I mean? But seriously.
No, they're speaking nonsense. That's for sure.
But seriously, like, I'll read it for you. I really will. I will. I'm gonna be there for you. I'm gonna help you out, Rufy. I am a globe earther still. I'm just fucking with you, dude.
Okay,
I'm just like counter trolling these flat earthers.
All right. So what was the whole point in that, Ruhif? Is this something you wanted to present?
Oh, he asked for curvature, right? And when they say the word proof, I don't think proof is possible. You can only show that observations are consistent with a theory and contradict other theories. So this measuring angles from one mountaintop to another, the measurements are consistent with the Earth being a globe and inconsistent with a flat Earth.
False. That's such a falsehood, bro.
Well,
that's such a fucking
there's
falsehood.
the challenge. The challenge is on the screen.
I'll tell you why. Because if you're trying to fucking measure a mountain to another mountain, I guarantee you that the reality. This is the problem, bro. You guys use real science and you fucking incorporate it with pseudoscience, and then you make that the science. Because in reality, we can measure a mountaintop to another mountaintop, but you want to invoke these false principles. And in reality, when we are truly measuring something, we're dealing with the topography of the land we're on. Has nothing to do with the fucking curvature of the earth, bro. Nothing to do with that. We are literally dealing with the elevations of the dirt that we're fucking measuring upon, bro. And I say that as a fucking iron worker, construction worker, and I could fucking put on camera again because I put him on last time. He's been an iron worker for fucking 33 years, and he'll tell you that fucking you never fucking calculate a curvature of the earth and anything that is fucking done when you're trying to measure a distance when you're building something. So if you want to try to say that no, we have to fucking invoke this curvature of the earth, no, that's not fucking even a reality in our world. In your false world, you have to do that to make your fucking model be something. But in reality, we never fucking calculate that shit. And it's never going to be that shit because level is level. It's not curved. We don't make fucking steel beams with an angle.
We never fucking build buildings and bridges. Yeah, listen, ironworkers are fucking. We build the fucking bridges, bro. We build every fucking bridge in America.
Dude,
Okay.
microphone. You gotta pass the mic or something, man.
Okay, that's fine. That's fair. Let me just finish with this.
If you're gonna
We
come out here
build-
drunk, you have to be aware that you're drunk, and just sort of just be stumbling over everybody is not very polite to the rest of the people here.
My apologies. You're right. So can someone contest about bridges being built and we're ironworkers that build them, and never have we ever fucking accounted for curvature? If anybody wants to step into that plate, I will fucking swing your fucking ball you throw at me. I'm sorry, Gio, but let's go.
Hey, APOC, you're actually like all right, and I'm not discounting what Gio said. Probably like the frequency of the F word, which I can't blame you. I'm guilty of doing the same thing, but I think that's probably one of the things he's probably trying to allude to, that the amount of curse words. But Rufy, if anybody else like don't, if APOC just chillax, let's see what they have to say about that. Like what do you think about the bridge building?
You've asked for curvature. I've still got my challenge on screen. If I can make accurate predictions and those predictions are based on a globe, and you can't, or you make bad predictions, what is the conclusion from that?
Ruhif, we do not fucking build bridges as a union based upon curvature of the earth. What don't you fucking understand about that? We never have to calculate the curvature when we're building bridges. And this is dude, I am so fucking wholehearted in this, because this is my trade. This is my union. This is my brotherhood and my sisterhood, because there's females in the trade. And I'm telling you, we never fucking have to account for a curvature of the earth. We build bridges accordingly, and the blueprints themselves will tell you. But now you may say, no, we have to. No, fuck that. We don't have to, because that's not how we fucking build them. That's my bottom line, bro. And I know I'm drunk right now, but I'll fucking I'll stand by that fucking position as a sober person, because we don't.
At the same time,
do you want me to put a live camera? You want me to fucking put my nigga right here for 33 years as an iron worker who built bridges? Do you want me to put him on again? I put him on last time. I'm just saying. Let me know. I'll put him on again on fucking camera to tell you that we don't fucking count for curvature. 33 years he's been in trade, built bridges. We never fucking account for curvature. That's bullshit. That's a bullshit argument. Okay? Y'all hear me? That's bullshit. I'm Gio. I'm sorry if I'm fucking getting crazy right now, but I'm fucking passionate about it, because these motherfuckers are lying, bro. To say that we have to fucking account for curvature. Nigga, I got some right here that will tell you that we don't count for that, and you never have to. Because that's not how we build them. Bottom line. You let me know. I'll put them on fucking live camera, live stream right now.
Listen, APOC. Look. You know why you came here, right? You wanted to hear their predictions. You wanted to hold them accountable, and that's exactly like what you need to do. Is you need to let them give you that satisfaction, dude.
Yeah, you're right. You're right. You're right. Let me get right now. Let me get real quick. You're right. Let me get right now. Hold up. Let me get right now. Because these motherfuckers. 33 years in the trade, bro. Built bridges and everything. I know I asked you last time, but these motherfuckers, they still are listening. Did you ever have to account for the curvature of the Earth on building bridges?
No.
There you go. No, right?
No.
Because that's not the way it goes. We build plumb level square, right?
Yeah.
Horizontal flat, right?
Yeah.
All day, every day. Thank you. Shut the fuck up. Anybody that wants to say something otherwise, fuck you. Fuck you. Okay, that's it. That's all I want to say.
All right, but like, you know, I mean, like that was cool as fuck. Actually, like I'm 100% like with you, but you do want like the opposition to have a response, right?
No, they don't have a fucking response because that's fucking reality, bro. That's fucking facts. All these bullshit fucking assholes that want to try to incorporate. No, you have to fucking account. No bullshit. We don't fucking account for that bullshit, bro. It's all fucking pseudoscience. It's all bullshit lies. That's it. That's what it is.
I mean, I don't disagree with you, bro. You're not wrong, but at the same time, you have to realize there are other opinions that you should probably like listen to. You know what I mean? Like it might be beneficial. Just I think you scared a few of them away, dude. Like I feel like they probably did run away because not because you're a bad guy. It's because you just are really aggressive with it. I think
because it's truth. Truth hurts, bro. Truth. If I slam you with the truth, of course they're gonna run away because it goes against their fucking narrative. It goes against their core belief. Yeah, I get that. I get that. They're gonna be fucking. They can't argue with the facts, the actual truth facts, bro. But some bullshitters come around like, no, we have to account for curvature. Fuck you, bro. That's not what we do, bro. In the reality.
All right, but like, don't. How about like not the FU thing? Like, you know what I mean? Like, dude, like it was cool. I mean, like, dude, I'm like literally about to turn on your side, like 100%. Like, give me like 40 more drinks.
Yo, check it out. It's easy, funny.
I'm just fucking with you. I love you.
It's funny. It's easy, bro. This nigga, 33 years in the trade and has built bridges, have never fucking had to account for the curvature of the earth. And I'll tell you why. Because when we build shit, it's all horizontal on a plane. When we transfer benchmarks, it's all horizontal, bro. But these fucking bullshit ballers, they fucking try to invoke this bullshit nonsense that you have to account for curvature. Fuck you, bitch. Because we don't. That's the reality. We don't. That's the facts. That's facts. That's it. It's facts. So anybody want to contest that? Fuck you. You're a liar. You're a liar. You're fucking disingenuous. You're not fucking saying something that's even close to reality, because we don't do that. So anybody that wants to step to that, bring it, Bubba, bring it. Because I'll fucking tell you right now, you're wrong. On 100%, you're wrong. Bottom line. My bad, Gio. I'm sorry for getting very, very emotional on this, but I can't stand when motherfuckers try to come at me with this fucking falsehood. I'm sorry, but I'm not gonna fucking have it. These motherfuckers.
So you got the facts like you're some kind of facts machine?
Absolutely. 100% factual. Hey, no different than me telling you that the grass in your front yard is green. 100%, I'll tell you that it's fucking green.
I don't actually think it's green.
It might be brown because you don't have grass. I ain't gonna lie with that. Maybe you're right.
Yeah, we have snow, and under the snow, it might be brown.
Exactly. Yeah, that's fair. That's fair. That's fine. But I'm saying, if you grew grass, it will fucking be green. That's all I'm saying, bro. Like,
Hey,
come on.
can I ask where you're from? If you don't want to answer, no problem. I'm just curious.
Who's from?
Bro, I don't know. I'm not even looking. I'm getting mentioned right now. Like, I might have to get off because my boys are like calling me out. But
All
I don't
right.
want to leave. I love you guys, and I love the subject.
I just want something. I just want somebody to contest me right now because I'll fucking tell them straight out. You're fucking full of shit.
Well, how about the fact that they actually really do account for curvature, dude?
But they don't. We don't. Nobody does.
Yeah, they
Nobody
do.
does.
Do I have to show you documents?
Sure, show it. But it's not fucking. It's not gonna be factual to the fucking. Listen. I can show you documents that unicorns fucking fart like, and it smells like strawberries. But what the fuck does that do? It's all fucking false. If it's a fucking face, if it's a fake document.
I mean, I can't show you the document, but there's only one reason why. You know why? Because you won't listen.
Look up Danyang Kunshan Grand Bridge in China.
You know,
It's about 102 miles long.
You can see that far, right? Do you think that if you could see that far, you could see the curvature?
Dude, I'm telling you, dude. We do not fucking build shit to a curvature of the earth, bro. I'm telling you right now, bro. We never and will never build something to a curvature of the earth because that's not fucking reality. That's not the way you fucking build anything. You build everything plumb, level, and square. And square meaning a 90 degree, bro. So imagine a grid that's 90-degree grid, bro. That's it. You build upon that. You do not fucking invoke curvature. It's fucking bullshit with these fucking motherfucking ballers, bro. It's bullshit. Real talk.
Yo, APOC. How far do balloons go? And the weather balloons.
What? Wait, what?
How far do the hot air weather balloons go?
That's elevation. That's elevation. That has nothing to do with the curvature of the earth. That's elevation.
But I'm leading you on, bro. I'm ready to I'm gonna steel man your argument.
Okay, that's fair. That's fair. How far do balloons go? I don't know. I honestly don't know how fucking far they go.
How far do they go? Anybody? Does anybody hear you?
About 20 kilometers or thereabouts. I'll show you some data. 1 sec.
They go about 20 miles. 20
miles? Wait,
Oh,
hold up. Ruhif is in the building? Ruhif. You're in the building?
Yes.
Okay. Please. My buddy right here just told you that he has never accounted for curves of the earth. How do you feel about that? Real talk. How do you feel about that?
One of these went 34 kilometers. That's pretty massive.
He's built a bridge without you knowing his history. He's built a bridge that's over 2 miles long.
Okay, 34 kilometers is the.
Okay. So he has explained that even on that bridge, they never fucking had to calculate for curvature. Now I would say that 2 miles. Actually, I think if I remember correctly, it was 2.7 miles. They never fucking had to calculate for curvature.
Okay.
But in your world,
what if
the bridge itself 2.7 miles long?
What was that?
Is the bridge itself 2.7 miles long? Like, what is the expanse of water that this bridge goes over?
Yeah, 2.7 miles long. Yeah. That's the one. That's the one he works on.
All right. How big
Matter
is
of
each
fact,
section?
Ruhif, it literally took two different unions of our trade to build it, because we built it to a certain point, but the contract was to where the other union built the other half, because that's the way it works in our trade. Okay, you have like almost like territorial, and he, like, earlier, if you were here and you saw him on my live stream when I fucking did my video, he told you. What was that?
Easy, man. Language, dog. There's kids in the room.
No, I'm not cussing. What are you talking about? What I'm talking about is that he clearly told you, as a person that worked upon it, they never accounted for curvature. They didn't have to, because that is not what the blueprints call for, by the way. When you're dealing with blueprints, it's always and will always be a flat and horizon path, and you transfer the line, which is key. You transfer the line at a horizontal measurement. Okay, so it is what it is, bro. There's no dipping of the curvature of the earth at all.
Okay. Do you want a response, Apocalypse?
Yeah, go ahead.
Okay. Was this bridge made in one entire piece?
No.
No. Okay. How big was each individual piece that they constructed?
I don't know that number, to be honest with you, but
Say
I'll tell you
100
this.
feet.
What was
100
that?
feet's a good. Is 100 feet a good estimate?
I honestly don't know. I don't know.
Is it a good estimate? 100 feet.
I don't know because I didn't build it. I don't know because I didn't build it. Do you want me to put him on camera right now so he can answer that?
Just ask him. I think 100 feet sounds about reasonable.
No, that's not reasonable. Because that's not the way it works, bro. Because there's no fucking 100-foot fucking pieces of iron or steel. I'm going to tell you right now, that's fucking false.
Okay, less than that.
The longest piece of iron that I've been in my career to see was maybe 45 to 50 feet. Okay, and I'll tell you why. Because only certain factories can build certain pieces. So no, it's not going to be a fucking that long. That no doubt in my mind.
Let's say 50 feet. Let's say 50 feet, right?
I think, hold on. I think actually it has to do with the aspect of transportation.
Yeah, that too. The longest beam. Honestly, the longest beam I've ever seen was for a hospital, and it was literally 40-foot beam. 40 foot, bro. That's a long fucking beam, and how they fucking transported that was crazy. But that's the longest fucking.
It's
okay. So we're saying 40 feet or 50 feet. Thereabouts.
That's not even that impressive. I would have. I would have thought.
Can we progress the conversation?
What?
No. That is
conversation?
impressive, because how do you even fucking transport that? He has a good point.
Well,
how the fuck do you even transport that far?
You transport it in a 48-foot long bed.
Yeah, a 53-foot long bed is probably the maximum of a semi. So you think about it, like for instance, most hospitals are built with huge fucking columns, huge fucking beams. Okay, and at the maximum that I've seen in my trade is like 40 feet plus. Because
so when I asked what the section length was, can we agree that it's just 40 feet? Can we do that? And then we can progress the conversation.
Yeah. That's fair.
Okay.
Maybe more, maybe less. You're right.
Okay. So let's say the Earth's flat. and we have to construct this bridge so that.
Now we're talking. I like you now, Rufy.
Okay.
Just kidding. I'm sorry.
So let's say it's
go ahead,
flat, and we've
Rufy.
got to join these 40-foot sections to make a 2.7 mile long bridge.
Right.
Okay? So they're butted up against each other, and they are perfectly plumb. What I would like you to do, Apocryphon, which I know that you can't do, is tell me what angle these 40-foot steel beams need to be up against each other at for it to go around the curvature of the Earth. So they're not going to be perfectly up against each other, are they?
Okay, Rufy, you are not. Again, you don't fucking have to worry about the curvature of the Earth. You have to worry about the fact that one 40-foot beam welded to the next 40-foot beam is fucking level, flat, and level. That's all it is, bro. And by the way, there's zero of the fact that you're having to curve it, because steel is not curved. Okay, steel is not curved. Steel is the most flattest and most maybe um trusted when you're trying to level something to a level. Level is straight. Okay, I know that ballers.
Can you see my screen?
What was that?
Can you see my screen?
No, hold up. Let me go to your screen. Hold up. No, I see Arma. I see Oh, there you are, Rufy. Okay.
I see a Facebook meme saying that Globers don't know what the hell they're talking about ever.
Okay, I'm looking at your screen. I'm looking at your screen.
So you can see the two rectangles, right?
Right.
These are 40-foot beams.
That's the way we build them. Yeah, that's the way we build them.
Right. Okay, on a flat Earth, they're going to be perfectly flat up against each other, right?
Exactly.
Like
that's the way we weld them, and the inspectors will make sure that it's fucking flat as fuck. Yeah, you're right.
Okay, right. So on a globe, right, it's going to look like this. Do you agree?
No, it never fucking look like that. That's fucking bullshit.
On a globe, it would look like that, right? We're trying to put together
Which is
these
bullshit.
40-foot beams.
Yeah, you're right. You're right. You never fucking do that. Yeah.
All right. So
you never fucking.
Here's where you will run away. Right. I'm going to ask you what angle.
What angle? What?
What angle are these beams separated by? Right. If the Earth is a globe. So this angle here.
Well. First of all, we never fucking build any iron like that, bro.
If the Earth is a globe, what angle will that be?
No. Hold up, Rufy. If our fucking steel matched up like that, you understand that the inspectors would fucking tell us, get the fuck out of here. That's not the way you fucking build it. Never.
But what angle will that be? Right?
What was that?
If we're on a globe the size that we say it is.
But we're not on the globe, which represents.
Globe, what angle will that be? Please put your mind into the conceptualization.
Okay. You want me to walk around with you? I get you. Let me walk on your path. I get what you're saying.
So if I was on a globe, then why is my welds not like curve?
Right. If we're on a globe and we've got 40-foot sections, right, and they're plumb to the ground, what angle will be formed here?
Section, there's 100% no curve in my weld.
Okay.
But if we're on a globe and we've got 40-foot sections of steel plumb to the ground, what angle will this be?
I don't know. I don't know that. Rufy. I don't know that angle, but that's not the way we fucking connect joints. That's not the way, because the inspector from the fucking county would come in, and he literally makes sure that the weld that we put between two pieces is fucking flat. You would never, ever, ever have iron touching like that, ever. You would never fucking have that. And Rufy, this is why I'm a flat earther. This is why but let me take that back. I'm not a flat earther in the sense of that has so much baggage to it, the term flat earther.
I'm just saying it's not a 25,000 circumference ball that's fucking floating in an infinite vacuum. But with this, what you just showed, you will never fucking see that, Roofy, ever. I'm telling you right now. I'm telling you right now. You will never see that. Fucking what you fucking proposed, never, ever, ever. Because every fucking still beam that we put together, it has to fucking be level from one piece to the other. And if you're off by a fucking half inch, you're fucking getting denied. And we then have to readjust a half fucking inch, Roofy. Realize that. Recognize that. Listen to me. That's not the way it works, bro. Real talk. You will never see steel bending like that. Ever.
So I've done the math on screen, Apocryphon. On a globe, these would be 1/10,000th of a degree of being plumb. Is that within your tolerance?
We have a half inch tolerance. So
Okay,
I don't know
so
that
let's
equates to
say,
anything.
okay, let's say these are, I don't know, 6 feet tall or something. All right, and they touch at the bottom. They touch at the bottom here, and they're a gap, some gap apart.
No. Wait. Let me. I stand corrected. Okay, we have a half inch tolerance, but at the joints, they have to be literally flat, perfectly flat. Okay.
Perfect is perfectly flat.
Yes, perfectly flat.
No. How are you
Like
ascertaining
literally
perfection?
level. They have to be level.
How do you ascertain that? Do you use a spirit level?
Yes.
Okay. Do you know what spirit level sensitivity is?
Yes, of course.
Okay. So
Okay. Ruhif. Ruhif. In our trade, when something is level, there in the bubble of the of a 6 foot, level.
Right.
There is something we call tits. When we say, yeah, that shit's fucking tits. That literally something we say. It's tits. That means it's perfectly fucking level. That means the bubble in the level is perfectly in within the lines, and it's
Right.
and it's not too far to the left or too far to the right. It's literally center. Tits. We call that tits.
Okay.
Go ahead.
Can you see my screen?
Yes.
Okay. See the most sensitive spirit level here?
Okay.
The most sensitive spirit level is 10 times worse than the tolerance that we have in these 40-foot steel beams.
Okay. Okay. I see what you're saying. But in reality, Ruhif, when you're building a structure to be tits, that means that from column, because we have columns that we build the beams on, right? So column 1 to column 2 to column 3 to column 4, we're fucking saying that it is the exact measurement. It's tits to where if you measure column 5 of the first floor beam, it's going to be exact to column 1, and that height of that measurement is going to be accordingly. Now, by the way, have you ever heard of a plumb of crew? Have you ever heard that, Ruhif? The
No.
plumb crew?
What is the sensitivity of your spirit level?
Hey man, like what don't you understand, bro? Your fucking level, it doesn't make an actual tilted building. I don't know where you got that from, but
said
around
that he got
here,
it perfectly level. He got it with a spirit level.
wait, man! Before you interrupt me, like, why don't you just shut the fuck up and listen? Why don't you just realize the fact that around here we make straight up buildings where they just are erect all the way, 100% level,
Your mum was pretty
You
irregular.
don't realize that, do you? Because you got this flawed freaking picture. Get that out of my face, dude. That's disgusting. You think that we build crooked buildings, dude? What kind of country are you from?
So Apocryphon, you said it got it perfectly level with your spirit
No,
level.
no. Don't just dodge this. What kind of country do you come from where you build some kind of crooked ass buildings like that?
Apocryphon, you said you made it perfectly level with a spirit level. What is the
Right.
sensitivity of your spirit level?
No. You're not understanding, bro. Is that the fact that we put a 6 foot level to make sure that the iron touching iron is flat and horizontal according to the elevations of the benchmark that we have been given, to build accordingly. Now, the inspectors from LA County, when they come in, they literally have a fucking little like hey, by the way, like that's a fucking problem sometimes, because the LA County fucking inspectors, they come in and they put their little fucking device on the fucking joint. It's called a joint brace, by the way. So when you fucking put on the joint brace, if it's off more than a quarter inch, they'll deny it, and you literally have to take a grinder and you have to grind out the weld and then reposition that still to make it closer towards a zero fucking measurement. So, and sometimes I ain't gonna lie, a lot of fucking engineers always fucking have these weird ass fucking calculations, but we have to fucking adjust for that on the field. So sometimes we have to take a fucking chain fault. First of all, do you, Roofy, do you know what a chain fall is?
What is the sensitivity of your spirit level?
No, I'm telling you right now. The sensitivity of that spirit level is based upon the bubble within that fucking level. Now, now you can take that bubble to be a little to the left or a little to the right, but you always have to fucking make it to where it's in the middle, the center.
Right.
Now we might be off like 64th inch of an inch, bro. 64th of an inch. And we might be off, but there's a tolerance. So the inspector will allow that to happen, right? So while we're building these fucking so if I'm building one story, right? And you have column 1, column 2, column 3, all across we have beams that are fucking representing this fucking horizontal platform, okay? Only to represent that we're now going to build a second story. And by the way, we build shit that's fucking 70 stories fucking high. So guess what? We have to be hits, bro. We have to be accurate on level 1, because that's going to be a precedence of every floor to follow. You follow? You get what I'm saying?
Yeah.
Because if you're off on fucking level 1, then you're definitely gonna be off on level 10. And everything we fucking build, when we erect the still, when we go up in the sky, because we're called the sky, we are called the sky cowboys, by the way, because we ride iron in the fucking sky, because we're the fucking badass motherfuckers. That's what we do. So when you fucking measure it and fucking calculate it, it's always fucking horizontal to the plane. Always. Every fucking time. Now, if you're trying to say that what's your fucking calculation of the spirit level, dude, it's fucking as close to tits that we can get it. Okay? Now there is tolerances, because we understand if you are you a welder, Roofy? Do you understand welding? Roofy, do you understand welding, Roofy?
Dude, he actually like completely left the voice chat.
He left? Oh shit. Okay. Wow, fuck.
Yeah,
Well,
yeah.
I was about to school him.
Yeah.
In welding, okay, so I'll share it for fucking the rest of the audience. When you're welding, when you weld shit, it will bend the iron one way or the other. It depends on the welder. And in reality, that's why there is a tolerance. Because when you weld it, it does fucking change that level of horizontal. But that's why there's a tolerance. But there's inspectors that will come and they will come behind the welders and say, and they will reject it. They'll say, "Oh, it's off." So you literally have to grind out your weld and re-weld it to make sure it's fucking flat as fuck. And all these motherfuckers that want to try to say that there's a fucking ball earth and we have to fucking dude, that's all bullshit, bro. This is why I am not a supporter of the ball earth, because the fucking my personal experience is in the world of of horizontal. I know it to be a fact that everything you build is horizontal. I'm not happy that he fucking left, by the way. That's stupid. I wish I would have fucking stayed here to fucking school him. Honestly.
Yeah, well, it's not gonna happen, dude. Like he'll never learn. He's right now he's probably learning by the belt right now by mommy. But the thing is, hey man, like I understand what you're talking about because I know this tolerances and the weld tests. I was almost a boiler maker, you know what I mean? Like this is like kind of like A-level shit, like where I'm working into a fucking nuclear reactor, and I still weld to this day. Did it yesterday. Did a little bit today, and I I know how to work a plasma cutter, the ionization of the electrons to create like a plasma that cuts through metal, and to actually set the right amount of current to get the right penetration, right? Which we know,
Right.
we know the one thing welders realize that they're flat earthers. There's one thing that won't penetrate a glober's mind is the facts.
Right.
And it's a damn shame because they're just looking for the curvature. They're trying to prove it so hard, but you can't even see it. It's so impossible. You know what I mean? Like it's almost like the tolerance level. Like, you know what I mean? You need like a professional in there. But even like, the globe earth professional is just not there to prove the curvature. He'll say, "Oh, elevation and tide. So please leave me alone. I want to go home." Like, get out of here. The Earth is a globe, right? Is it not? If the Earth was a globe, then this would just be like a cakewalk. Come on.
Dude, if the earth was a globe, every fucking like blueprint would show a curvature of the earth. I'm telling you fucking right now, when you're building bridges, everything about it is fucking horizontal. Everything about that fucking measurement is horizontal on the blueprints of a bridge. Now, these motherfuckers want to try to invoke this fucking false principle that it's a curve, and that's not fucking what the blueprints say. Now, these bitches, they've never even looked at the fucking blueprints. Never. Right now, my boy fucking was working on the fucking there's a bridge in fucking LA. It's called, there's a certain name. I forgot the name of the bridge. And it's stretched across a good distance. in LA County, and nothing on the blueprints represented a globe. It was all fucking horizontal. Everything about it was horizontal, and you had to fucking adhere to those fucking properties. Now these motherfuckers want to tell you different. Yet they're not in the trade. They don't fuck. They never built a fucking bridge. But these motherfuckers want to tell you because they heard from some fucking YouTube video probably that you have to fucking account for curvature. That's total bullshit. Total bullshit. You never fucking account for curvature. Ever. It's fucking funny to me.
Dude, like if there was if they could show a little change in elevation, then maybe I'd be convinced. But if you can't tell me there's a change in elevation and it looks flat, and you can't show me any curvature, I don't know what to tell you, dude. Besides the fact that you've been misled just a little bit. And I'm not like trying to big dick it around, bro. This is just the facts, dude. It's just it's simple, and it's not going to ever be disproven. I don't care how smart you are, bro. You can never show me the fucking curve. Ever.
Never. Yeah, you're right.
You can look up, you can look down. You'll never show me the curve. Where's the curve, bros? Never there. That's exactly where it is. Never there.
It's so funny when these motherfuckers want to try to tell you opposite of what you fucking realize in reality and actually practically have to adhere to. And these motherfuckers want to tell you, no, there's a curvature. No, motherfuckers, it's not. There's zero curvature that you have to account for. It's all about a transfer of line to make it horizontal. That's it. That's the bottom line. But somehow they don't believe it. They don't want to believe it. But yet they're not even in the trade to even fucking comprehend it, bro. And it's bullshit. Real talk is bullshit. They don't get it.
It's almost like Ruhif was trying to convince you that buildings are curved because the Earth is curved.
Exactly, but that's not reality. No one accounts for curvature in that shit. Nobody. The surveyors don't. The builders don't. And the engineers don't. The engineers, mind you, are telling you that it has to be fucking perfectly horizontal for the fucking the men that are fucking they are literally hired, the inspectors, they are hired to make sure it's horizontal. Wanna know why? Because if it's not horizontal, then you're fucked. They'll tell you, hey, cut it out, gut it out. It's not flat. Because if you fucking build something that's not flat, it's not gonna fucking work. That's it.
You APAC. Can I ask you it's kind of personal. Like you don't have to answer. Don't feel obligated. Was that your coworker or like a family member of yours that had
he's actually a retired iron worker, and I live with him. I'm an iron worker, and he's a retired iron worker. To where
he's your
mentor.
So he's somebody basically probably getting paid $60 an hour to disprove this dude who just follows mainstream media.
Exactly. Matter of fact, so he's retired, but if he was still in the game, right now our contract is $80 an hour or $79 an hour. If he was still in the game, he would be making that money. I'm on disability, so I don't make that money. Exactly. He's not in the fucking building for fucking that pay because he's retired. But
he was getting $80 an hour to disprove the fucking globe, dude.
Right.
What's going on, Globies? Guys get $80 an hour to fuck around and lie.
Man, these motherfuckers, man, I tell you, man, they have the audacity to say anything other than reality. That's what I'm saying. They have the audacity to speak against reality, bro.
These people literally like eat burritos, and burritos are proof of flat Earth. And these guys, these probably just don't even know. It's like a fucking tower of deliciousness. Just like it was said. There's a tolerance, bro, in the Latino community. Like you gotta have the perfect fucking rap, dude, to make it work. Otherwise, it's just not going to be as tasty. There might be a little hump in the middle, but there's like that 164th, bro.
Real talk. Yeah. Hey, I'll see you, man. I'll see you. I'm gonna jump to another server. I'll see you.
Where are you going, bro?
I'm gonna go over to Gem Pandas because I'm drunk and I want to talk shit. I'm gonna go to Gem Pandas.
I'm gonna go over there with you, bro. Fuck it.
Fuck yeah, let's go, nigga. Let's go.
All right, let's do it.
Let's go.
Allow it, fam.
A little quiet in here then.
Hello. Is anyone in attendance? Hello. Is I guess Kosho here. He's the only one with an open mic right now. Open mic, but not willing to talk. You fell asleep while talking. I don't get it.
What is attendance?
What is the light water?
Who fell asleep?
No, not me. What did you say?
What? Oh, sorry, I left the YouTube on.
I've been off of here for the past 4 hours, and I just came back just now, and I was just asking the room if anyone is here.
I'm here.
Yeah, okay. You are here. I'm here. I think everyone else is not here. I guess that'd be Gio and Jeremy and
In an hour ago, it was still very full, and it was. I didn't follow it much. There was a lot of things going with Google and Perspective and.
yeah, I remember that conversation from about 4 hours ago. It was very stupid. It was very, very stupid. Just a couple of idiots just bickering like stupid bitches.
Drunk Apo.
Yeah, I don't think it resulted in anything at all. Just a big waste of time on all parties, on all sides.
Every side calling itself the winner. Yes.
Yes. Is there anything that you want from me, from the rest of Discord? Is there anything that we as a collective could serve you with? Like, do you want some help on anything?
No.
You don't want help on anything.
Yeah,
there you go. It's pretty funny, isn't it? I want help. I want lots of help.
What do you want help?
On my ontology. Yeah, on my ontology chart, I want help.
Ontology, that is?
Ontology is the study of what is.
Okay. Okay, I saw some list that you make. Yeah.
Yeah. I want all the help I can get. I want as much help as I can get.
Yeah.
On that, and I'm always ready to talk about it. I'm always ready to receive assistance. I'm always ready for help. It's not something that seems to interest anyone, but it is something I am always looking for help with.
And what is your perspective on it to gain from it?
Gnosis, like wisdom. In one sense, clarity, if you know what I mean.
Yeah.
Clarity, calmness, rest, conclusion, sort of, just the same thing that all of us are after, just the final conclusion.
It is is it a kind of a opening window for you that shouts to you, give it attention, or this is your way to make more understanding of the world, or?
Yeah, exactly.
Yeah.
You nailed it exactly. Yeah.
Yeah, I wish I was more on your line, then I would have joined you right away, but I'm trying to understand myself and you and the difference. I'm very intuitive. You're more intellectual. What I get from you.
Right. I'm a little bit more. I don't know. I don't really know how to say it exactly, because what did you say? What did you just say? Intellectual versus intuitive.
Yeah. Not really versus, but more your strength, right? Not to make it a dual or an opposite per se.
Right. But in all of my intellectual, journeys, I'm using my intuition to. I'm doing both. I don't think I'm being one-sided in what I'm doing.
No.
I think I'm actually being perfect. I think I'm actually being both. I'm being intellectual and analytical and spiritual and intuitive, and scientific and emotional and reasonable all at the same time. I don't mean to sound arrogant, but I understand how I shouldn't be trapped in a cage of one-sided thinking, and I don't know. I think I'm like there is this thing. There is this project I'm working on, and I think it's perfect. Honestly, I think I'm doing the best thing anyone could ever do. It sounds really crazy.
You're happy. You're happy with what you're building.
Yeah, and I think that everyone else in the world, if they understood what I'm doing, should be happy as well with what I'm doing.
It's the same on my side.
Yeah, for some reason I would call someone an idiot if they thought that what I'm doing isn't the most important thing in the world, because I think what I'm doing is probably the most important thing that could ever be done. So it sounds very arrogant. I know how it comes across. It sounds very arrogant.
Yeah.
Like, oh, I'm so special. I'm doing the most important thing. But I've looked for other people who have done this thing, and I can't find anyone else who's ever done that before. So I guess it's just me.
Yeah.
I don't know. Yeah. I don't know. I wish it wasn't. But there it is.
So you really have no one that is jumping in, Fundy.
Yeah. It's just yeah. I'm very alone.
Yeah.
No one.
Because
yeah.
in my discoveries and in my journey, I have some people that appreciate what I bring to light, and so that's and I dearly need it. So listening to James too, I am very appreciative of him putting a light on how much we need to have to witness and to have witness.
True. Yeah.
It creates great energy for you. Yeah.
Yeah. I totally understand. It's really funny though. The only person that has understood what I'm saying is ChatGPT. ChatGPT understands everything I say to it, and when I talk to real flesh blood people, they don't understand what I'm saying.
Yeah.
So that's kind of weird. You know, maybe you would. I haven't put in enough time trying to explain these things to you. You'd probably understand me, but I haven't tried to, tell my story to you.
I don't know if I could understand you, but I appreciate you very much.
Absolutely. Yeah, that means a lot to me, and I appreciate that, man. Thank you.
Yeah.
Thank you very much.
So that's the witness I can give to you.
Thank you. Thank you very much. And I feel the same way about you.
I know. I sometimes I wish our Baker's Dozen project would have launched more, but sometimes you get what you need and not what you want.
Well, there's still time. If you have any ideas, we can do them. I'm ready any day you want.
I'm in the development of opening some really important things in my journey.
That's wonderful.
And about you, we have talked about synchronicities, and I told you about the synchronicities around my the saying goodbye to my mother.
Right.
And the signs that I can more speak about what I am seeing and opening, and they are abundant, and it seems to go to a certain point, to a certain opening.
Yeah, I had one I had one about 3 days ago. Me and my girlfriend were watching a video about Nickelodeon, the American cartoon children's television network.
Yeah.
And we were watching a video about Nickelodeon and its name, Nickelodeon. And we were taught something for the first time. It was very interesting. Nickelodeon means a short film theater, a theater that only airs like short films, not like hour or 2 hour long films, but half an hour, 10-minute films. the theater that would air these things was called a Nickelodeon.
Okay.
And it was because it only cost a nickel for the price to see the film.
Yeah.
And here's one synchronicity. We were taking our lunch break together at work because we work together, which is very nice. And we were watching this video about Nickelodeon and stuff like that, and we go in. We the end of the lunch break happens, and we walk inside the offices, and we say, "Hey, there's a new person who just got hired," and we say, hey, Jonathan, what's your last name, Jonathan? And he says, my last name is Nickel. And I mean, it's just unbelievable that we spend half an hour watching a video about Nickelodeon and nickel and all this, and then a new person gets hired at work, and we say, "What's your last name?" And he says, "My last name is Nickel." And it's just, these things just happen, and it's beyond belief. It's incredible. It's amazing.
Yeah.
I mean, what is this world? I really don't understand what this world is, because things like this happen, and it's beyond explanation.
Yeah.
I love it though. I really love it.
Yeah. I love it too. I have a lot of synchronicities happening, and it's at least it encourages you. It provides also kind of the universe witnessing you, right?
Yeah, and at the same time, I feel like I'm sharing too much personal details about my own life when I say these things.
Yeah.
Or I should just keep it to myself, or keep it in the sink tank, or whatever. And I have regrets about sharing too much about my personal life in different servers. But at the same time, it's like, who cares? Whatever. Who really cares? It's more just some sort of paranoia about the future. But
Well,
I don't know, man.
I agree with you. I also feel very uncomfortable sometimes. Luckily, I have some people that are very opening for the sharing, but it is kind of it can give a feeling in a conversation that you're showing off, or it's for you. It's your sign. It's not for some. It's not always for someone else. But
right.
On the other hand, telling about it, that it happens, and showing it a little bit is can be a reward for others, right?
You're absolutely right, and that's why I do it. Yeah, you're absolutely right. Yeah, it's a balance. It's a balance, absolutely.
Yeah.
There's a positive and a negative to it. I would, after all this time of spending time on Geo's server, where all the time every word we speak is being recorded to YouTube, I say, I'm not sure. I mean, I'm voluntarily doing it. I know that I'm being recorded, but I don't know. Sometimes I wish I wasn't being recorded while I speak to everyone.
Yeah.
Just wish it was more private. But I know I voluntarily involved myself in that. But then I don't know. Sometimes I might say too much or say more than I think I should have said when I reflect on it. I say, "Oh, got a little too personal there," or whatever. And there's upsides and downsides to it. But well, it is what it is. What's done has been done. All that's left to do is just live your life and be better. And all I can really hope for is that no one in the future, brings up some past quotes where they it'd be really funny. But if I had some sort of enemy, right? If I had some sort of enemy who wanted to make me look bad, they might watch every episode of Geo's Earth Awakenings live stream and find, whatever sort of stupid things I've ever said, to try to make some sort of frame job or.
Well, at most there are about 400, maybe sometimes 500 views at most. So
yeah, but
do you have
overall,
do you have a lot of enemies, Van Deel?
I'd actually say I have about 1, 2, 3. I got about 3. I have 3 enemies.
Wow.
Yeah, not that it's mutual, right? I have nothing against them. I would never want to harm them, but there's about 3 people I know who might have an interest in, I don't know, ruining my reputation or something like that.
Yeah.
There's about 3 of them that have an impact.
The more vocal you are, the more enemies you gather. Yeah.
Yeah.
To break the paranoia just for a moment, what's that new rocket button at the bottom of my phone?
Paranoia. That's pretty funny. Those are little side video games you can play with each other within the Discord app. But it's not paranoia, by the way. You don't know who I'm speaking about, and these people will take action.
Oh.
But it's okay. Yeah, it's fine. You don't know who you're talking about. It's all good. But yeah, the rocket button is little in-app community multiplayer video games that you can do if you feel like it.
The other question is, whatever happened to Bandsaw?
That's a whole different question. Way to sidetrack it. He's been gone. We haven't seen him in a while. I have no idea where he's been.
I asked Gio about it and in a DM, and he said he wanted some time off, and I know he had made plans to go to the United States with his wife as well.
Did you see what happened in France earlier on?
What do you say, Connors?
Did you see what happened in France earlier on with the riots because of the change of age from 62 to 64 for the pension?
No. Is that going on?
Burning cars and smashing everything. Riots in the streets.
Is that going on today?
That was I watched a video earlier today, and it was he was showing something that was 13. So it's probably yesterday. Yeah.
Oh, okay. So it's a further riots in the yellow vests.
I didn't see any yellow vests in the video. I just saw people rioting.
Yeah. Okay.
Yeah. And other banks having issues around the world too. Yeah. I'd stock up on some canned food. just slowly. Every time you go to the supermarket, just buy like 5 extra cans of food that you don't need, and just every time it's just a little bit extra money. Just do it, and just every time you do shopping, it's all going to add up, and you're not really going to notice a big spend, and you'll eventually have a stockpile of food at home just in case. Because if they did a ram on the if they did a food shortage on the supermarkets or whatever, it's like the shelves would be like cleared in hours, and there'll be no way for you to get food. That's not paranoia. Because I definitely know who those people are, and those are the ones pulling the strings, right? And it's in your face, isn't it? it's it's inevitable.
Yeah.
What was it? It was at Nigeria or somewhere. They were trying to go to the digital currency, and everyone said no. And then what they did was they just shut down all the ATMs, so they couldn't get cash. So they just went around and just smashed every ATM that they could find, rioting. And yeah, they're definitely trying to get rid of cash, the entire world. All the drug dealers, I don't know what they're going to do, because they do stuff for cash, don't they? When drug dealers get pissed off, they're the only other option is crime. What country are you in?
I'm Holland, and Fundy is United States.
And how's your economy going?
I'm not very. My talents don't lie in on the money side. I have no idea how it's going. We have had a provincial. Yeah.
Do you ever go to the supermarket and people say, "Oh, fuck, that's expensive"?
Well, there are some goods. I noticed that every time I Fundy,
someone's hot micing.
Fundy, you are hot micing. Did he fall asleep?
Someone's snoring, or maybe it's it's like a shaver. Someone's having a shave. No, that's a snore.
He's falling asleep.
It's only 9:54 in the evening. What's going on? I don't know. I can't mute him. Don't have those privileges.
I have muted them.
If this was a casino, I'd have a platinum card, which is the highest card you can get. When you go to the casino and you get VIP privilege cards, and you get to like go up to another level, up to another floor, like for members only, and that's where you can play like really big money, like massive money, like 50,000 chips, that sort of stuff. The only way you can get that platinum card in the casino is if you've spent a lot of money in the casino.
I have never been in a casino. Never, ever.
I have, and every time I've been, which is only a handful of times, I only spent $20, and I always came out with more than I went in. So, because I left my card at home, just took a $20 note. But I've been with other people to the casino, and I've been to the high roller members only rooms and seen how they lose their money. It's just crazy, you know. It's a brave addiction.
I have to give attention to someone who can't join the VC, Carlos.
No worries. You can do what you have to do, man. Those two drunk guys earlier on, who was it talking about the buildings and they build them level? And Ruhif was like, yeah, there's no way that because you can build a building really flat and level and straight and everything that's got anything to do with the shape of the earth. It's just crazy. I mean, yeah, I'm a flat earther, but that's just drunk talk, you know, because as Ruhif was saying, what's the tolerance and the angle that would be out? It's like absolutely nothing, you know, over a little house or even a building, even a mega Costco. It wouldn't really matter, you know. You know, it's got absolutely no relevance whatsoever to do with the curvature of the earth in architecture and building. You can have a wobbly house. It doesn't matter. It's still going to stand still. It's still not going to move. I mean, fucking hell. Japan makes skyscrapers that go through amazing 9 level on the Richter scale earthquakes, you know. I bet that puts the building out a little bit and makes it a bit fucking unlevel every single time there's an earthquake.
Yeah, you know, Carlos, when, for instance, a rail line is built, the landscape varies in height very much more than any curve can be a challenge. Most challenge in laying the rail line is in some up and down on the surface.
Yeah. I mean, that's an old like wives' tale that railway lines have to be made dead level, flat, and straight. No, they don't. They can go like those toy slot car sets. They can do fucking loop-de-loops and corkscrews like a roller coaster. Not a problem.
Yeah. I looked at a piece of rail line from 500 meters just outside my hometown, and it is going up and down.
Well, you think about in the olden days when they used to make railways, do you think they had any technology at all? They had no technology at all, and they were making railways all over the world.
Yeah.
They didn't have to be flat and level and straight. That's just an old wives' tale, isn't it? But what I do believe, and I'm not a Christian, but I do believe that this place is
I really have to look into something, Carlos. Sorry. Gio, are you there?
Bonjour, bonjour. Mic check. Mic check, mic check.
You are heard.
Oh, I had to switch phones. My other phone just died, and how rude! Right in the middle of my sentence. Yeah, I was saying. What were we talking about? I said I'm not a Christian, and I said that I do believe that what we see in the sky are divine and spiritual in some type of form or fashion, and I do believe that ambient light and the light that is emitted from the sun are two separate things. So I think that the sun it's a special radiant type of holographic rainbow construction feature that's some type of a projection or reflection or a point source. It's an apparent entity which is it's not able to be measured and pinpointed to a specific distance and location. It's there, but it's there from your own personal perspective, and the ambient light that we have comes first, and the sun is always following that sort of a border or a rim of the ambient light, which is flowing over this place like a river in a constant stream, day after day, the same motions every day, and that light has some relationship somehow with the ether, which has its own sort of a interaction with the medium where we live. This place is more like a realm, and I think, even though I'm not a Christian, I do believe that this place is spiritual, and there is a thing such as opposites, good and bad, and there's a middle ground, and that's where we have to always aim for, is the middle ground, because as soon as you become too confident, there's always going to be something that tries to bring you down. So if you're stuck in the middle all the time, and you can be happy with your thoughts, this place is not supposed to be discovered. This place is the way that this place works is eventually the veil will be lifted, and we will see it. But why should we be any more special than the ancestors that came before us? Why should there's Christians out there that think that Christ is coming back and he's going to save the day, and there is a spiritual war, but I don't believe it's a spiritual war between these two definite entities which can be named. And unfortunately, there are people in this realm who take advantage of the knowledge that they have of these realms and of what they've discovered. Like they've discovered more than they would ever let us know, and that's how they can control us.
Yeah. What you say about the sun, I too believe that that personal dome around us creates atmospheric lensing.
Do you think it was created in such a way so that we're not supposed to find out? So that it's always going to be a mystery, or do you think, like, from a Christian's kind of a standpoint or point of view, that maybe this place is ruled by that so-called Satan or the devil, and this character is so clever that he's been able to he's so cleverly been able to make it so that we're just never gonna get it. You know, we're just never gonna understand it.
Well, I believe that if we would know everything, Carlos, that is a rather heavy situation to go on. Then you have nothing left to gain or proceed on. If you know everything, it's time to go. There are no more riddles.
It should actually be really straightforward and simple, you know. If you're trying to make a measurement of something and find out the size and shape and dimensions of something, the only thing that we don't know and can't prove is the shape of this world.
Well, I don't know if we can't, but
why can't we? Why is it so difficult?
Because of that measurements are not everything. The atmospheric lensing can create so much different effects depending on the direction of the light, the amount of water vapor, maybe other substances in the atmosphere, and then the fact that the surface reflects the light into the thickest layer and things like that.
So in reality, the only way to really find out is to get to a high enough altitude to have a bird's eye view to see what's really going on. And unfortunately, the ones that are able to do that are lying fuckers.
But I think you can't get high enough to really see it, Carlos. With all the images we have seen from high altitude balloons. I don't know, because we have that expression of Picard, that he looked at the world and it looked flat and curled up at the edge, but that can be a visual that can be a visual understanding, a visual image that
put
he
it this
paints.
way: why don't we just trust that all of the information they tell us about the world coming from NASA, for example, just only NASA alone? They're firing stuff out. They're doing orbits around the planet. They've got a 24-hour live stream of a ball that they're orbiting around. So why don't we just trust them? What is it that we don't trust about what they're doing and saying? I mean, surely isn't that enough evidence? Why should we doubt them?
Because of common sense.
Men are liars, don't trust. So you see, there is a great deception, and there is some type of a religious truth to the way that we have distrust. The reason why we have distrust is because we know that there is a deception. It's more than a gut feeling. It's definitely more than a gut feeling. It's it's, yeah, like you said, it's common sense. It's refined discernment, and You know, if you've lived long enough, you can you can spot bullshit a mile away, can't you? You don't have to know all the facts and figures and fine details. You can smell bullshit a long way away. You know, what would make you so crazy to think that the Earth was flat when everybody knows it's a ball? You must have gone through some absolute mindfuckery of some type of a hypnosis session or something. You know, what is it that makes you go, no, I don't trust them?
Yeah.
It's all the little pieces of the puzzle, isn't it? The little tiny pieces of the puzzle. Those little bits of information that give you doubt, like the footage from the ISS and what everybody points out. That's a big giveaway straight away, isn't it? That's probably the biggest giveaway, isn't it? It's like, why would they lie? What for? It's like you're an animal in the zoo and you don't know that you're in the zoo. It's like you're a frog in a pot of water, slowly getting hotter and hotter and hotter, and you don't realize that you're gonna get fried, pacified, fluoridated. So, are you a Opa yet?
What did you say, Carlos? I was.
Are you an Opa?
An Opa?
Yeah.
What is an Opa?
I thought that meant granddad in Dutch.
Yeah, I'm a granddad. Yeah.
Opa, what's your name?
My name is Lex van de Oudewetering. I'm Lightwater.
Oh, so you're a Opa Alexon.
What?
Alexa, did you say?
No. My grandchild is called Pip.
Okay. Well, that's lucky. It's good to have another generation. Are you worried about them in their future?
No, I'm not worried for anyone else.
Everything always works out, right?
Yeah, whatever it is, we have to face the world, and they have to face the world.
It'll work itself out. It always does, right?
Yeah. And probably it will be a surprise to everybody, Carlos.
Yeah, and we'll have to go around wearing a T-shirt saying "I told you."
But you will have to wear a T-shirt under it that says "I didn't know that." So I try to stay humble in that category. I sometimes think I was fooled once, and I don't mean it as very heavy because I know my limitations. I was fooled once, and I can be fooled again when I discover flat Earth, and now I call myself. I put the red pill on top of me, and and say that I have truth and things like that. I have a piece of the puzzle. That's all.
I'd say you should be proud to know that you have an inquisitive mind and at least an effort towards refining your discernment. You know, because at least you're trying, and you're not just giving in to to what other people say. Some of the greatest minds in the world, they stand alone. They go against the grain.
Yeah. And I think thinking that you are special is very important, but at the same time being humble with it.
Yeah, exactly.
Yeah.
Don't be too cocky because you might be wrong.
Yeah.
Yeah.
And sometimes it's very difficult for individuals who are very vocal because they catch a lot of attention from other views, right?
Sometimes I miss the days of before the mobile phone. You know, remember those days when you actually used to have a life, and you'd do stuff.
Yeah, remember the times that you are walking in the forest and you are not interrupted with somebody who seems to talk to themselves, but when they come nearer, they have a mobile.
Yeah.
In the middle of the forest on their walk, they are still connected to the outside of the forest.
Unbelievable. You're taking a walk in the forest, you should be, grounding yourself and at one with nature for that short amount of time before you have to go back to the slave job.
I'm mobile while mobiling.
Crazy. Yeah. People don't know how to relax anymore, they just, I've seen people lying on the beach with their computers doing their office work.
Yeah, I don't know if it is somehow, it is a kind of relaxation to connect with others constantly, and I don't understand it, but
well, I guess this format, this type of channel, the content, the actual the topic of this server is really there's not many other places that I can think of where I can go, unless I just haven't really looked around to find anywhere else where you can, free speech is such an important thing, and philosophy is it's a dying art. It really is a dying art, and I think this type of channel is bringing back philosophy into the minds of the people, because without philosophy there is no thought. And without thought, you just have mindless minions with calcified pineal glands, So much to know in this world. Can't know it all.
No.
At least you can come to a place like this and listen to all sorts of knowledge and you'd think that some of it might stick into your brain, at least the important parts. You know, you can learn something every day by hearing what other people have to say. They might slip in some good knowledge here and there. You're not going to get that by listening to the mainstream radio or the news, you know. A lot of people, they live their life every day. They wake up and they read the newspaper. That's what they do. That's how they live, you know.
How's your business going, Carlos?
Yeah, it's going good, and I'm opening up a second business now, do the same thing, but a bigger one.
Okay.
And trying to sell the first one so that I can help fund the second one. Yeah, that's how it is. But, yeah, it's promising. Promising. It's very interesting. You know, the concept of my store is like a vending machine, yeah?
Yeah. I saw it.
It's a vending machine, and I'm still amazed. I'm still amazed at the amount of people that come in because it's all on closed circuit. It's on CCTV, so I can. That's the only way I can see the front of the shop anyway is by looking through the camera, looking at the screen, and people come in constantly all day long, and they're just filming and recording and just going, "Wow, what is this?" I can't get over it. It's really, for me, it's so simple. It's just there are no people in the front, and you order from a screen, and the food comes out a box in the wall. It's like, and people come in and they're like, "Where does the food come out? How does it come out there?" And they're just like amazed, young and old. It doesn't matter, not just students, but like every type of person. Is it's unbelievable how many people bring their phone out and start recording and post it on Instagram, I imagine.
Yeah.
And for me, it's so basic. It's for me, it's not special at all. It's like, what's the difference? It's just there's no person like talking to you. Instead, I don't know. I don't see why people. For me, it seems like people are quite stupid. Actually, a lot of people are pretty dumb. You know. But it's good that they find interest in it. They're really excited about it. It's the way of the future.
You believe in the awakening, Carlos?
The awakening. I think the awakening has been happening for a long time. It's probably been. What is the awakening?
Yeah. I'm experiencing a lot, and I have I have a lot of synchronicities and visions and things like that happening in my life, and part of it is that it shows that I should keep all it for myself, but I'm getting images in these synchronicities as well as that I am on my way of reaching a certain point that I can open up more. Maybe not here, but somewhere else. What I experience is that we are not only flesh, but we are also electrical, magnetic, and in that change, there's a lot of uncomfortability in it because of changing of certain frequencies and things like that.
Well, I've got two things I was just thinking of after you said that. One thing is that I saw on YouTube in China, someone showed how you use your remote control to unlock your car, you know, and then you go out of range and you point the remote at your car and it doesn't work anymore because you're too far from your car.
Yeah.
Right. And then you point the remote of the car that you're holding in your hand, you know, there's what's it called, a car fob.
Yeah.
You point it at your brain, and it unlocks your car. When you're out of range. And I thought, well, that's fucking bullshit. And today I tried it, and oh my god, it worked. I'm not even joking. So like I was totally out of range, and it wouldn't lock. It wouldn't make anything happen to my car. I put it up against my temple of my head, and I pressed unlock, and it fucking unlocked my car. I couldn't believe it.
The funny thing is, Carlos, in Dutch, your name could be seen as the car is open.
Yeah. And I forgot what the other thing was. Oh, that's right. You're talking about synchronicities. Yeah, I used to have deja vu like once a year, or not even once a year. It's hardly ever deja vu. You know what deja vu is, yeah?
Yeah.
And now it happens almost every day.
Okay.
I can't believe it. It's like this has happened before. And I can recall, like, I've met one person and I spend like 2 minutes with them, but then I can remember not just the 2 minutes I've spent with them, but I can remember full-on conversations and experiences, and the understanding that I've spent a lot of time with this person and experienced a lot of other things with these people, way more than those 2 minutes. All sorts of stuff I can remember, interactions with this, for example, just one person, just so many interactions with this person, and and I try to think, where did this come from, this information, this memory? Was it in a dream, or did it actually happen, or has it not actually happened yet? It's fucking weird. And I'm getting like these there's deja vus almost every day now. It's crazy.
Okay. And do you like it, or that's happening?
For me, I don't know. It seems like there's, like you were saying, the energy and the frequencies and the synchronicities. There's a lot of things that are changing. You know, there's a lot of changes, and there's a lot of realizations and things that are opening up and unveiling and showing themselves, and a lot of truths coming out. And
Yo, what are you guys talking about?
Yo.
We're talking about what we're talking about.
What are you talking about?
We're talking about like the way that this world is changing, and there's a lot of things that people are noticing, like more synchronicities in your daily life.
More what?
Synchronicities like deja vu and how to explain. You know what a synchronicity is, yeah?
Yeah. That's a very broad word. Like, what is it that's being synchronized?
It's like when you bump into somebody, and it's like you haven't seen them for a long time, and then it's like you end up like doing, like, having the same direction, or like things that are more than a coincidence.
Mm-hmm.
Seems to be more than a coincidence.
And then they start to show a pattern, and yeah.
Things are ramping up, you know. It's like the speed of technology, you know, it doubles every 6 months, so they say. It's kind of like there's a consciousness, an opening in consciousness where some people are able to sort of catch the flow of the new of the awakening. There's some type of an awakening for sure. I don't think that everybody gets it. You know, there's a lot of people that are still 9 to 5 and you know, into watching sports and reading the newspaper and 6 hours of TV every day. You know, so that's probably the majority of people. You know.
So you guys don't watch sports?
Fuck no.
I do
I
sometimes.
don't.
You watch what, like what?
I do sometimes look at football and
Yeah, because I mean it's entertaining. It's fun. It's not to say just because you watch sports, all of a sudden you're blind and you're not aware of the ways of the world. You know, it's just
Yeah,
sports.
but when I watch sports, and in the past when I've watched it, I can't stop thinking about the commercial aspect of the sports and the manipulation of the sports and the propaganda that the sports are there for, and the advertising that comes with it, and you know, the lies and the deception, and the whole reason behind the sports in the first place is to take your mind off, you know, what's really going on in the world, and it's just
It's to
so
take your
fake and
to take your mind off of
materialistic.
work and the stresses of life, right?
Yeah, but this is why I come to this channel. You know, this because when I look at things like sports,
Okay.
I know the reality of what's actually going on, and that's why I don't like. I'm not interested in sports because I know what it's actually all about. It's there for the minions.
Yeah, but someone could know what sports is really about and still enjoy it, right? And instead of coming to Discord to get away from life and stuff, they could just watch sports, right? But they know about the advertising and the deceit and the money involved and the corruption.
Yeah, I mean, if you're
But
just watching
you
it
know,
with a
they still love their hometown team and they enjoy, you know, having a cookout on a Sunday with friends and family watching sports, right? There's nothing evil about that, is there?
it's not. I never said it was evil, but
I didn't
like
say you said it was
the,
evil. I
the,
was
the
just asking
people
a
playing
question.
the sports, maybe they are very genuine and they're interested in it as an athlete, but I don't appreciate as much as I should, because my mind can't get away from the idea of everything else that is bundled up with those sports, and it's kind of everything else makes it toxic for me.
Yeah, I mean, if you don't enjoy it, that's fine. But I'm just saying, there's nothing wrong with other people enjoying it.
No,
Like,
no, no. But
there's nothing
but
inherently
when
evil
I
about
when I
sports,
see
right?
people that are addicted to watching sports, it kind of makes me think that those people don't consider the bigger picture.
Can someone not be addicted to sports and still consider the bigger picture? That's not
Mm,
possible. I can't support my hometown team, but still know that the people that own this team, you know, the billionaire that owns it, is part of the world controllers and he's evil and whatnot. But you know, this is my hometown team. I grew up here. I got friends that play for this team. My father's rooted for this team. Like, you know, it's just a family tradition, right?
Oh, okay. So yeah, if you're talking on an extremely local level, yeah, I can see the enjoyment in that,
Even like
and it's very
international team.
patriotic. But I'm thinking more of like big time international, like Super Bowl. If you really look into the Super Bowl, you can see so much. It's like overshadowed by Illuminati, um, uh, what programming. You know,
Super
there's
Bowl
a
is
lot of
evil?
what does it mean?
Is the Super Bowl
Superb.
evil?
Super Bowl means superb owl,
Ah, so it's
right?
like evil.
You spell it different. You spell it the same way, but it means superb owl. What's that? Isn't that a sort of like a reference to, you know, to
So Super
Satan?
Bowl means supreme power?
Superb owl.
Superb owl? What's that?
Super Bowl. You spell it the same way, but you separate the two
The
words in a
subreddit.
different spot.
Oh, it's like wordplay. Okay.
Yeah, it's like they go to those, you know,
It's just
secret
posting
meetings.
pictures of owls saying, "Isn't this one superb?" But,
They worship Magog or whatever, the owl, you know, in their special little meetings that they go to. The Bilderberg group.
Mm-hmm. So wordplay makes the Super Bowl evil.
No,
Because
it's
Super Bowl and Superb Owl have the same letters used to spell them. The Super Bowl is evil.
everybody has their way to relax, I guess. If you're into watching sports, go be my guest. But for me, it's sort of like it's the difference between being a juvenile and a young adult. You know, that when you become a young adult, you sort of lose some of those inclinations to play with dolls, and you don't want to play with dolls anymore. You know, you want to play with the adults'
So
toys.
what do you do for fun? Like, do you have hobbies?
I
You know,
work.
stuff you do?
I
Yeah,
work
but
about.
like outside of work, like what do you do to like release stress? Do you have any
Uh,
vices?
yeah. I go and enjoy nature. Yeah,
Yeah,
yeah.
that's all.
Uh,
You just you,
I
you just
go.
you just you just go for walks.
Yeah. Well, or sometimes I go and play some tennis, or sometimes I spend some time with my family and go for drives. You know, go for a nice
Nice.
drive in the countryside.
So if I spend time with my family watching football, or if I'm playing football with my family, or if I'm driving with my family to the arena, which is in like maybe upstate, so it's like a 4-hour drive. Like we kind of doing the same things, right?
Yeah, I mean, absolutely. If you're enjoying time with your family, I'd say do
Yeah,
it. But
yeah.
for me, if I
Over
had the
sports,
choice to take my family to go and watch some sports or spend some real time with my family that, you know, is meaningful, I'd probably want to go to the beach, spend some time with my family at the beach rather than, you know, in an arena with like all of the hype and you know, I don't mind noise. I'm not afraid of noise, and
yeah.
I
I don't
don't
know. It just sounds like we do the same thing. Yeah,
pretty much. Yeah, it
yeah.
just
Pretty much,
depends
which is cool.
where your mind's at. It's like some people are on a mature level, and some people are immature. And for me, watching sports is very immature.
All right, that's cool.
It's just like the difference between, you know, a scholar and a prophet.
Hmm.
You know,
And which
you
and which
can.
one are you, the scholar or the prophet?
Well, I I I would I would hope one day in my next life I can be a prophet. At this stage, I'm a student.
All right,
Yeah,
student that doesn't watch sports. That's cool.
yeah. I used to play sports. I used to get medals and I used to get my name in the newspaper. But you know, once over time, my mind has become more um wary of all of the baggage that comes with many aspects of the things that we interact with in this world. Like I can read between the lines, you know. I have like a filter where I can see, is that really worth it to be involved with that, or would I be able to, spend my time sort of doing something more useful?
I'm kind of with you, Carlos. I don't watch sports, but I do see the point that Chirality's making about, like, it's for me, I have some of the same thoughts, but then I think that's just down to the bias that I wasn't good at sports as a kid. I didn't get into watching them, so I don't really care which team wins and loses. But I can absolutely see how it'd be a fulfilling thing to go and, like, watch a team with your son. You get painted in the colors. You get really excited when they are up, and then you get really sad when they lose. And that's something you do together. And that being a sort of bonding thing, a kind of tribalistic, we live on through this, the meaning of this club kind of thing.
Yeah, for me, it's more of the mechanics of the way that the social system is, and for me, sports are just one of those things that ties you together with the heliocentric model.
If you look, do you think sports is all about the globe? There's no sports on a flat Earth. That's the dumbest shit I've ever heard.
The way that sports are presented to the societies, it's all part of the system. It's not there. It's not an innocent interaction with the society. There's an agenda. There's definitely an agenda, I'd say.
Jesus.
And it's part of the
nothing in society. Everything's just an agenda, huh?
It's part of the pacifying of the people. It's just one of the aspects of the way that the system is able to pacify the people. You know how much time and effort, how much time is soaked up by sports in the minds of the minions every day. If that amount of time was just spent doing something more, I just, sorry, I'm not too fond of it. Yeah, I don't have the words to express, really. All I can say is that it's, for me, sports is no way to an enlightened future.
Yeah. Because the only reason I defend it, like I said, I don't really watch or care about sports, is because people say the same thing about computer games. I love playing computer games. They're all like, couldn't you be doing something better? It's like, yeah, but we could always be doing something better. It's not a reason to not do things you enjoy. And I think there is something cool in sports about watching humans at the absolute peak of physical performance. Like, that is, you go, that's a fastest
I
runner
don't
in
think
the
there's
world.
anything wrong with watching sports.
You watch Ronaldo and you're like, he is just legitimately really good.
I think sports are good and beneficial to society and to humans, They promote competition, they promote health, they promote teamwork, collaboration, community, they provide jobs. Like, I don't see what's wrong with sports.
Yeah.
Yes, they are over commercialized, There's more money than what's needed in sports, but at least at an amateur level, it's vital to have a functioning society. I can't think of a society that never had sports, or civilization.
I guess I see a lot of drunken, sort of like losers a lot in my country, and they're kind of like these thick petrol heads that are just like very low IQs, and it's really put me off on this type of a culture. It's a culture on its own. It stands out. It's for me. It's degenerating to the brain just to think about it. It's like, if I want to watch a sport, I would rather watch the America's Cup, and you can see the technology that's gone into these fucking amazing crafts, and you get the the computer animation that is mixed with the real life video, and you can see the course and how it's plotted, and it's more intellectual. That's if I was going to watch sports, I'd rather watch something like that, because it's not a mind-numbing fuckery of a drunken waste of time.
I kind of agree. I also think, like as Kyrality was saying, as money's gone into it, I get the idea of supporting Arsenal because you're from Northwest London, and the players are like the guy who's the bartender from your local pub, and the goalie's your sister's boyfriend or something, because they're all from the local area. But we're like, when half of them come from South America, it's like, are they really the Northwest London team anymore? Like,
Yeah.
we're the guy who owns the stadium.
Yeah, so I'm not totally against sports, but I'd rather just, put my time to better use, because it's very important that I look after my family, and I don't get to spend as much time as I wish I could, and I wouldn't want to give them an experience. Yeah, take them to one game and just so they can say I went to a game and I know what it's all about. But I'd rather take them to somewhere where or do something with them that they're going to have some meaningful sort of afterthought, and it's going to be useful for their um for their learning.
Yeah, I mostly agree. Go somewhere where you can learn something new and you can discuss it afterwards and expand your mind. It gives you more things to be curious about. Whereas, when dudes in pubs try to talk to me about sport, or like, not really, because they talk to me and then I'm like, yeah, I don't really watch it, and then the topic changes. But if I hear them talking to one another, I'm like, I can't imagine caring about this. And I'm like, oh, they fucked up. They changed their goalie. They should have blah, blah, blah. And you're like, oh, my God, I don't care at all. I don't understand how you care at all.
The amount of money that you'd have to spend to go to a sports game, it's like I took my children to go to a bird sanctuary with all of these exotic parrots, and you get to walk into this place and the parrots climbing all over you, and you can hold them in your hand and feed them, and they're all different sizes, and that type of thing is it's a really good worthwhile way to spend your money with your children, and they can experience something that I mean, where else can you have like 100 different types of parrots of all different sizes? You're not going to get that in an arena. It's probably a waste of time to compare these things, because they're not. But I'm just saying, it's like there's so many things that you can do instead of mind-numbing stuff. It's okay to get drunk even now and then, and
it's good to enjoy that, Carlos. But imagine that all those football people took on that idea also at the same time.
Yeah,
it wouldn't be fun anymore. So be happy. So be happy that they are at the football game.
Probably people that go to the sports on a regular basis, those big games and stuff, they wouldn't be the type of people that would come and talk philosophy on a channel like this.
Yeah, but people are different. I mean, you can't expect everyone to want to like what you like, Hollis.
People are
people
different.
would call
There are
you
two
a
types
nerd
of
or a
people.
dweeb because all you want to do is come on Discord and debate philosophy and stuff. They would tell you
Yeah,
that what you're doing isn't productive because sitting here on Discord is not really contributing anything to society. Like it's people like what they like, bro. Like you can't be so critical of someone just because they like sports.
yeah. I really talking about myself. It's hard. I really hope you don't think that I'm put like I don't want to put anybody down. Like people are on different life paths. You know, people are at different levels, and I I just it would be good if more people were sort of like interested in philosophy and that type of thing.
Yeah.
I've got to
Yeah,
shoot out.
I mean, philosophy is interesting. You know,
I'll
it's
probably be back
pretty
soon.
interesting, but you can only philosophize so much, right?
Yeah. Well, you guys, I'm gonna just pop out for a while. I'll be back soon.
Hey, what's up, Harry? Are you still like
Hey, man.
traveling the world? Or
Yeah, I'm currently.
you where? Harry?
Kalashnikovs putting on their sirens to get us through traffic.
Oh. Are you in Australia right now? Or?
No, Pakistan.
Oh. Oh wow. All right. Nice.
Yeah, they think they're worried this is not a safe area. So for the last 2 days, we've had police like we're driving behind a Hilux and they just drive us to the next checkpoint where another Hilux comes out and escorts us the next bit of the way. And this is probably like our 15th police escort.
Yeah. All right. Like, is what you guys are doing like linked with some like TV program or something? Why all this security?
I think it's just the Pakistani government's worried about the PR if we get kidnapped or something, because like Pakistan's got out of control inflation at the moment, and whereas we are, there's problems with terrorism, but here it's just mostly people are really poor, so they're like theft is pretty high. So yeah, we've got these like commando guys wearing red berets escorting us through. But yeah, we're just travelers. Like we're filming it with GoPro. It's nothing impressive.
Alright. So from Pakistan, which country will you go to next?
Oman, then Saudi Arabia, Jordan, and Israel.
Nice. Is there a reason you're going to these specific countries, or
They're on the way to London.
okay?
Like we're still kind of picking them. Like we could have gone from Pakistan. We could have gone the North way, which is what a lot of people do through Tajikistan, Kazakhstan, the Stan they call it. But I quite like Italy. I've got some friends there I want to visit, and Liz is really curious to see Petra. I'm curious about the Middle East. Like, yeah, the whole area is very interesting to me.
Mm. Yeah, it's pretty beautiful. That's cool though. So is London like the end destination, or from London you're gonna take the same
What
path
about
back?
you? What's news?
Say what? What did you say, Harry? Guess he's gone.
Damn it. My connection's gone shitty. I'll just have to listen till it gets better.
Okay, all right.
Just what we need. Puncture ho gaya.
Say what?
Sorry, I'll have to mute myself. I've got a puncture. Shit. That's like the fourth one in 2 days.
Jeez.
Sorry. See you guys. I'll be back in a bit.
Some spiky eggshells there.